10 GB ಇದರಲ್ಲಿ 9.1 GB ಯೂಸ್ ಆಗ್ಬಿಟ್ಟಿದೆ. ಹ್ಮ್ live on YouTube, but with a delay. Is being live. But it is delayed. ನೀವು ಇವಾಗ ಗೊತ್ತಾಗಿದೆ ಇಲ್ಲಿ ಯೂಟ್ಯೂಬ್. ಇಲ್ಲ ಯೂಟ್ಯೂಬ್ ಯೂಟ್ಯೂಬ್ ಲೈವ್ ಸ್ಟ್ರೀಮ್ ಆಗೋದಿಲ್ಲ. ಝೂಮ್ ಅಲ್ಲಿ ಎಷ್ಟು ತುಂಬಬೇಕು ಅಷ್ಟಾದ್ರೂ ತುಂಬುತ್ತೆ. 250 ಪಾರ್ಟಿಸಿಪೆಂಟ್ಸ್ ಪರ್ಮಿಷನ್ ಇದೆ. ಯೂಟ್ಯೂಬ್ ಲೈವ್ ಸ್ಟ್ರೀಮ್ ಮಾಡ್ತಿದ್ದು ಅಕಸ್ಮಾತ್ ಇಲ್ಲಿ ಎಕ್ಸ್ ಯಾರು ಬಂದೇ ರಾಕೇಶ್ ಇಲ್ಲ ಸಂಜೇಶ್ ಅವ್ರ ಹತ್ರ ಇದನ್ನ ಕಳಿಸ್ಬಿಡಿ, ನೀರ್ ಬಾಟ್ಲು. Hi, do share the link on which I have to join.
Join ಆಗ್ತದೆ ನೋಡಿ.
ಸೊ ID ಪಾಸ್ವರ್ಡ್ ಹೇಳ್ತೀರಾ ಒಂದ್ಸಲ? ಅಲ್ಲ ಇಲ್ಲಿ ಒಬ್ರು ಕಳ್ಸಕ್ಕೆ. ಹಾ ಪಾಸ್ಪೋರ್ಟ್ ಎಲ್ಲಾರು ಬರ್ತೀವಿ ಅಂತಂದಿಯಾರಂತೆ. ಆಶೀಶ್ ಕಪೂರು, ಆಶೀಶ್ ಎಲ್ಲಾರು Yes. Hello. 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 Hello, Anshul. ನಾನು ಸೇಮ್ ಅಸಿಸ್ಟೆಂಟ್ ಕೊಟ್ಬಿಡ್ತೇನೆ. ಹಲೋ.
Waiting room enable direct.
ನಾನು ಹೇಳ್ತಿರೋದು 20 ನಿಮಿಷ 20 ಸೆಕೆಂಡ್ ಲೇಟಾಗಿ ಕೇಳಿಸ್ತದೆ.
ನೀವು ಮಾತಾಡೋದು
ನಾ ಮಾತಾಡ್ತಿರೋದು ಇಲ್ಲಿ ನನಗೆ 20 ಸೆಕೆಂಡ್ ಲೇಟಾಗಿ ಕೇಳಿಸ್ತಾ ಇದೆ.
ಹೊರಗಡೆ ಹೋಗಿ ಮಾತಾಡ್ತೀನಿ ನಾನು.
ಅಲ್ಲಿ ಕೇಳಿಸ್ತಿದೆ ನಂಗೆ ಬ್ಲೂಟೂತ್ ಅಲ್ಲಿ. ಓ ಶಿಟ್, ಇದು ಯೂಟ್ಯೂಬ್. ಸರ್ ಯೂಟ್ಯೂಬ್ ಲೈವ್ ಒಂದ್ಸಲ ಚೆಕ್ ಮಾಡಿ. ಪ್ರಿಕಾಸ್ಟ್ ಇಂಡಿಯಾ ಅಂತ ಕೊಡಿ. ಹಾ.
والسيراميك
Good morning, everyone. So we have participants who are joining, and we'll start the session in another 5 to 10 minutes. Thank you.
Very good morning, everyone. Seeking the divine blessings of His Holiness Jagadguru Sri Shivaratri Deshikendra Mahaswamiji, respected Pro-Chancellor, Principal, Jesus Academy of Technical Education, Dr. B. Manoj Kumar Sir, Registrar Madam, and Summit Chair, Dr. R.S. Jagdish Sir, esteemed speakers from industry and academia, distinguished guests, faculty members, research scholars, students, and participants joining us in person and online. A very warm and hearty welcome to each one of you. It gives me immense pleasure to welcome you all to Precast India 2026, a one-day summit on accelerating smart and sustainable construction through precast technologies, organized by the Department of Civil Engineering, Jesus University, Noida. On behalf of our Honorable Chancellor, Vice Chancellor, Sir, Registrar, Ma'am, Dean, faculty members, staff, and students, I extend a sincere welcome to all our distinguished guests and participants. Today's summit brings together renowned experts from leading industries, premier research organizations, and academia to deliberate on one of the most transformative technologies shaping the future of construction. Throughout the day, we shall have the privilege of listening to eminent professionals who have been at the forefront of innovation in precast construction, building information modeling, digital twins, industrialized construction, and 3D concrete printing. We hope this summit serves as a vibrant platform for exchanging ideas, strengthening academia, industry collaboration, and inspiring our students and professionals to embrace the future of smart infrastructure. Once again, I warmly welcome all our esteemed guests and wish everyone an enriching and productive day ahead. Now I request the convener of the session, Dr. Ruchi Saraswat, Head of the Department, Civil Engineering Department, JSS University, Noida, to give a welcome speech. Over to you, ma'am.
Good morning. Thank you, Jyoti ma'am, for welcoming all. It's with the divine blessings of His Holiness Jagadguru Shri Shivratri Deshikendra Mahaswamiji. It's my honor to welcome you all for this AI Summit organized by the Department of Civil Engineering. It gives me an immense pleasure to welcome to all of you to the Precast India 2026, which is a one-day summit organized by the Department of Civil Engineering, JSS University, Noida. On behalf of the department, I extend my heartfelt gratitude to all our distinguished speakers who have graciously accepted our invitations and to share their invaluable expertise. The construction industry today is undergoing a remarkable transformations driven by the digitalization, industrialization, sustainability, and automation. Among these advancements, precast technology has emerged as one of the most promising solutions for delivering high quality, economical, and environmentally responsible infrastructure. As an academic institution, it's our responsibility not only to impart the theoretical knowledge, but also to expose our students and researchers to the latest industrial practices and emerging technologies. Today's summit has been designed to bridge the gap between the classroom learning and industry expectations. The participation of experts from Larsen and Turbo, SWICO, Adlak Associates, CSIR, CBRI reflect our commitment to fostering meaningful academia industry partnership. I am confident that today's technical session, panel discussion, and case studies will inspire innovative thinking and encourage collaborative research in sustainable construction technology. I sincerely thank the university management for their continuous encouragement and supports. My appreciation also goes to our organizing committee, faculty members, students, volunteers, and everyone who has directly or indirectly contributed towards making this event possible. I once again extend my warm welcome to all our guests and participants. I wish the summit a great success. Thank you, one and all.
Thank you, Dr. Chima. May I now request our esteemed session chair, Dr. Jagdish R.S., Dean Students Welfare and Academic Coordinator, Jesus University, Noida, to kindly address the gathering and formally inaugurate the technical sessions. Over to you, sir.
Thank you, madam. With the divine blessings of His Holiness Maha Swamiji, a respected Pro Chancellor, Vice Chancellor, Acting Vice Chancellor, Principal, Deans, HODs, faculty members, and the participants. It is indeed a pleasure to be a part of Precast India 2026. First of all, I would like to congratulate the Department of Civil Engineering for meticulously planning and organizing this timely and highly relevant summit. The future of civil engineering lies in innovation, sustainability, and digital transformation. Around the world, infrastructure projects are increasingly adopting industrialized construction methods that deliver superior quality, improved safety, faster completion, and reduced environmental impact. Precast technology represents precisely this transformation. However, technology alone cannot drive change. Its successful implementation requires collaboration among academia, industry, researchers, policymakers, and young engineers. Universities have an important role in preparing graduates who possess not only sound technical knowledge but also an understanding of modern construction practices and digital technologies. I am delighted to see eminent experts from leading organizations joining us today to share their practical experiences. Such interactions enrich our academic environment and broaden our students' perspective. I encourage every participant to actively engage with our speaker, ask questions, participate in discussions, and make the most of this excellent opportunity. I congratulate the organizing committee for their dedicated efforts and wish today's summit very success. Thank you to each and everyone.
Thank you so much for the inspiring words, sir. Your guidance will always lead us to the great success. Now it's time to start the technical sessions. But may I request everybody to turn on their cameras so that we can have one group photograph. Thank you so much. Now it's time to begin the technical sessions. Welcome back, everyone. We have Mr. Satyam Agarwal with us, who's senior engineer at SWECO. He will be delivering a talk on Precast meets digital, bridging BIM and construction reality with Tekla. I request my colleague, Mr. Bharat, to give a brief introduction about Mr. Satyam Agarwal to our audience, please.
Good morning, everyone. So it's my pleasure to introduce our first speaker, Satyam Agarwal, a BIM and structural engineering professional with over 8 years of experience in BIM coordination, model validation, and digital delivery. So Satyam currently serves as a senior engineer in SWECO India Private Limited in Gurugram, where he leads the BIM coordination and efforts across infrastructure and building projects, working closely with engineers, architects, and contractors to ensure accurate information exchange and smooth project delivery. So, over the course of his career, Satyam has built deep expertise across leading platforms, including Revit structures, Navisworks, Tekla structures, Autodesk Construction Cloud, BIM 360, and Bluebeam, supporting projects from level of development 300 through level of development 500. So his work spans clash detection, quality assurance, construction documentation, and coordinated model delivery for complex multidisciplinary teams. What's particularly impressive is the international scope of his project portfolio. So Satyam has contributed to landmark developments such as Rosemary Ganton residential building and the like the FIFA World Cup Lusail Stadium in Qatar, where he worked on precast concrete design for an 80,000 seat avenue. Satyam sir holds an MTech in structural engineering from SGT University and BTech in civil engineering from IK Gujral Punjab Technical University. So he's known for it. He's known for his hands-on technical delivery, strong client coordination skills, and his commitment to mentoring team members on BIM workflows and best practices. So please join me in welcoming Mr. Satyam Agarwal, sir. So welcome, sir.
Thank you, sir. Thank you, Bharat, for the introduction. Yeah, I would
Sir,
share.
your voice is not audible.
Okay.
Mr. Satyam, you're muted, sir. We are
Uh,
unable to hear you.
hello. Am I audible now? Hello. 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 Hello.
Sir, like you can share the screen, sir.
Yes, sir, you are audible, sir.
Hello. Am I
Yeah,
audible
you are
now?
audible. Yeah, you are audible.
Okay. Okay. Great. Okay. I can share my screen now. Okay. Is my screen visible to everyone?
Yes, it is visible.
Okay, great. So as Bharat sir mentioned, today we are going to discuss over BIM and accelerating smart construction and sustainable construction through precast technology with the introduction of BIM. So why I would just to understand first of all the fundamentals of in this we will understand the fundamentals of precast technologies and the fundamental of BIM, why we used what is precast, that all the things we will discuss from a model how we deliver the factory made elements and the finished goods from that, so why it is important in the current situation. So today we will talk about why precast. So we have learned and evolved in the construction technology. We have seen across, like we are building the infrastructure with the help of cast in place construction. But in the today's scenario, why precast is important? what are the fundamentals of precast, and how we can integrate BIM and their workflows with the help in the precast technologies to make it more efficient. What are the real, I have some examples of the real project which I have worked on. We will talk about that, and some important things which we have used in the Tekla structures to make it more efficient as a tool, and what are the takeaways from that, all that precast and BIM technologies. So firstly, we'll talk about why precast. So what is we need to understand what is precast and why precast. So in the regular construction technologies, so what happened is we are very much dependent upon the weather. So weather should be firstly suitable, and labor dependency is there. So and the quality concerns are very much there, like workmanship. So if there is labor and there is availability of good weather, so sometimes workmanship gets hampered. But in the precast technology, since everything is being casted in the industry, in the factory setup, so firstly, they have very high standards of quality to ensure like should be a good enough temperature for the curing, water should be good, and the mix should be good. And since the molds, so we can use molds every time. There are like there are good enough sets of molds, so we can make it more efficient with the help of that molds. So which helps us to shrinks the delivery, so to have the faster delivery. And yes, of course, while working in the controlled environment, while working with the machines and precision, we can reduce the wastage and lower the carbon emissions as well. So these are all the factors why we prefer precast. And of course, if there is like a very big, like 1 lakh square feet area which is being constructed nearby, so we can set up a factory, or the factory, there is nearby a factory, we can transport the goods directly over there. So which helps us to build the infrastructure very much at a high speed rate. So, but what is precast? So, firstly, precast is something which is prefabricated, which the terms itself defines, like precast. So but it is being developed in the industry at this before moving it to the site, and everything, the curing is done at the industry, and the all that, if the windows has to be installed in the walls, so or the opening has to be provided with the coordination with the MEP, and everything is done in the factory. So nothing has to be done on site. And after that, uh, since it is being done in the industry, so we are being caught, like the factory and the structure engineer like us has to coordinate with them, like what are the typical molds are available, so that they don't have to work much on the molds and we can fit that. Like obviously there would be some irregular shapes as well, so that to make it very much faster. And after that, we can use pre-stressed in the precast as well. Like there are pre-stressing technology in the precast also used. Like we have hollow core slabs in which there is section which is like hollow in the bottom, and top we have the strands. On the top and bottom we have the strands. So which is pre-stressed on in the site. Sorry, pre-stressed in the factory as well, and then it is being delivered and transported and erected at the site. So what are the type of elements which we have, like which I have worked and which evolves around the industry? We have slabs, as I talk about, and the slabs. We have pre-stressed slabs. We have regular concrete slabs, which have normal rebar as a mesh in top and bottom, and we have hollow core slabs as well, which are very much being used in the precast industry to make it the floor construction faster. And then we have the walls. We have very much different type of walls, like we have sandwich panels in like in industry, like in Indian environment we have solid walls, which has double layer of mesh, and outer we have the facade panel, which will be which is used as like an architectural aesthetic feature for the outside. As like I have right now I'm working with a European environment, so there's a lot of temperature variation, and we require to maintain the control the temperature for inside of the building. So we use a sandwich panel for the outer layer, and we have a solid wall. So that kind of panels are there, and even over in the precast construction in the Europe, what happens is the foundation is being casted on site, and after that, to avoid the moisture content to transfer it to the outer panels, so we used to have socle elements which has like height of 1500 millimeters, and which breaks the soil and the the bottom of the sandwich wall to avoid the moisture content to the to the walls. And then, yes, of course, we have the beams, precast beams and precast columns. We can cast according like to the requirement, like which shape of the beam we require, how we need to make it resting. So that can be done. And yes, balconies. Yes, of course, I have like worked around in the Europe, and there we have the balconies as well, which are being casted and erected with the help of certain modules directly into the floors. So this is the wide variety, and of course there are like a lot many others elements as well in the precast industry, which is like being manufactured as per the requirement of the contractor or the architect. So how we evolve around the BIM with the in the precast industries, we have like couple of tools Tekla structures, Revit structures, which is being used for the modeling, detailing, and shop drawing generation. And for the coordination, we have the Nevis work, and in which we do the clash detection. Then we have for the documentation, we have BIM 360. Now it is known as Autodesk Forma, and previously it is known as Autodesk Construction Cloud. Over there, we do the coordination with the document which is being done with the stakeholder and the design team. So right now, but I have an example of a Tekla structures, how we are using Tekla structures in the precast industry. So what are the advantages of it? Why we use Tekla structures? Is you have an example of a model which is being like on from the top, and then a 3D view. So this is a example of a building which is there's a site around, and which if the model was divided into four parts, and that model, the buildings is in four parts, and the model, there were two different models of Tekla, since like it was getting very big, and we can't accommodate in our system, so we have to split that model. But all that construction with the integration of other disciplines like mechanical, electrical, and plumbing, so every other items were being through the IFCs were being imported in the model, and we can check according to like being what is required, like if there is any clash with our structure, or what are the criticalities we need to take care, how we need to reshape our structure so that it should be good enough to hold the MEP, and it should have good the integrity with the building as well. So that's how that helps us to build a good 3D model, and later on, like whatever we have the good input, that's how we can generate a good drawing so that it can be constructed in in the factory, and later on it has to be transported to the site and erected at the site as well. So we can what we can do with the help of Tekla structure as a BIM tool, so we can prepare these kind of 3D models, in which we can prepare the cast in place model, like meaning just simply model the column beam structures. We can put the reinforcement, and in the precast we don't have to join as a reinforcement. We have to put the embed goods, like put the lifters to lift it, to tilt the walls. These are kind of the elements which are required to put inside the precast elements, coordinate with the MEP, and various other disciplines wherever it is required. Detail, as I mentioned, like to reinforce it and put the embeds. Embeds means like put the lifters to lift it with the help of cranes, and prepare the shop drawings. As well, we do the for the fabrication. To improve the fabrication, we require to export the IFC, so that the site person and the factory also have the digital 3D data. Like they can't have carry these big heavy models with the in the Tekla structure, so they need a common extension to communicate. So where there it comes the role of IFC. So IFC is something like industry foundation class. It the full form of IFC is that which helps us to coordinate with various other teams. So everyone can like we as a structure designers, we require IFC from the MEP team so that we can coordinate with the pipes and ventilations and with everything. And the same ways it goes for the other teams as well, so that we can communicate. And for the site as well, they know like which element has to come where and what are the levels, where how much there's a gap between, because we need tolerances in the precast. And of course, the report generation at the last, like how much rebars are there, how much elements like embed goods like lifters are there to put the purchase order. So why Tekla structures? To to improvise the complexity. So there are like so simple like when we have a smaller structures which are like no which are regular geometries, we can make earlier we can make with the help of CAD as well. But now as we evolve around the complexities, we have the tedious geometries and various like multiple stories as well there, like any like structure superstructures can be constructed with the help of, but we need something to have the coordination with it, to see like how it will look like in the actual world. And that's how you need a software where it helps us to grow faster and understand this complexity of the structure. Like if there is a pipe in between solid wall or a slab, how it is going, what is the root of it, you can quickly take a decision on that, like where the root has to be changed or the whatever the structure has to be modified according to the requirement. So but with the help of within the 2D, there's a constraint, you can't imagine very fast and take the decision. So you have to put so much efforts in that, whereas the 3D viewing in the Tekla structure, it reduces the time. So that's how it helps us to build a good complex model, helps us with the geometries. That's true 3D modeling happens. Clash, clash detection, as I mentioned, like where there's an example of a pipe which is going in the wall and something. So it helps us to take decision according to that. IFC, as I mentioned in the previous slide, like it helps us to communicate with the various different disciplines. And sometimes it helps like with the, if there's a geometry build around some structure, so we can directly import that kind of particular geometries directly into the model as well. So if complexity rises, then it comes with the smart component and parametric components in which we adapt to the geometries. Reports, as I mentioned, like we can extract reports like embed goods, reinforcement detailing, and content manager. There's a lot of option while after extracting the drawings how to make the ensure quality of a model. So that's how there's a drawing content manager in the Tekla structures. So these are a couple of example I have. Like these are like I have worked with a small scale and large scale project, but these are the two examples on which I've worked largely. I was part of it. So this like 1.5, 2 years long project in which like 4 buildings were there. The first one was this Socklingen, and it was built in a Tekla 19 version and another one in Tekla 2020. So there were 4 buildings in both of the projects, and we have done from from the modeling to the delivering of drawings and delivering of the reports in all of these buildings in each of the projects. And that's how the real time pictures look like after the construction is being done on the faces, like when the balconies and the outer walls have been erected on site. This is the finishing look like. So there's like also one advantage of it, like since the every quality is controlled of the material, so finishing is really good. So you don't have to be worried about this like chances of getting bad finish on the outer face. So you just apply directly paint on it. So there's some smart features as well in the Tekla structures. As I talked about, Tekla is a very advanced tool for like it was firstly built around the steel, but later it evolved around the precast and the cast in place structures, which helps us to evolve faster with the models and the buildings. So there are some tools like selection filters. So imagine I have to filter any pipe or to electrical pipe inside the model, because sometimes it happens like we have to model these kind of things which are associated with the other disciplines in our structure. So to check like how the reinforcement is required, sometimes it happens like while coordination we assist the other teams, like on the majority cases, like if the pipe is having a bad root which increases the criticality of the structure. So we can deviate the shape or the root of the pipe, but sometimes like as I said, it's a precast construction. So even the pipes, electrical pipes and the water pipes, we have to provide the shapes of it inside the precast structure. So that level of detailing we can achieve inside the structure, like we have achieved while working with the European project. So they do install everything firstly, so that on site they just have to connect it like a Lego blocks. So, but while modeling, coming back to the modeling part, so there are tools inside the Tekla structures in which, like selection filter, you can check like what is the length of the pipe through the selection filter, and if the goods is missing or not. So that kind of a thing we can achieve with that phase manager. So while working with the model, if you have different buildings all together, so you have to put that in a particular phase, so that like while selecting with any of the component or any of the wall or the slab, you don't end up selecting entire model. So that reduces the complexity while working with the Tekla structures. Otherwise, it will be a lot of mess and chaos around the model. And yes, after working at a certain point, you require like Tekla is not having that much components which makes you work faster. So there's an option of custom components in which you have to save your time and build the tools inside of a Tekla structure, which makes you more efficient while working. Like if there are grout tubes, so you have to put the grout tubes inside the wall, like this when we have a wall to wall. So to fill there's a dowel from the wall coming from on the top, and the bottom there will be grout tubes in which it will sit. So but in the model that is on the site, which has to happen, but before us having the construction on the site, so like erecting on the site, it has to be go through the model. So in the model, you have that option of custom component you can create, in which in a linear phase, the grout tubes will come at a certain distance. Sometimes the component is there in the Tekla, sometimes it is not. So you can build around it, and then you can put it in and use it in the drawings and the model, and later you can extract the shop drawings around it. So what is the impact what it creates around the Tekla structures? So as we came through the process, like uh, we are talking about precast, we are talking about the BIM integration. So but in totality, in together, what it helps us to achieve. So uh, the while working on the cast in place projects, so there are a lot of times the timelines what has been prepared, it deviates, tends to deviate because of the lot of parameters. It happens whether it can be labor shortage, whether it can be the weather, or whether it can be the material. But as it comes to the precast technology, so firstly you require a skilled labor to work on the site and in the factory as well. But when it comes to the construction part, so in the controlled environment, it helps to reduce it helps to increase the quality and compress the timelines on times you can achieve. Obviously for that a lot of coordination is required with the structure design BIM team as well. But yeah, it happens, it helps us to do that thing. Yes, wastage, as we talk about, like in the cast in place construction, there's a lot of time you end up doing the lot of wastage with the material. Like if the certain portion of the buildings has been casted, if the rebars are outside, if someone has not put the weather protection on the rebar, so the material it can be wasted. But it in that in that precast construction, like you have controlled environment, you can you reuse the molds, and you can put according shape according to the sizes and cutting for the rebars. So that helps to reduce the carbon emission and saves the concrete as well. Quality, as I spoke about, the finishing quality of the wall slab, every concrete element as casted is top notch. So you because the curing is done being done in the chambers, the whatever the particular amount of temperature and water is required, and the control mix is there, so it helps us to achieve that. And yes, with the integration of Tekla structures, you can if the factory and the structure designer are using that same platform to coordinate, like what element, like if you can prepare the time and timeline of for the like what elements has to be casted. You can set the construction order in the Tekla structures. So with the help of that, you can see like what elements has to be cast first, and together with the coordination with the contractor, if the contractor approves like this elements has been casted from us, so you can get the feel of it, like whatever the building part has been left, so you can trace that. But while in the cast in place construction, this becomes tedious to trace, like what is casted, what is like how it is planned, it can be delayed. So that's how it evolves faster. Yeah, that's the end from my side. That's all.
Thank you very much, Mr. Satyam Agarwal, for an insightful and engaging presentation. Now, the floor is open for any questions, queries from the audience. Anybody would like to pose any questions to Mr. Satyam Agarwal? So I guess
Sir, I just wanted to know when we were talking about the in your presentation, when you
Yeah.
told that the finish that we get with the prefabricated or the precast structures,
Mhm.
so the strength parameters and then the reusability of it. Say for example, the C&D waste, if you're talking about like with the
Mhm.
conventional concrete,
Mhm.
and that with the precast members.
Mhm.
So the C&D usage of it, if you can guide us through it.
Okay, so I'll take one by one. About the strength parameters. Yeah, the process remains the same. We have a cube testing and on the site and the precast as well. So, but since like sometimes on the cast in place structures, the ratio is not get being achieved due to workmanship. But what happens in the precast structures? So the machine itself has the proportion of it. So the machine prepares you have to just give the raw material to it. It prepares it on and mixes, and then it pours on the bed. Like we have for the slabs and the walls, we have a lot large bed, like 12 meters bed size, and 3.5 and 5 meters depending on the factory, like it's in width. So that height and width you can achieve that, and in those beds or in those molds, the there's a machine which pours the concrete itself before like it mixes it and then pours it. So that there's lot less chances to being missed with the right proportion, like whatever the proportion you require, if it is M30 M35. So whatever mix is required, so it tends to achieve that, and it due to that, and after pouring it, so I'm talking about the process, like how it is done. So after pouring it, so the on the bed there's a beneath it, like there's a vibrator. So like on site we do the vibration with the needle vibrators everywhere around, and then that same thing is being done within the controlled vibrations, like how many repetitions to be done on the vibrations on the bed. So that helps to settle down, and after that, like then it is being settled, and try to like it tends to harden the concrete, and after that it is being poured in the curing chambers. So like how many the temperature and the water is required for the curing. So that rigorous process and everything is being done while the time of casting in the factory. So that helps to make it good because of the good mix and the right proportion, and the yes, in between that I missed like putting up the reinforcement. Yes, so the if there is a wall, imagine there's a wall of 3 meters by 3 meters. So there's the like mesh which is being built, and that is welded on in within the factory only. That welded mesh will be placed like on both the sides, front and back side of the wall, and then the concrete is poured. So that much level of like accuracy with the way the placement has to be done. If imagine there is a opening as well, so the bar has to be the mesh has to be cut around the opening, and the reinforcement is placed. So everyone look like with the help of the drawings as well, like the coordination is being done, and the concrete is poured, and that all the curing will happen. So because everything is being done in that controlled environment, that's how the finishing and the strength, because of the good mix, happens. That all that vibration process and the good mold mixture, it happens. So we tends to achieve that. And talking about the carbon emission, lowering the carbon emission, like since like with the help of how much sizes we have to cast it, so there like imagine like not with the one panel, if that same wall has to be casted, if there are like a lot of walls, like 10 to 15 walls, the same has to be casted. Imagine you don't have to work with the different molds creating, and these small parameters with the less different molds and less complexities involved in that particular casting reduces tends to reduce the emission, and increase the quality, and make it more efficient while casting in the factory. So these all small little things while working, while planning, it helps us to reduce the emission.
Thank you, sir.
I hope I'm able to answer to your query.
Yes, sir. Yes, sir. Thank you.
Thank you so much, sir. I request audience to come up with queries or questions with Mr. Satyam Agarwal.
In the meantime, I can share precast, one more insight of precast. So we can take a look like how the manufacturing of the precast structural elements happen. So what I was being delivering it, like how what is like hollow coat and how it is being casted. So these all long beds, like, imagine you have a 12-meter long bed you have there in the factory, and that is like 1.2 meters in wide for the hollow, because that's a different bed, and on the top you have a crane to lift it. So this on one end, there's a pre-stressing machine is there, in which pre-stressing strands are there, and the other end it is connected. So these long strands will be there, and there's a certain pattern to it. So the factory has a different strand pattern in which these strands are being put. So this is pre-stressed since pre-stressing term is clear. So this is pre-stressed first, this strands and this concrete poured to it till the time the concrete is hardened and achieve its strength. So the strands will not be cut. And once it is hardened and achieves its strength, so the these strands will be cut from the machine. Otherwise, it will be like due to the stressing applied, it can come out and it could damage anyone. So this is an I section. This is like being done like a lot. This is like a common practice I section. Everyone has seen the girders which are being casted for the flyovers. So this has been done from a very long time. This like this precast, they for the highways, the girders are being casted on site with the help of molds. They used to like cast it first and then they lift it with the help of cranes and they put it the at erected at the location. So yes, I was discussing like how they cut it if there is a cut required in the particular element. So these kind of machines are there which gives it like a very good finish and cut where it has to be cut. So this is how it is being lifted in very controlled environment. This is a particular example of an hollow core slab. And later, after putting it on the truck or train, after that, it is being lifted from the truck and with the help of cranes and being erected on the site. So, uh, so see the level of finish. So they don't see the forms. Like there's a very good finish quality on the top of hollow core slab. And yes, obviously these are being covered so that like to avoid the water going inside it. And on the beams it is being placed. So this is a sample section for the hollow core as per the requirement, as per the design. So one can choose like what pattern has to be or what hole, how hole has to be chosen according to the thickness of hollow core. So if we talk about how it has to be connected, so there are different processes to it. Like in India, there's a different process. Like we used to place dowels and tubes are there in the like above element, and from the bottom there will be dowels. But uh, in different part of the world, there's a different type of joining happens for the precast. Like here we have an example. We have shims to provide the tolerances between both of the elements, and then we have the column shoes, and there are like small studs outside from the bottom column, and it is being like with the help of crane it will be placed on the right position and then it will be uh, bolted. And later on, yes, I missed one thing. Yes, this dry grout will be placed to have the finish and to make it appear as a one integral unit. And similarly, we have an example for column to beam connection that was previously column to column connection. So there are like welded plates cast in on the, uh, there's like embed which is provided in the beam and there's a bed provided in the column at the right specific location. For this, like a lot of detailing has to be done in the drawing. And on the side, placing a weld plate at the site with the help of weld, it is being making as an integral unit. And the bottom the bearing pads for the to have a specific tolerance, because there's like for the this there is very important thing is tolerance in the precast, like 5 to 15 or 20 millimeters tolerance has to be provided. So this
Um,
is how, yeah,
Sir
this is,
Ron, very good morning, sir. Thank you for the insightful session.
yep,
Actually, I just have one query with respect to the software Tekla.
yep,
As you were mentioning about the precast concrete element connections from beam to column, beam to beam, I
yep.
just want to know how does it properly in the software um, do that so that they would replica the same thing which has been embedded in the sites,
So,
because the
yeah, you complete first.
software has its own limitations, own bugs. So how do we do the simulation in the software, especially in Tekla?
So, imagine this as like this as a regular software. So, like we put the certain dimensions in the softwares, like while modeling with the certain dimensions for the beam or a column. So, these all things we try to place first and assemble it in the software first. Like I can show you an example of it.
Yeah, sir,
Uh,
sure, sure.
yeah, yeah.
Sir, I have a very common question with relevance to the students' perspective.
Yep.
Many civil engineering students have limited exposure to digital engineering tools. What
Yep.
software skills and competencies would you recommend to students to develop to become industry ready for careers after their graduation?
For that, I think there are tools around Tekla Structures 1, which we are using it. In that, we do the precast concrete as we're doing, like I'm showcasing it. And other is Revit structures, which is widely being used in the industry. And the Revit, for the advantage of Revit is like it is being used with the architecture team, MVP team, like mechanical, electrical, and plumbing, and the structure team. So the coordination makes it very faster to use it and to adapt it. These are the detailing softwares which I'm talking about, Tekla structures and Revit AutoCAD, Revit structures. And for the design perspective, you have eTabs and you have StatPro, and Tekla also have Tekla designer softwares. So for the design analysis, there are those tools, and for the detailing softwares and the 3D modeling, the Tekla structures and Revit works. And I think for this, the content is available, and there are a lot of tutorials and tutors as well who helps us to learn these all the softwares.
Thank
I
you,
hope
sir.
you got the answer to it. Yes.
Sir, I also want to ask something from the student's point of view only, that can you give in detail like any of your international projects, so that students will also get an exposure that how industry works and how works are being done on an international level.
Okay. I can share something. The content. Just a second. Can you see my screen?
Yes.
Yes, sir.
Okay. To answer the question, like how we can ensure like the every dimension is correct and that is being replicated same thing at the site. So for something like this, we have to firstly model it correctly. Model means while working. So if you can see this image, so here on the left hand side, you do the geometry modeling first in the Tekla structures, in which you have like the input is being delivered firstly by the architecture team, like where the window has to be there, and then with the structures, we have to coordinate where the supporting structure will be there, if there is any beam or a wall sideways connecting, and how it is being connected, or if there is a slab, how it is being supported by the wall. So all that thing, all that stuff has to be checked while modeling. While modeling means like you have to see that in the 3D, like how the structure is being connected with the like column, beam, and everything. So that integrity has to be modeled first, and according to that, you can see there is like opening inside at a specific dimension. You have to provide the opening, and what will the size get from the architecture, and then how long the slab or on the top, how it does it look like. You have to make a cut, and on the right hand side, you can see there's also a one more cut. And after that, once you model and finalize this 3D geometry of a element, and then you pour the reinforcement, you model the reinforcement with the help of components, and there's a lifter around it to lift it by after the when the finally the casting happens, the concrete gets settled and hardened. So with the help of cranes, it will be getting lifted. So and there will be reinforcement. The main reinforcement will be there in the two, like front and back. Like front and back means like if there is a wall of 200 millimeters, so you have to put two meshes around it. Two layers of reinforcement will be there, and the grout tubes what I am talking about. So all these embed goods what are the requirements, and on the top for a connection you have a plate on the top. So these all the things will be like whoever so is modeling that structure has to ensure like these has to be there in the modeling. And after that, the next step is like this model is not being seen by the person who is casting this. So uh, this is the document. The drawing is the document with which the site people will help will communicate, or with the help of this, like because it has all the dimensions, all the details to it, like how much the overall geometry look like, if it is a 4 meters and how high it is. So that's all geometry is being seen with the help of drawing documentation. You can see this overall dimension, like where the lifting will be provided. So where is the cut, and where is the side lifting is there, but where the grout tube is there, and how the section look like, how much thickness it has. It is like 200 millimeters thick. So that's how the and all the specification of the rebar you will place in that, so that site people doesn't have to think a lot before casting, or they have to measure each and everything. So the one who is doing the modeling has to think a lot before delivering this content to the site person. So to make their job easier, and to have the better quality of the construction. So, and with the help of this is like a geometry and details which is being provided as a document to the site person. And with the help of this, the dimension, so now the workmanship happens, plays a role. If the person who is casting has a good enough skill to read the drawing properly, that person will cast this drawing in a good manner. So this is how the process happens, from modeling to delivering it to the site during the erection. I hope the person who has asked this question, like how to make ensure the quality, like how to make ensure like this is being rightly modeled, has got the answer.
Yes, sir. Yes, sir. Thank you, sir. Thank you so much.
Okay. Yep. Any other questions?
The floor is open for any other questions. I request the students also to come up with the industry relevant questions.
Sir, the same question was which Vaishnavi Bansal addressed. So,
Yeah.
any of the international projects, say for example, the FIFA football stadium design which you had done. So, if you can share any like the pictures or some details about it.
Okay, I don't have that right now in my presentation, but definitely I will share this with like after this presentation. But I have like what now I have worked with some of the international projects right now, so I can share this with you all. So these are the kind of projects which I have worked till now, in which I was part of it. So this now right now we are talking about Tekla structures, but this is one of the example which I've worked with the Revit structure as well. This was kind of a building which was done in the Gothenburg. Gothenburg is in Sweden, and we do like right now I'm working with Scandinavian region. So here we have to model the reinforcement of this building, in which like we have to model the footing first, and after that we have to put the rebars. So that all is being done in the Revit, and after modeling the rebars, we have the drawing which has to be prepared. So this is how it get complex while making the drawing. You can see the complexity, but with the help of a Revit as a tool, or if there is a Tekla in that case also, it is possible to do and deliver this kind of a complex drawings. So how we are able to do these drawings? So firstly, the modeling is very important over here. So while modeling, you have a edge. You can see how that looks, the rebar in the 3D, and in the sections, you can take a lot of section, and then you have an advantage like on the plan, how does it look like? So when you are done confirmed with like how the modeling is being, if the modeling is being done as per the input, then you start preparing with the drawings, and the drawings will give the same result, but you have done the input to it. So this is how then the final outcomes look like. Then if we talk about the precast, uh, so this is again the cast in place project. Yeah, this was the project which I can say like this was a complex project in its own kind, and we have four buildings together. The one which I've taken example for, and there were like a lot of elements, precast elements like hollow core slabs, pre-stressed slabs, and there were regular concrete slabs and solid walls. All that were done in the Tekla structures. So this is kind of the complex drawings we have for the regular concrete slabs. So what I was talking about, like complexity, which involves lot of MEPs as well inside the drawings. So these are the pipes for the electricals inside a drawing. So imagine this level of detailing. You have in a slab, you have a drain pipe also. From the plumbing team, you have a route for it. You have to present it and give it to the site. You have to give the dimensions of it so that they don't miss a chance to miss this all the details. You have to be sure of the geometry so that they have a particular cut inside it. So this kind of detailing is firstly being modeled in the Tekla structures, and then it has to be lifted it also, and then you have to connect it with some other element. For that you have a connection, and then this a pipe for the electrical things which is being running over here. So this is a kind of elements detailing we are being doing over here in the Tekla structures. So what I'm talking about, the socle and elements. So why we provide this socle element? So like this is example from the site, we have it. So these are like short heighted elements. We do call in the Sweden it's called socle element. So why we provide it? So everybody have seen that that kind of stable we used to have it because Sweden is like has a lot of snow around the year. So to have reduce the moisture contact with the superstructure, so there's an element provided with that's short heighted. There's a focal element. So this avoid that contact between the upper structure and the foundation and the ground level. So that's we provide, and also helps us to make a supporting structure as well. So that's called a socle element, and within the building as well, we used to provide that for the same purpose. And then comes the sandwich element, which it's provided on the facade, which has like on the outer, we have one non-structural element, non-structural concrete, and in between we have an insulation. And then on the inner side, which is the supporting part, has the 200 or whatever the designer gives the information, has the thickness of the concrete is there to support the slab or other elements. And this is how the erection on the site look like of the sandwich wall. So this is kind of a bracing we provides as a temporary support we to hold the wall so that it doesn't like after erecting doesn't fall off. So you have to provide temporary bracing for it. This wall, these all the elements I'm talking from different projects. We have it, but we work in the Sweden. So, and this is how we, like, if a wall is connected with a another wall on a perpendicular side, how the propping anchor will work. And this is an example for the lifting. There are some of the buildings we have, like this is an IFC we have from the client, and like how the architecture will look like. But the requirement was to just model the slabs for it. That was like hollow core slabs again, and that was being done in another software. It was not Tekla, it was Impact AutoCAD. This specifically used for the Scandinavian market, and in that we were using it to model just for the Holocaust. Because so here comes the example, since it was a precast, and to reduce time, and we just have to think like this much area is there, and the pattern for the holocore was fixed, like 1200 meters, 1200 millimeters. It's a width should be there for the holocore, and the length should be approximately 5 to 7 meters, or you can go up to maximum 12 meters. That's the length of the bed we have. So the one has to just check like where the particular concrete slab or this hollow core deck will be fit, and how it can be fit. The person who is modeling has to ensure that. And because of the hollow core, because it can be casted in within the factory fastly, so for the flows it is used, and it is light in weight, so the transportation to transport it is also easier. And because of the pre-stressing strands, and it has like a lot more strength as compared to the regular slab. So these are the kind of projects I've worked with internationally right now, like which I have some examples to share.
Thank you so much, sir. I request anybody else to have some questions. Otherwise, we have come to the fag end of this particular technical session with Mr. Satyam Agarwal. I guess no more questions, sir. Sir, your talk has beautifully demonstrated how digital technologies such as BIM and Tekla are transforming the planning, design, and execution of precast construction projects. The practical examples and industry perspectives you shared have done undoubtedly broadened our understanding of digital construction workflows. I'm sure our students, researchers, and professionals have gained valuable insights into the future of digital engineering. Ladies and gentlemen, please put our hands together once again to thank Mr. Satyam Agarwal for his wonderful presentation. Mr. Agarwal, we are also expecting you as a panel member after all the technical sessions by around 3:15 p.m., sir.
Okay,
Thank you so much, sir. Thank you once again.
thank you.
Thank you, sir.
Thank you.
Please attention, everybody. We are going to start our next technical session by 11 a.m. Welcome back, everyone. We have our next technical person available with us, Mr. Pramod Adlaka, who is the Managing Director of Adlaka Associates Private Limited. He is going to deliver a talk on industrialized prefab, precast, affordable building construction technologies. I now request my colleague, Dr. Amit Tripathi, to please introduce Adlaka sir to our audience, please.
Good morning, everyone. Ladies and gentlemen, it is my great privilege to introduce our distinguished speaker, Mr. Pramod Adlaka. Mr. Adlaka, sir, is an internationally accredited chartered architectural engineer with over 55 years of professional experience. He is the founder and managing director of Adlaka Associates Private Limited and is widely recognized as the father of affordable housing with innovative technologies. Throughout his illustrious career, he has pioneered innovative, cost effective, and sustainable housing solutions. With more than 50,000 affordable homes completed using advanced construction technologies, he is the recipient of numerous prestigious awards, nationally and internationally honored, including the Awas Ratna Award from the Government of India and the International Commendation Award from the International Association for Housing Science, USA. Mr. Adlika sir has served on several expert committees of the Government of India, contributed to the National Building Code, and has been instrumental in promoting emerging housing technologies across the country. His work has influenced policy, practice, and innovation in affordable housing, both nationally and internationally. Please join me in extending a warm welcome to Mr. Pramod Adlaka as he shares his valuable insights and experience with us. Sir, welcome.
Over to you, Mr. Adlaka sir. Please take over.
I'm not skipping up few of the initial slides. Yes. After 55 years of my experience, this is the book which is going to come out by the end of this year. So what presentation I'm going to do today is out of the chapters from this book. The name of the book is The Tech Bank That Never Fails. And this is world's first and only book of its kind, which has never been published and will never be published after also. What is unique in this? This includes 700 plus building technologies, systems, practices, methods, with more than 5,000 figures, photographs, more than 5,000 references, more than 4,500 quotes, each page has a quote, 25 sections, 300 chapters, 450 sub-chapters, and comprise of about 5,000 pages in 3 parts. Publishers are Jain Brothers, New Delhi. First, just let us see what is conventional. You can see the normal in situ RCC foundations, the RCC columns, RCC slab and form with formwork. See the type of shabby work that we get. They see the brickwork that we normally do in our buildings. And on right, you can see the column formwork scattered all along. And then our question arises, Why alternate prefab precast innovative technologies? There are ये फिर वापस आ जाता है. Just a minute. The traditional construction practices are unable to solve many key issues. I'll not explain in detail. You can go through my slides later on through the college. The only thing I want to say is it doesn't move. I don't know why. Please, you can let help. हाँ ऐसे इसको अच्छा ऐसे इसको मूव करो. ओके ओके ओके. I have worked on small panel prefabrication, and my thought process is that in Ghar cottage industrialization as micro small units. This is what I'm promoting. And this is what I have worked on for the last 55 years. I will not read out this also. Industrial prefabrication has got 4 stages. The first stage is first degree of degrees of prefabrication. First stage is to replace the in situ concrete floors with small modular floor component. The second stage comes after we gain the first. When the first stage people accept, is a question of slow gain of acceptance by the clients, acceptance by the industry, and with the further knowledge of our own professionals, we can increase the degree of prefabrication. The second stage is floor and roof components with prefabricated bricks and blocks and prefabricated interlocking blocks without mortar. The third stage is the second degree of prefabrication. Bricks and blocks are then replaced with the precast wall panels and precast columns, precast beams, precast higher utilization with small cranes. Fourth stage is the third degree of prefabrication, wherein we can use precast room size walls and room size slabs, box system, a precast toilets with all services inbuilt and use of large cranes. The fifth stage is the precast composite system, that is the insulated wall and roof system, concrete with insulated layers in between. Precast pre-stressed concrete large panel wall and roof system, and precast multi-storied lightweight concrete pre-stressed system. How we classify prefabrication and prefabricates classifications in small prefabricates when the plan area is not more than 2 square meter, large when plan area is more than 2 square meter. Similarly, light prefabricated item means its weight is not more than 30 kg, can be erected by one man. Medium is not more than 200 kg, erected with simple mechanical equipment. Then medium heavy prefabricates. Oh. बहुत ही मुश्किल या तो किसी को रन करना पड़ेगा बट अब थोड़ी यू हैव एन हैबिट नो heavy prefabrication when the weight is more than 500 kg and require heavy handling. Now these are few tips. There is no single approach acceptable to all. Okay, I'm not reading out the other things. Only today's recommendation that I want to do is today the answer lies in, with no sudden shocks, encouraging building systems which are intermediate type, less sophisticated, involving less capital investment, upgrading to sophisticated technology applications where conditions warrant so, and for future upgradation. I'll just go through fast. This is the slides for foundations, precast foundations. The one is the pedestal Pre-pedestal pile foundation. This is for single-story building when the load is not more than 2.5 ton per meter length of the wall. The pile spacing is not more than 2 meter at all corners. You are seeing the section of the pile, and the right diagram is a pile which has been exhumed. This is a precast pile erected on a hard style strata with in a in situ concrete infill. Next. This is an earth bag foundation, soil bag foundation. This is also why I'm taking this foundations are. This is the new technology. When a soil bag is prefabricated, when filled with the soil, and it is packed, and then we are using this for foundations. Continue. You are just seeing the diagrams of this. I'll explain this later on. Then next comes the prefab pocket footings. You're seeing the diagrams. These are the precast columns and precast footings, pocket foundations. Next. These are the standard units, corner units, standard units, precast units. Then this is a disc-shaped precast footing. You can just थोड़ा सा ऊपर करो. This is a circular footing. और सेकंड डायग्राम फिगर 2 में आप देखें आइसोमेट्रिक प्रीकास्ट फुटिंग शो कर रहा है, स्पाइक शो किया हुआ है. स्पाइक का एडवांटेज ये है कि दिस हेल्प्स इन in earthquake horizontal forces, taking up horizontal forces in sandy soil and in black cotton soil. Next. Then this हाँ, ये आप ध्यान से देखेंगे तो इसका बॉटम जो है वो अब कर्वेचर में हो गया. इसी फाउंडेशंस का जो मैंने आपको शो किया था, this acting like a shell, bottom foundation. Then these are the precast block foundations. आप just see the figures 1, 2, 3. प्रीकास्ट फाउंडेशन का एक वो है, उसमें नॉचेस कटे हुए हैं. आप ध्यान से देखेंगे इसमें ये नॉचेस के अंदर में प्रीकास्ट टाई बीम्स डाल देते हैं प्लिंथ लेवल के ऊपर में. और एक सेकंड ऊपर करो, ये फिगर 5 देखिए, वो प्लिंथ बीम को प्लेस कर रहे हैं इसके अंदर में और फिर जॉइंट को ग्राउटिंग कर देते हैं इसमें. आगे चलो. दिस इज द प्रीकास्ट स्ट्रिप फाउंडेशन. आप छोटे छोटे स्ट्रिप बनाइए, जिस फिगर्स में आप लेफ्ट में देखेंगे ये शेप है उसका, और इन सबको जोड़ते जाइए आपस के अंदर में. एंड देन इन द हॉन्च दैट इज क्रिएटेड बिटवीन दिस जॉइंट फाउंडेशन, इस पर टाई बीम रीइंफोर्समेंट डालिए, टाई बीम का काम करती है. इसके ऊपर आप ब्रिक वॉल लीजिए, आरसीसी वॉल लीजिए, कुछ भी कर लो क्या. देन दिस इज द प्रीकास्ट शेल फाउंडेशन. ये शेल कई तरीके से बन जाती है. हाफ सफियर भी है, कर्व्ड शेल भी है, फोल्डेड प्लेट स्ट्रिप भी है. ये 11 नंबर फिगर देखेंगे तो प्रीकास्ट शेल फुटिंग जो है ट्रायंगुलर अच्छी की है. राइट को जो है एक्चुअल साइट कंस्ट्रक्शन है यूजिंग दिस एज ए प्रीकास्ट सिस्टम. Then we are coming to the superstructure. Prefabricated soil blocks we can use. So these on the left we are showing the moldings, these molds. ये मशीन है राइट को, और ये गैंग मोल्ड्स हैं जिसमें 8-10 ब्लॉक्स इकट्ठे आप कास्ट कर सकते हैं मैकेनाइजेशन करने के लिए. थोड़ा सा ऊपर फिगर 11 है. इसको मैकेनाइजेशन करने के लिए ये मैकेनिकल मशीन है जो उसके साथ अटैच हो जाती है, जिससे ब्लॉक्स की प्रोडक्शन बढ़ जाती है. राइट फिगर 40 नंबर देखेंगे तो स्टैकिंग एंड ड्राइंग पूरा स्टॉप किया हुआ है. अभी हमने बात की सॉइल ब्लॉक्स की, अब ये आ रहे हैं हम प्री फैब्रिकेटेड सॉइल कंक्रीट ब्लॉक्स. द ओनली डिफरेंस दिस इज दैट सॉइल तो है लेकिन उसके अंदर में ग्रेवल इसके अंदर में डाला हुआ है, और ये भी प्री फैब्रिकेटेड सॉइल ब्लॉक्स बन जाते हैं. आगे नेक्स्ट. I have to go fast because there are more than 200 slides. ये कास्टिंग करते हुए, ये बिल्डिंग बनाते हुए फिगर 15 में वॉल्स इरेक्ट करने के बाद में. नेक्स्ट. Then this is prefabricated stabilized compressed earth block. अगर आप सॉइल के अंदर में लाइम मिलाते हैं, सीमेंट मिलाते हैं या कुछ केमिकल्स मिलाते हैं जो स्टेबलाइजिंग का काम करती है, और इससे फिर आप कंप्रेस कर देते हैं तो इट गेन्स द स्ट्रेंथ. इसका परमेबिलिटी भी रिड्यूस हो जाती है, एंड वी कैन यूज इट फॉर ये मशीन्स है उसके लिए, मैकेनाइजेशन के लिए। सबसे पहला मैनुअल प्रेस है, अगर उसको यूज करना है, मोटराइज सिस्टम भी है, मोबाइल यूनिट भी है, और लार्ज प्रोडक्शन करनी है तो फिक्स सिस्टम भी है। ये कुछ फिगर्स हैं ब्लॉक्स को बनाते हुए। आगे चलो, ये बिल्डिंग्स कुछ बनी हुई है, कुछ इंडिया में है, कुछ कोलंबिया में है। ये अभी जो सॉइल बैग फाउंडेशन मैंने दिखाई थी आपको, वो ये है। जो बैग है उसको सॉइल से जब भर लेते हैं तो उसके बाद उसकी अटैचमेंट कैसे करते हैं, उसकी अटैचमेंट के लिए अब ये वेलक्रो प्लेट देख रहे हैं, ये लगाई जाती है और उसके ऊपर नेलिंग कर दी जाती है। नेक्स्ट में, नेक्स्ट नेक्स्ट स्लाइड। ये आप ध्यान से, ये बैग्स हैं, लेफ्ट में फाउंडेशन का सेक्शन है, फिगर 34-35 शोज द बैग, और नीचे जो है वो बैग को कैसे रखा है, सीक्वेंस है 36 पे, इसके बाद 39 में ध्यान से रखेंगे। और इसके बाद जब बैग्स को रखते हैं, देन आगे चलिए थोड़ा सा, फिगर 43 में देखें तो इसमें बारबेड वायर के साथ इसको, बैग्स को लिंक कर दिया जाता है, बोथ टॉप लेयर एंड बॉटम लेयर एंड हॉरिजॉन्टल, जिससे ये पूरे इंटीग्रिटी इफेक्ट आ जाता है ब्लॉक्स के अंदर में। राइट को जो कुछ बिल्डिंग्स बन रही हैं, ये थोड़ी थोड़ी कुछ फिगर्स हैं मैंने दिखाई हैं। हाउ टू फिक्स अप द कंड्यूट एंड स्विच बॉक्सेस, वेलक्रो प्लेट कैसे लगाते हैं, टेम्परेरी फॉर्म वर्क फॉर ओपनिंग कैसे करते हैं। ये बिल्डिंग्स को बनते हुए हैं, ये सेक्शन है। प्री फैब्रिकेटेड एईसी ब्लॉक वॉलिंग, ये तो आप वैसे पढ़ भी चुके होंगे इसको। एईसी ब्लॉक वॉलिंग इज मेड ऑफ फ्लाई एश, सैंड एंड सीमेंट, एंड इसमें अल्यूमिनियम पाउडर डालते हैं, और जैसे ही और वाटर डालते हैं इसके अंदर में, ये पोर्स क्रिएट कर देता है और लाइट वेट कर देता है। पूरा आगे चल, ये आगे चलते हैं। ये देखिए, फिगर 2 में मोल्ड की असेंबली शो कर रहे हैं। ये जो सेकंड हैगा, अल्युमिनियम ऑक्साइड इसमें डाला, फिर इसके बाद वो ग्रीन केक बन जाता है। क्रेक को इसको कट कर देते हैं, फिर डीमोल्डिंग करते हैं फिगर 5 में। नीचे देखिएगा तो उसकी वायर कटिंग करी है इसके अंदर में, फिर हॉरिजॉन्टल कटिंग करके लार्ज ब्लॉक क्रिएट कर देते हैं इसके अंदर में। फिर इसके बाद में ऑटोक्लेविंग के लिए चली जाता है, 10 to 12 आवर से ज़्यादा ज़रूरत नहीं होती है। ये पूरा process है, it requires an industrial process of manufacturing, can't be done at site. CLC block is similar to AAC. The only thing is what we use is the sand, cement and the foaming agent. And these blocks can be produced at site with the small machines. आप ये छोटा सा प्लांट देखिए फिगर 3, ये साइट पे मेरे किसी में लगाया था कालका जी में, दिल्ली में, और इससे हमने CLC ब्लॉक्स बना के मल्टी स्टोरी बिल्डिंग में यूज किए। ये फोम जनरेटर है, और इसको मिक्स करते हैं फोमिंग को मोल्ड्स के अंदर में, ये डिफरेंट मोल्ड्स ब्लॉक्स के अंदर। देन दिस इज अ प्रीफैब्रिकेटेड हॉलो परफोरेटेड स्ट्रक्चरल क्ले ब्लॉक। ये जो आप ब्लॉक्स देख रहे हैं ये क्ले है, लेकिन ये कंप्रेस्ड क्ले है और फायर्ड क्ले है इसके अंदर। बट दीज आर दी काइंड ऑफ ब्लॉक्स दैट यू हैव मैन्युफैक्चर्ड। ये कुछ प्लांट्स हैं इंडिया के अंदर में, झज्जर में एक प्लांट है, बेंगलोर में एक प्लांट है जो ये मैन्युफैक्चर करते। आगे चल, दिस इज हाउ दी ब्लॉक्स आर लेड, ये मैं शॉर्टकट में दिखाया है। अलाइनमेंट कैसे करनी है, उसके बाद ब्लॉक्स नेक्स्ट कैसे लगाने हैं। ये अंडर कंस्ट्रक्शन है, कुछ बिल्डिंग अंडर कंस्ट्रक्शन, कुछ कंप्लीटेड है। ये ब्लॉक्स ले करते हुए ये बिल्डिंग कंप्लीट होगी। then the next is the, थोड़ा सा is the prefabricated masonry। आपने अभी तक तो प्रीकास्ट सिस्टम कंक्रीट का सुना है, अभी तक इंडिया में ये प्रीफैब्रिकेटेड masonry कॉन्सेप्ट आया नहीं है अभी, बट आई हैव ट्राइड बट ऑन a smaller scale। इसके लिए पूरा एक इंडस्ट्रियल प्लांट लगा सकते हैं, लाइक ए प्रीकास्ट कंक्रीट यूनिट। इस लेफ्ट में आप देखिए, ये पूरा का पूरा एक कास्टिंग यार्ड है पूरा इसके अंदर में, जिसके अंदर में ब्रिक, आपको ब्रिक के कोर्सेज दिख रहे होंगे, और हॉरिजॉन्टल कट्स दिख रहे हैं, मींस पैनल्स। ये पैनल की हॉरिजॉन्टल कास्टिंग है फिगर 9 में। फिगर 10 में क्या है कि जब उसको उठा लेते हैं तो क्या पोजीशन आती है, कॉर्नर्स कैसे टूथिंग क्रिएट करते हैं। नेक्स्ट फिगर 11 में देखिएगा कि ये ब्रिक वॉल का फिनिश्ड वॉल पैनल है। फिगर 15 में और 16 में आप देखेंगे तो ये पैनल को कैसे उठाते हैं मोल्ड के साथ में इसके अंदर में। नेक्स्ट ये 16A 16B 16D ये ऑल शो 18 ये शो करती है प्रोसेस को पूरा। कॉर्नर एल कैसे बनाना है उसका सब ऑल प्रीफेब्रिकेटेड है बेस सिस्टम। 21 देखें तो पूरा लार्ज पैनल को लिफ्टिंग कैसे करते हैं इसके अंदर। वो आप उसको स्ट्रिप बांधेंगे बिकॉज यू जस्ट कांट लिफ्ट इट लाइक ए कंक्रीट पैनल जिसमें हुक लगा के नहीं कर सकते हैं, क्योंकि ये बॉन्डिंग जो इसके अंदर में ब्रिक वर्क की है छूट जाएगी इसके अंदर में। तो इसका मेथड ऑफ लिफ्टिंग एंड इरेक्शन इज डिफरेंट देन द कंक्रीट पैनल। ये कुछ लिफ्टिंग एंड कैरिंग दिखाया हुआ है। ये स्टोरेज है रैक्स कैसे इसके अंदर ब्रिक पैनल्स का। ये पैनल्स के लिफ्टिंग का सिस्टम्स। और इसके अंदर में आप देखेंगे कि फ्लाई ऐश ब्रिक और रेड ब्रिक का कॉम्बिनेशन करके कुछ पैनल के अंदर में डिजाइन बनाया गया एस्थेटिक क्रिएट करने के लिए, कुछ आर्किटेक्चरल फीचर्स है। ये सब प्री फैब्रिकेटेड मैसनरी का कुछ व्यूज फोटोग्राफ्स हैं इसके अंदर में। ये अलाइनमेंट कैसे की, वर्टिकल कैसे खड़ा किया। Then we come to the use of stone. Stone का हिल एरिया में बहुत यूज होता है, बट द वॉल्स हैव टू बी वेरी थिक, सो वी कैन यूज द कंक्रीट ब्लॉक। स्टोन क्रीट ब्लॉक मेसनरी बोलते हैं। हम उस स्टोन को यूज कर सकते हैं और ब्लॉक्स बना सकते हैं प्री फैब्रिकेटेड करके। देन वी कैन यूज इट एज ए मेसनरी। नॉर्मल साइज जो है इसका ब्लॉक का 402 डिफरेंट साइजेस है, मॉड्यूलर फॉर्म में है। 300 लेंथ भी है, 400 भी है, विड्थ इसकी 200 150 100 सब साइज के हम सकते हैं। ये सिंगल मोल्ड दिखाया मैंने इसके अंदर में। ये आगे नेक्स्ट में चलेंगे। ये देखिए ये मल्टीपल मोल्ड है फिगर 8 में, जिसमें एक बड़ा स्टोन 2 या 3 रख के फिर इसमें प्लम कंक्रीट डालते हैं। प्लम कंक्रीट मींस 148 146 1510 डिपेंडिंग अपॉन द स्ट्रेंथ रिक्वायर्ड। एंड देन फिगर 10 शोज हाउ द कॉम्पैक्शन इज डन। ये 16 में आप देखेंगे तो इसमें भी एक टोटल मोल्ड का मल्टीपल मोल्ड्स कास्टिंग हो रही है, कॉम्पैक्शन हो रहा है। ये अगर आपको वर्टिकल रीइंफोर्समेंट अर्थक्वेक के लिए डालनी है इसके अंदर में, या कोई भी रीइंफोर्समेंट डालनी है, तो हाउ टू क्रिएट द होल इन दिस बिकॉज इट कांट बी कट। तो एक वुडन पीस उसके अंदर में रख देते हैं जिसको कंक्रीट में मोल्ड में बाद में बाहर निकाल लेते हैं, जो हाफ राउंड मोल्ड बन जाता है। ये देखिएगा कास्ट करते हुए बहुत आगे चले। बस ये फिगर दिखा दें जरा ऊपर। इसका राइट में क्लोजअप देखेंगे व्यू, तो आप ये देखेंगे ये बड़ा बड़ा स्टोन जो है ये दिखता है इसके अंदर एलिवेशन के अंदर। ये राजस्थान हाउसिंग बोर्ड का हमारा प्रोजेक्ट था। प्रीकास्ट रिवर स्टोन कंक्रीट रिवर के अराउंड ये राउंड शेप के ओवल शेप के पेबल्स बहुत मिलते हैं। ये दिस कैन ऑल्सो बी यूज्ड इन क्रिएटिंग द ब्लॉक्स इन दोज प्लेसेस। इंस्टेड कि आप क्वेरी से लेके आए, इन्हीं को आप यूज कर सकते हैं बोल्डर्स को। तो मैथडोलॉजी वही है कि इसके ब्लॉक बनाइए। ये मशीन है वाइब्रो कॉम्पैक्शन मशीन, और ये एक डेमोन्स्ट्रेशन हाउस है जो CBRI रुड़की के कॉम्प्लेक्स में बनाया गया है इसी से। Then we come to the precast concrete panels, small panels. I am promoting only small panels. ये फंडामेंटल सिस्टम्स है इसका थोड़ा सा। हाउ टू कनेक्ट द पैनल, ये इंपॉर्टेंट पार्ट होता है। आप पैनल के ऊपर पैनल रखते हैं तो उसका कनेक्शन कैसे करेंगे, तो ये कनेक्शन शो करने के लिए ये मेथड है इजीएस्ट। एक ये ट्यूब मेंबर होता है जो नीचे वाले मेंबर में डाल देते हैं, और उसमें से आपका रॉड चली जाती है ट्यूब में, और फिर इसको ग्राउट कर दिया जाता है बोथ टॉप एंड बॉटम कनेक्शन के लिए। नेक्स्ट, then there are various method of small panel systems. One is the clamped vertical wall element system. मैं 4-5 कुछ systems हैं 18-19 जिसके वो मैं आपको समझाऊंगा इसके अंदर में। This is the first system is, आप लेफ्ट में देखेंगे तो ये वॉल पैनल्स हैं वर्टिकल, ऊपर रूफ है जो भी आप डालना चाहते हैं। सेक्शन बना हुआ है इसका कि ये वॉल पैनल है, एंड देन इट इज फिक्स्ड अप इन द प्रीकास्ट फाउंडेशन। Then precast हॉरिजॉन्टल वॉल एलिमेंट सिस्टम, आप ये देखेंगे हॉरिजॉन्टल वॉल है जिसमें टूथिंग हुई हुई है, टॉप एंड बॉटम, मेल फीमेल एंड है, और जॉइंट पे वाटर ग्राउंड करके इनफिल कर दिया। ये राइट को एक बिल्डिंग है जो हमने बनाई थी जम्मू में फॉर रेलवेज। ऐसे साइट ऑफिस बनाए गए थे जब जम्मू की रेलवे लाइन लग रही थी, ये उस वक्त का प्रोजेक्ट, अबाउट 20 ईयर्स अगो। पोस्ट एंड प्लेट सिस्टम, आप जैसे देखेंगे इसमें एच शेप के कॉलम है, और पैनल्स जो है वो कैसे इसके अंदर में ज्वाइन करते हैं। सो मेन पॉइंट इज द जॉइनिंग सिस्टम, एंड्स और जॉइंट्स कैसे होते हैं इसके अंदर। चलिए नेक्स्ट। अब इसी को देखेंगे तो वो कॉलम जो है पोस्टल प्लेट सिस्टम में कॉलम इंटरनल होगा। उसमें क्या था, दोनों एंड पे वो कॉलम दिखता है, इसके अंदर में इंटरनल सिस्टम हो जाता है। सिस्टम वही है, पोस्ट एंड प्लेट सिस्टम। कॉर्नर भी देखिए कैसे कॉलम क्रिएट करते हैं, ऑल प्रीकास्ट सिस्टम, कॉलम इज आल्सो प्रीकास्ट एंड वॉल पैनल्स आल्सो प्रीकास्ट। प्रीकास्ट में डायमंड शेप कनेक्शन, अब इसमें देखेंगे कि जो पैनल्स के जो एंड्स हैं वो डायमंड शेप कट है, और जो कॉलम है वो भी डायमंड शेप का बन जाता है। नेक्स्ट, देन दिस इज ए मिड बाई सिस्टम। आप इसमें देखेंगे तो इसमें क्या सिस्टम, थोड़ा सा उसके ऊपर चले जाओ। हाँ, इसमें क्या है कि प्रीकास्ट पैनल को फिक्स करने के लिए एक टॉप में चैनल लगाते हैं, एक बॉटम में चैनल लगाते हैं। और लेफ्ट में अगर आप ध्यान से देखेंगे, ये राइट को लॉकिंग रॉड जो है उसके बीच में डाल दिया उसके अंदर में, टू कनेक्ट द टॉप एंड बॉटम एंड टाइटन इट आउट। इससे प्री स्ट्रेसिंग भी क्रिएट कर सकते हैं, दोनों मेथड उसमें। नेक्स्ट, ये डिफरेंट ट्रेड नेम्स हैं, ये सारे नेम्स हैं ट्रेड नेम्स हैं। मॉडर्न क्रीट रिब्ड पैनल सिस्टम, अब आप इसमें देखेंगे जो पैनल है वो एक रिब्ड फॉर्म में, बट रिब्ड इज नॉट 90 डिग्री, रिब्ड एट एन एंगल, दिस टू have a particular type of joint. The joint is filled with caulking, grouting, or with mastic, or any other grout material. Next, weights, ये एक रिब्ड पैनल, ये भी वेट्स के नाम से रिब्ड वेट्स रिब्ड पैनल सिस्टम है। इसका भी आप देखें, ओनली थिंग इज सीधे है सब पैनल ही, हाउ द पैनल इज आर जॉइंटेड, ये सब जॉइंट्स कैसे कराया जाता है ये शो कर रहे हैं हम इसके अंदर। क्रिको प्रीकास्ट सिस्टम, इसको देखेंगे आप ध्यान से, लेफ्ट में ये पैनल हमने शो किया है विद कॉलम्स, और ये कैसे सेक्शन काटा है, ये कैसे इसके अंदर में जॉइंट हो रहा है कॉलम पैनल के साथ, पैनल टू पैनल। ये भी सेकंड फिगर है उसी की, एक एल जंक्शन है। ये यूरो सिस्टम है, इस यूरो सिस्टम के अंदर में जो कॉलम आप देख रहे हैं इसमें डिफरेंट डिफरेंट टाइप ऑफ स्लॉट्स है। अगर आपको एल वॉल बनानी है तो कैसे है, टी जंक्शन करना है तो कैसे आएगा, सेंट्रल चारों तरफ में वॉल है, सेंट्रल कॉलम है तो कैसे आएगा, ये स्लॉट्स काटे आते हैं। और लेफ्ट में देखेंगे तो इसका एक पर्सपेक्टिव व्यू हमने बनाया हुआ है। ये है प्रीकास्ट बूट पियर एंड पैनल सिस्टम। इसमें क्या है कि दो पैनल्स हैं उसको कैसे ज्वाइन करते हैं, और पैनल टू पैनल कैसे ज्वाइन करते हैं ये शो किया हुआ है। डीओ पैनल सिस्टम, इसका भी देखिए जो पैनल्स हैं उसका जॉइंटिंग सिस्टम क्या है कि दोनों के अंदर में पैनल के जो एंड्स हैं वो टेपर्ड है, और बीच में जो कॉलम क्रिएट होता है वो स्ट्रेट नहीं है, वो पैनल टू पैनल भी है, वो जो बीच में दोनों वाइस के बीच में जो गैप है उसको भी वो कवर करता है, टू गिव ए बेटर स्टेबिलिटी। ये इसका फिगर 3 में इसका आइसोमेट्रिक। दिस इज विंगेट सिस्टम, इसमें ध्यान से देखेंगे तो इसमें भी ऐसे ही है, ये दो पैनल्स को जोड़ा है और उसके बीच में जो कॉलम्स जॉइंटिंग क्रिएट किया गया वो कैसे है, लेफ्ट में इसका आइसोमेट्रिक शो किया। दिस इज द स्वैन सिस्टम, ये थिन पैनल्स हैं, ये फेरोसीमेंट के भी हो सकते हैं, प्रीकास्ट पैनल्स हैं, और कैसे कॉलम के साथ इसको प्रीकास्ट में जॉइंटिंग की जाती है। ये इसका कॉर्नर कॉलम डिटेल है। Then this is the hybrid पियर एंड पैनल सिस्टम, दोनों का हाइब्रिड है बीच का इसके अंदर में। तो ये भी आप फिगर 4 में देखेंगे तो वर्टिकल सेक्शन है, और ये फिगर 2 में इसका पार्ट सेक्शन टॉप व्यू है, और लेफ्ट में इसका आइसोमेट्रिक है। दिस इज द स्मार्ट प्रीकास्ट ब्रिक पैनल एंड सीआरएफ कॉलम सिस्टम। सीआरएफ शायद आप समझते होंगे, कोल्ड रोल्ड फॉर्म सेक्शन, जिसको लाइट गेज भी हम बोलते हैं, स्टील, ये उसका तो ये कॉलम है। और प्रीकास्ट जो पैनल है वो ब्रिक पैनल है। थोड़ा सा ऊपर चलिए, ये कॉलम्स हैं खड़े किए फाउंडेशन में, ये ब्रिक पैनल इरेक्ट कर रहे हैं। फिगर 5 में 1C फिगर देखेंगे तो जंक्शन जॉइंट शो किया गया है बिल्डिंग का। Then these panels can be made of cellular waste also. You know, we got lot of waste. Cellular means lightweight aggregate. AEC block, CLC block, साउथ में सेलुलर ब्लॉक्स बनते हैं, उसका सबका जो वेस्ट होता है उससे भी हम ब्लॉक्स बनाते हैं, पैनल्स बनाते हैं, वॉल पैनल्स एंड कॉलम्स ऑल्सो। ये उसका सिस्टम शो किया हमने, कैसे पैनल बनता है, ये कॉलम्स कैसे बनते हैं, जॉइंट कैसे होता है। ये स्टेजेस हैं, बीम का बेस बनाया, फिर कॉलम को एलिमेंट बनाया, फिर पैनल को इंसर्ट किया, फिर सेकंड लेयर बनाया उसका। ये असेंबलिंग इन प्रोग्रेस है, असेंबली कंप्लीट गई, फिर टॉप रिब जो ऊपर किया उससे फिक्स कर दिया। दिस इज पॉली कॉन्क्रीट लाइट वेट प्रीकास्ट पैनल सिस्टम। ये हमारे इंडिया में लाइट वेट कॉन्क्रीट का यूज बहुत कम होता है कंपेरेबल टू द वेस्टर्न कंट्रीज, बिकॉज लाइट वेट एग्रीगेट इज नॉट अवेलेबल इन दिस कंट्री, इट इज वेरी कॉस्टली। So to make it a lightweight, another method is mixing of the EPS beads in cement concrete. But there is a limit. इसके बहुत सारे details हैं. We can't mix the EPS beads by volume more than 30%. Otherwise वो segregation हो जाएगा, concrete के साथ उसका adhesion नहीं होगा। तो ये एक section show किया हुआ है, पैनल का सेक्शन, राइट को फिगर 1B में। 1A में इसका वर्टिकल सेक्शन है नीचे। ये स्टैक्ड पैनल्स हैं जो बनाए जाते हैं चीज में, इसके लिए मशीन्स हैं थोड़ी सी। ये जॉइंटिंग सिस्टम है उसका, मेल फीमेल का इनका। ये आप देखिएगा नीचे, दिस इज द एक्चुअल साइट वर्क। दिस वर्क वी डिड इन द INA दिल्ली for the NBCC building. How the panels are erected, the bottom and top, how it is fixed, how it is locked. You must have heard the code wall panels, hollow code. नाम सुना होगा चीज में। How we can make the precast lightweight concrete code wall panels with EPS mixed concrete lightweight करने के लिए, और with the easiest method of construction. Next में चल, ये hollow core wall panels हैं, but this is a plant which has been established in Chennai, जिसमें वर्टिकल बैटरी मोल्ड सिस्टम डेवलप किया गया है, और रोलर्स लगा दिए हैं टू क्रिएट द कोर्स। उस रोलर से क्या करते हैं कि जो पाइप्स होती हैं उसको वो टेक आउट कर लेते हैं विद जर्किंग, और स्क्रू कन्वेयर यूज करते हैं मटेरियल्स वो मिक्स करके उसमें डालने के लिए। These are the panels you are being shown, how the panels are, demolded. 9A में आप देखेंगे ये हाइड्रोलिक सिलेंडर्स हैं फॉर क्रिएटिंग कोर्स। 9B में आप ध्यान से देखेंगे, these are the cylindrical panels which have been placed before precasting. ये बीच में मोल्ड के बीच में दिया गया, तो मल्टीपल मोल्ड जो हैं एट वन टाइम कैन बी कास्टेड। नीचे आप देखेंगे तो ये पैनल्स डीमोल्डिंग के बाद में पैनल्स कैसे निकलते हैं। ये कुछ जॉइंटिंग सिस्टम्स हैं, टेक्निकली डिटेल्स हैं थोड़ी सी इसके। जी, ये हाउ टू इरेक्ट द पैनल्स। I'm going fast because there are so many slides, so time is less. Just let me. Now we'll come to the roofing system. This is prefabricated brick panel system, RB panel. This can be done manually also. This can be done semi-mechanized method also. Industry can also be established where the brick is cheaper, where the higher strength of brick is available. This technology is very useful. Villages के अंदर में बहुत easily work कर सकते हैं. People's की liking है, insulation है. There are many benefits of this. ये देखिए पैनल्स को लेफ्ट में कास्ट करके रखा हुआ है, राइट में आप देख रहे हैं तो पार्शियली प्रीकास्ट जॉइस्ट है, जिन जॉइस्ट टू जॉइस्ट के बीच में इन पैनल्स को इरेक्ट करते हैं. ये देखिए पैनल को इरेक्ट. ये ग्रेटर नोएडा अथॉरिटी का जो ऑफिस है सेक्टर गामा में, ये सब वहाँ की फोटोग्राफ्स हैं. कुछ बिल्डिंग्स हैं लेफ्ट में शो कर, नीचे से सीलिंग व्यू. चलिए इसी पैनल को अगर मैं थोड़ा सा कर्वेचर दे दूं तो ये आर्च शेप में बन जाता. वी कैन सेव स्टील, इट गिव्स हायर स्ट्रेंथ. ये राइट को देखें तो ये पैनल्स हैं, लेफ्ट में इन पैनल्स को जॉइस्ट टू जॉइस्ट प्लेस किया हुआ है. फिगर 15 में देखेंगे तो सीलिंग व्यू है. नाउ दिस इज अ टेक्नोलॉजी विच इज नेम्ड एज बीम एंड ब्लॉक फ्लोर सिस्टम, बी प्लस बी एफ सिस्टम. ये बीम्स आप देख रहे हैं फुल्ली प्रीकास्ट है, और जो ब्लॉक है ये लाइट वेट कंक्रीट ब्लॉक बनाया गया है और सॉलिड ब्लॉक है. ये ब्लॉक लेफ्ट में रखते हुए ये प्रोसेस शो किया है. बीम्स का रखे बीच में ब्लॉक डाल देते हैं और इसके ऊपर में फिर आप इन सिटू कंक्रीट का लेयर डाल दें विद मैश रीइंफोर्समेंट फॉर मोनोलिथिक इफेक्ट. ये टेक्नोलॉजी है प्रीकास्ट होलो कंक्रीट ब्लॉक पैनल सिस्टम. आप ये प्रीकास्ट ब्लॉक्स कंक्रीट के भी मिलते हैं, ये क्ले के भी मिलते हैं. कंक्रीट का अगर यूज करते हैं तो सी हाउ द ब्लॉक्स कैन बी जॉइंट टुगेदर, सी फिगर 4, टू फॉर्म ए बीम और फॉर्म ए स्लैब. ये पूरा का पूरा स्लैब एलिमेंट है. ये बीम एंड स्लैब दोनों कॉमन एक्ट कर रहा है. इसमें जो ग्रूव्स हैं टॉप में उसमें रीइंफोर्समेंट डाला जाता है चीज में. और जो आप फिगर 2 में देख रहे हैं, दिस इज मेथड बाय विच वी कैन अलाइन द ब्लॉक्स इन लाइन क्विक असेंबली के लिए. नेक्स्ट नीचे में ये देखिए ये शो किया हुआ है हाउ द रीइंफोर्समेंट इज प्लेस्ड इनटू दिस. देन दिस इज इन्वर्टेड. इसको बॉटम, ये जो रीइंफोर्समेंट टॉप वाला फेस है वो नीचे आ जाएगा. और राइट, एक सेकेंड, आप राइट में ये देखिए सेमी मैकेनाइज्ड मेथड, हाउ द मोटर फिलिंग इन डन. जो मेसन है वो मोटर जो है वो फिल कैसे करेगा. ये एक छोटा सा इक्विपमेंट है, आप उसमें डाल दीजिए, इसको आप स्ट्रेच ऑन करिए, वो मोटर अपने आप जॉइंट के अंदर में फिलअप करते जाए. ये है प्रीकास्ट ट्रेपिजो पैन रूफिंग फ्लोर सिस्टम. ये 100 mm के स्लैब को 120 mm स्लैब या 150 mm के स्लैब का एक ऐसा शेप क्रिएट किया गया है जिसके अंदर में मेंबर इज वेरी थिन. मेंबर सिर्फ 30 मिलीमीटर है टोटल, 25 to 30 मिलीमीटर, लेकिन उसका शेप ऐसे क्रिएट किया है दैट वी सेव द कंक्रीट. और कंप्रेशन का बेनिफिट ले रहे हैं बाय गिविंग दिस शेप, कंक्रीट इन कंप्रेशन. ये कास्टेड पैनल फिगर 2 में है. ये बोल्ड भरते हुए फिगर 8 में, लेफ्ट में थोड़ा सा आगे नीचे वाला, ये मोल्ड का फिलिंग करते हुए ये यूनिट्स को रूफ में रखते हुए चीज में, और ये फिनिशिंग कर. When this is a precast trough unit hybrid system, ये जो अभी मैंने आपको वो दिखाया ये एक और टाइप का ट्रफ है. दिस इज नॉट ए वेफल. ये ट्रफ जो है ये दोनों साइड से इसका, चलो थोड़ा सा ऊपर करें, ये इसका थोड़ा सा एंड आप देख रहे हैं इसके अंदर में ये बेंड मिला हुआ मिल रखते हैं. इन when the two or these panels are joined together, we cast in situ beam can be created without shuttering in this. And it's the total system is a two-way slab system. ये फोटोग्राफ है ड्यूरिंग कंस्ट्रक्शन की, ये सीलिंग व्यू है। एक प्रीकास्ट प्लेट फ्लोर सिस्टम, व्हाट इज अ प्लेट फ्लोर सिस्टम? प्लेट फ्लोर सिस्टम का मतलब ये, आप लेफ्ट में देखें फिगर 1 में, ये टोटल प्रीकास्ट पैनल है, लेकिन उसमें बीच का जो पोर्शन है वो तो फुल्ली कास्टेड है, लेकिन एंड के जो पोर्शन हैं वो हाफ कास्ट है, और उसमें रीइंफोर्समेंट उसमें डाल करके एक्स्ट्रा इसको फिर इन सिटू फिलअप कर देते हैं। तो ये कंपोजिट सिस्टम बन जाता है इन सिटू एंड प्रीकास्ट सिस्टम का। द एडवांटेज इज दिस कि जो प्रीकास्ट सिस्टम है वो शटरिंग का भी काम करता है इसके अंदर में ये, और जो इन सिटू सिस्टम है उसकी बॉन्डिंग हो जाती है। तो देन यू डोंट नीड अनदर एक्स्ट्रा लेयर ऑफ कंक्रीट, जिसको हम डायफ्राम एक्शन के लिए कंक्रीट को बोलते हैं, डालने की जरूरत नहीं पड़ती है ये। तो आप ये फिगर 3 में देखिए डिटेल इसकी, आगे चलिए। दिस इज द सिस्टम कॉल्ड एज प्रीकास्ट डब्ल्यू पैनल सिस्टम। ये सीबीआरआई की डेवलप टेक्नोलॉजी है। डब्ल्यू पैनल जो है छोटा पैनल है, पैनल के ज्वाइन किया हुआ है, लेकिन आप इसकी शेप देखेंगे तो ट्रफ शेप है इसकी टोटल। तो इसका जो राइट में आप देख रहे हैं फ्लोर सिस्टम करते हैं, तो जो ट्रफ के हॉन्चेज हैं इनको फिलअप कर देते हैं। रूफ में हॉन्चेज की जरूरत नहीं है, वो रेन वाटर गटर की तरह काम करता है। दिस इज अ प्रीकास्ट आरसीसी हॉलो कुल्लर स्लैब सिस्टम। आपने कुल्लड़ देखा हो, कुल्लड़ समझते हैं, शिकोरा समझते हैं, या जो भी आप उसकी लैंग्वेज को समझते हैं चीज में। ये कुल्लड़ जो है क्ले के बनते हैं, और इसको हाफ बेक करके ये मार्केट में बनाते हैं, मास स्केल में बनाते हैं। दिल्ली के अंदर में पूरी एक कॉलोनी है, नोएडा कुम्हार कॉलोनी। ये इस कॉलोनी में सिर्फ कुम्हार का मतलब यह है कि सिर्फ कुल्हड़ ही बनाते हैं उस चीज के ऊपर। दिस इज माई ओन इन्वेंशन, जिसका मैंने पेटेंट लिया हुआ है। 1977 में मैंने इसका पेटेंट लिया था। ये पैनल है जो आप देख रहे हैं इसके अंदर में रीइंफोर्समेंट। सबसे राइट साइड में फिगर 3 में देखिए कुल्हड़ उल्टा करके रहे। पहले क्या करते हैं, बॉटम कंक्रीट डालते हैं, उसमें रीइंफोर्समेंट डालते हैं, और फिर उसके बाद कुल्हड़ प्लेस करते हैं, और फिर कंक्रीट भर देंगे। तो उससे एडवांटेज ये मिलता है कि कुल्हड़ उसके अंदर में रह जाते हैं अराउंड न्यूट्रल एक्सिस। तो न्यूट्रल एक्सिस के अराउंड हमें जो वॉइड्स मिलता है, इतने हम कंक्रीट को सेव कर लेते हैं। स्ट्रक्चर बिकम लाइट वेट, स्टील कम लगता है, प्रीकास्टिंग हो जाता है, सर्टेन एडवांटेज। पैनल को छोटा भी कर सकते हैं आप। 4A फिगर में देखिए छोटे पैनल कास्ट कर रहे हैं हम, 4B में ये, और 5 में देखिए वो पैनल को जॉइस्ट टू जॉइस्ट प्लेस कर रहे हैं। इसी सिस्टम को हमने फिर फर्दर और डेवलप किया। अगर हम स्कूलर सिस्टम को, नहीं अभी अभी नहीं, ये उसी का, तो आगे चल, ये उसके पार्ट सेक्शंस हैं थोड़े से, आगे चल। ये कुल्लड़ का एक पर्टिकुलर सेक्शन दिखाया, ये हमने दिखाया। ये एक मल्टी स्टोरी बिल्डिंग है होटल कोहिनूर लखनऊ में। इसकी जो फ्लोर्स हैं सारे, हमने इस सिस्टम से वहाँ, और एक बिल्डिंग हमने भोपाल में बनाई जहाँ ये टेक्नोलॉजी यूज की गई। ये 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 टेक्नोलॉजी है ये अनदर टेक्नोलॉजी है जहाँ कुल्हड़ को हमने थोड़ा और नीचे, नहीं नहीं, ऊपर वाला, ऐसे ऊपर देखें, अच्छा ठीक है, ओके। जिस उसी कुल्हड़ को अगर हम हॉरिजेंटली जॉइन कर दें तो क्रिएट ट्यूब, तो क्या होगा, दो दो कुल्हड़ को हमने ज्वाइन किया, इसके बाद में डिस्ट्रीब्यूशन रीइंफोर्समेंट डाला, मेन रीइंफोर्समेंट तो है ही अलोंग द लॉन्गर एक्सिस, इसके अंदर में इट बिकम्स ए प्रीकास्ट पैनल। ये देखिए, ये इसका क्रॉस सेक्शन है, दो सेक्शन, राइट को ये पैनल को कास्ट करते हुए, चलिए। इसी पैनल को अगर मैं थोड़ा सा आर्चिंग एक्शन दे दूं तो इसमें रीइंफोर्समेंट की जरूरत नहीं पड़ती, उसी पैनल। दिस इज ए टेक्नोलॉजी कॉल्ड एज प्रीकास्ट वेफल कसान स्लैब सिस्टम। ये तो आपने देखी होगी टेक्नोलॉजी, इंटरस्टेट बस टर्मिनस है या जहाँ लार्ज स्पैन्स है वहाँ ये यूज किया जाता है प्रीकास्ट वेफल, ये प्रीकास्ट शेप है उस वेफल की जो प्रीकास्ट करते हैं। देन दिस इज प्लेस्ड उसका शटरिंग नहीं करते हैं, बट इसके बॉटम के एंड्स में अंदर में सपोर्ट्स लगा देते हैं, और जो जॉइंट दोनों का बनता है उसमें रीइंफोर्समेंट डाल के स्मॉल रिब्स बन जाती है, इन सिटू रिब्स। नेक्स्ट, ये देखिए, ये ये लार्ज स्लैब, ये सीलिंग है। ये है प्रीकास्ट हॉलो कोड स्लैब स्टोन, दिस इज यू मस्ट हैव नोन, बहुत कॉमन है। लेकिन ये इसकी कॉन्सेप्ट है वो ये है कि हॉलो कोर क्रिएट करने के लिए ट्यूब्स इसके अंदर में पाइप्स डाले जाते हैं। इसको कंक्रीट से फिलअप करने के बाद में दीज पाइप्स आर टेकन आउट विद इन 30 मिनट्स, बिकॉज 30 मिनट्स के अंदर में कंक्रीट की इनिशियल सेटिंग हो जाती है। अगर लेट करेंगे तो स्टिक कर जाएगी कंक्रीट, वो निकलता नहीं है। ये लेफ्ट में निकालते हुए राइट को ये मल्टीपल इसी होल होल की बजाय, राउंड की बजाय इसको अगर हम हेक्सागोनल शेप दे दें तो क्या पोजीशन हो। Then how to use this hollow core system with steel beam, composite steel beam section, ये उसकी डिटेलिंग। This is a system called as a beam panel BP system. ये छोटे छोटे पैनल्स हैं, 600 मिलीमीटर बाई 600 मिलीमीटर। द टोटल थिकनेस इज 35 mm, और 2 mm वायर्स यूज करते हैं, या आप मैश यूज कर लें इसके अंदर में। राइट को फिगर 4 पे देखेंगे कास्टिंग करते हुए। फिगर 8 में ये साइट के ऊपर में किसी ने कहा ये बहुत छोटे पैनल है, टूट जाएंगे, तो हमने उनसे कहा भैया तुम खुद खड़े हो जाओ। ये इंजीनियर साहब है, एक साथ में एक मेसन है, देख लो कितना, और जर्किंग कर लो, पैनल नहीं टूटा उनसे। ये बीम्स आप देख रहे हैं प्रीकास्ट है। फिगर 20 में ये ट्राईपॉड लगा करके पैनल्स को लिफ्टिंग की जा रही है। ये पैनल्स 21 फिगर में ले किए गए हैं, रेडी फॉर स्क्रीडिंग कंक्रीट। फिगर 22 में देखें, ये 6 स्टोरी बिल्डिंग है दिल्ली के अंदर सावन पार्क में, जो हमने बनाई थी इसी टेक्नोलॉजी में। ये राइट में ग्रेटर नोएडा अथॉरिटी का गामा सेक्टर का ऑफिस है जो बनाया था। ये लेफ्ट की आगे चल, ये कुछ फैक्ट्री बिल्डिंग्स हैं, हर तरह की बिल्डिंग बनाई इसमें, मोदी नगर में कुछ बनाया, दौराला मेरठ की बिल्डिंग्स हैं। इस टेक्नोलॉजी में करीब 2-2.5 लाख स्क्वायर फीट एरिया का हमने काम किया। दिस इज प्रीकास्ट आरसी प्लैंक्स एंड जॉइस्ट सिस्टम डेवलप्ड बाय सीबीआरआई लॉन्ग अगो। ये 62-63 के आसपास उन्होंने डेवलप की थी। मैंने इसको मास में यूज किया है, और करीब 2 करोड़ स्क्वायर फीट एरिया इस पे कर चुका हूँ इस टेक्नोलॉजी के ऊपर। इसे जस्ट समझा दूं थोड़ा सा चीज में। ठीक बात, ये ध्यान से देखेंगे तो इसमें प्रीकास्ट जॉइस्ट है विच इज हाफ कास्ट, जिसे हम जॉइस्ट को हम पार्शियली प्रीकास्ट बोलते हैं। या पैनल्स दिख रहे हैं, 3 पैनल जैसे दिख रहे हैं, द पैनल्स आर ऑल्सो पार्शियली प्रीकास्ट। बीच का हिस्सा जो है वो 60 मिलीमीटर है, सबसे एंड का 30 है। बीच में अगर आप देखेंगे वो टेपर किया हुआ है। इतने दुनिया भर की इसमें हॉन्चेस क्रिएट होती है, जिसमें हम फिर रीइंफोर्समेंट डाल के और इन सिचु कंक्रीट कर देते हैं। दिस इज द फंडामेंटल प्रिंसिपल ऑफ टेक्नोलॉजी इन दिस। ये एक एक्सप्लेनेशन दिया हुआ है, ये इसकी डिटेलिंग है पैनल प्लान की। ये पैनल हमने स्टैंडर्डाइज किया हुआ है 300 मिलीमीटर का विड्थ का। ये मशीन है कास्टिंग, ये प्रोसेस है, ये मशीन है जिससे हम कास्ट करते हैं। ये देखिए राइट को, ये प्लैंक्स, दो दो प्लैंक्स एट ए टाइम कास्ट होते हैं। ये प्लैंक उठाते हुए स्टैक करते हुए ये क्योरिंग हो रही है। लेफ्ट में ये बेड ब्लॉक्स हैं, ये पार्शियली प्रीकास्ट जॉइस्ट है। राइट को ये मशीन है जिससे हम इसको कर, ये सारे जॉइस्ट कास्ट करके रखे हैं। ये लिफ्टिंग करते हुए राइट को, ये भी मैकेनिकल लिफ्टिंग है, जॉइंट भरते हुए। ये व्यूज है। ये ये 5 स्टोरी बिल्डिंग है, मल्टी स्टोरी आरसी प्लान। देन दी प्रीकास्ट आरसी जॉइस्ट एंड हॉलो कंक्रीट फिलर ब्लॉक सिस्टम। ये है कुछ नहीं, सिंपल है। जॉइस्ट तो है ही आरसीसी का इसके अंदर में प्रीकास्ट, और ये जो ब्लॉक है इसकी एक शेप है। ये शेप जो है आप कंक्रीट का ब्लॉक भी बना सकते हैं, क्ले ब्लॉक भी मैन्युफैक्चर करते हैं इसके कंपनी। चलो कोई ना, दिखा देते हैं। This is filigree. Filigree is a name given to a PCF half slab system, यानी कि स्लैब का अगर आप फिगर 1 में देखें तो बॉटम पोर्शन इज प्री कास्टेड, द टॉप पोर्शन इज कास्ट इन सिटू। तो उसको दो हिस्सों में अगर इसको बना दिया जाए तो बॉटम पोर्शन जो है वो बॉटम नेगेटिव रीइंफोर्समेंट रख के बॉटम का कंक्रीट कास्ट होता है, टॉप वाला कंप्रेशन मेंबर बन जाता है। और दोनों के बीच में अगर ये डायग्राम नेक्स्ट में जाए नीचे, ये इंटरफेस शेयर स्ट्रेस जो क्रिएट होती है, ये उसका डायग्राम कंपोजिट मेंबर का। तो ये जो दोनों जो टॉप एंड बॉटम है, शेयर स्ट्रेस शेयर इंटरफेस क्रिएट करने के लिए द जॉइंट हैज टू बी रफ, ओनली देन दिस कैन टेक द शेयर। ये कुछ डिटेलिंग है आपको स्लैब के अंदर में। शेयर अगर और क्रिएट करना है, बेटर शेयर चाहिए या हाई स्ट्रेंथ लॉन्गर स्पैन में के अंदर में, तो हम ये ए ट्रसेस इसके अंदर में डाल, वायर गर्डर्स बोलते हैं इनको, वायर गर्डर्स लगा करके ये स्लैब्स को कास्ट किया है, जॉइंटिंग किया है। ये देखिए ये वायर गर्डर्स से ये स्लैब्स कास्ट, 3 स्लैब्स है ये जॉइंटिंग सिस्टम्स हैं इसके। एक्स्ट्रा बार डाला इसके अंदर में टॉप में स्क्रीड कंक्रीट में, ये प्रीकास्ट। प्रीकास्ट आरसी चैनल यूनिट्स, ये भी एक सीबीआरआई का ही डेवलप्ड है। मैंने इसको भी बहुत यूज़ किया है टेक्नोलॉजी को। इसके एडवांटेज डिसएडवांटेज दोनों हैं, तो वो मैं बाद में अभी आऊँगा जब इसी का नेक्स्ट स्लाइड दिखाऊंगा। ये एक इन्वर्टेड सिस्टम है चैनल, मतलब अगर आपके 150 120 100 स्लैब है, हाउ टू रिड्यूस द कंक्रीट अराउंड न्यूट्रल एक्सिस, तो ये उसका एक बहुत अच्छा एग्जांपल है कि आप प्रीकास्ट कर दीजिए अराउंड द न्यूट्रल एक्सिस, बॉटम के अंदर में कंक्रीट हटा दीजिए तो एक सी शेप का चैनल बन जाता है। चैनल टू चैनल इसको ज्वाइन करिए। ये आप राइट को डायग्राम देख रहे हैं, ये आईआईटी कानपुर का हॉस्टल बिल्डिंग है जिसमें ये टेक्नोलॉजी यूज की गई है। ये मैंने ग्रिड शो किया, कैसे उस ग्रिड को बनाया गया, कैसे उसका प्लेस किया गया। राइट में ये चैनल्स शो किए हुए हैं, आगे चलो। ये चैनल प्लेस करते हुए जॉइंट्स के ऊपर में जहाँ सपोर्ट है वहाँ नेगेटिव रीइंफोर्समेंट टॉप में डालनी पड़ती है फॉर कंटिन्यूटी। अगर मैं बात कर रहा था एडवांटेज डिसएडवांटेज, सी चैनल में डिसएडवांटेज ये है कि नीचे से वो हॉलो सी दिखता है, मकड़ी का जाला लग जाता है, तो ये कुछ उसमें इश्यूज आते हैं। अगर इसी चैनल को हम उल्टा कर दें तो क्या सिचुएशन होगी, ये उसी का शो किया हुआ है। कास्टिंग करते हुए मोल्ड, इसमें डबल मोल्ड लेना पड़ता है, बॉटम का मोल्ड अलग है, टॉप मोल्ड अलग है, और बीच में रीइंफोर्समेंट डाले। साइड से देखिए कंक्रीट में इसमें पोर कर रहे हैं और टॉप मोल्ड इसमें उठा लेंगे तो सी चैनल इन्वर्टेड कास्ट हो जाएगा। ये आप फिगर 5 और 6 में देखिए, ये इन्वर्टेड रखे हुए हैं, उसमें जो रीइंफोर्समेंट है उसको प्रोजेक्ट कर देते हैं सो दैट दे कैन बी बेंड एंड दे कैन be part of the screed concrete reinforcement। यही प्रीकास्ट चैनल को डिफरेंट मेथड में भी यूज कर सकते हैं। आप देखिए एक चैनल सेक्शन है तो फिर एक प्लेट है, राइट को टिपिकल 2 सेक्शन अगर आप देखें, एक चैनल सेक्शन है लेफ्ट में, तो उसी के बाद में इसका कैसे उसका हॉन्च क्रिएट किया गया टॉप में कि उसके अंदर में एक प्रीकास्ट पैनल आ जाता है। नीचे चले जाओ, ये इसका 3D व्यू है फिगर 3 में। ये भी सीलिंग व्यू है, ये भी आईआईटी कानपुर के अंदर में टेक्नोलॉजी को इसको भी यूज किया गया। इसी टेक्नोलॉजी को अगर हम इंसुलेटेड इंसुलेशन देना चाहें तो क्या सिस्टम हो, तो ये इंसुलेशन प्रोवाइड करने के लिए इंसुलेटेड प्रीकास्ट लाइट वेट कंपोजिट सिस्टम डेवलप किया गया है। आगे आगे चलो। ये देखिए बीच के अंदर में स्टायरोफोम पॉलीस्टाइरीन डाला गया इसके अंदर में। टॉप में टॉप जो है वो कास्ट इन सिटू है, बॉटम प्रीकास्ट। ये डिटेलिंग है पूरी। Funicular shell crit system. Funicular is a technology in which we are given a shape of a shell which remains in compression. इसका कहीं भी आप लोडिंग करें, कहीं भी शेप हो, इसमें टेंशन डेवलप नहीं होती। इसकी टेक्नोलॉजी है। ये शेप देखिए इसके अंदर। एवरेज 700 to 700, 800 to 800 और मैक्सिमम 1 मीटर का स्पैन, 1.2 मीटर का स्पैन रखते हैं। अदरवाइज इट बिकम्स हैवी अगर हम बड़ा सेल साइज रखेंगे। चलो ये इसकी हाउ टू कास्ट इट। ये एक मोल्ड बनाते हैं जिसमें हेसियन क्लॉथ लगा देते हैं। जैसे ही उसके अंदर में कंक्रीट डालते हैं वो हेसियन क्लॉथ हो जाए, संक कर जाता है। जैसे ही वो संक करता है वो शेप ले लेता है उसका फर्निकुलर का। तो ये आप फिगर 9 में कास्टिंग करते हुए, फिगर 10 में क्या किया, जैसे ही मोल्ड उठाया उसका शेप बन गया, बेंड हो गया। आगे देखेंगे आप ध्यान से। ये देखिए ये किनारे पे इसका रिंग बीम डाला हुआ। और 12 में देखिए उसको जब डीमोल्ड करते हैं तो ये शेल की शेप निकल आती है। 26 में ये शेल डाले हुए इन्वर्टेड करके एंड देन इसमें कंक्रीटिंग करेंगे। ये एक हाउसिंग चेन्नई में NHPC का प्रोजेक्ट में की गई with based on this system. So just drawn a diagram how we can use in a housing system also or housing project. This is the precast T-beam slab with precast steel. आप लेफ्ट में देखेंगे टी बीम बनी हुई है, उसकी शेप बहुत ध्यान से देखिए। उसकी शेप अगर आप देखेंगे तो बॉटम में जो उसका विड्थ है वो 60 mm है और ऊपर 50 mm है, बाकी टेपर्ड है। उस टेपर की वजह से हम बॉटम के अंदर में फेरो सीमेंट के पैनल कास्ट करके उसमें अगर एम्बेड कर दें इसके अंदर में चीज में, तो ये एक हॉलो स्लैब बन जाती है विच गिव्स एन इंसुलेशन। सीलिंग भी फ्लैट हो जाती है और ये टी जो है इटसेल्फ इज टेकिंग ए लोड। टी बिकम्स ए स्लैब। ये टी टू टी हम ज्वाइन कर देते हैं और ऊपर स्क्रीड करके रीइंफोर्समेंट विद रीइंफोर्समेंट स्क्रीडिंग करते हैं। दिस इज द प्रीकास्ट फेरो स्टोन पैनल स्लैब सिस्टम। राजस्थान के अंदर में रेड स्टोन का बहुत यूज होता है इवन इन द रूफ सिस्टम। बड़े बड़े पैनल भी, छोटे पैनल भी, छत में लाल पत्थर डाल के उसके ऊपर में वो या तो कंक्रीट करते हैं या पॉलीथीन लगा के मिट्टी भर देते हैं। दीज आर द वेरियस मेथड दे यूज, बट द बेसिक प्रॉब्लम इज द स्टोन इज ब्रेकेबल और वो सडन ब्रेक होता है, कंप्रेशन में सडन फेल हो जाता है ये। तो उसको डक्टिलिटी देने के लिए हमने क्या किया कि उसी स्टोन को एक फेरो सीमेंट का लेयर दे दिया विच प्रोवाइड द डक्टिलिटी। अब ये कभी फेल होगा तो ये आपको डक्टिलिटी की वजह से उसका टाइम पीरियड देगा कि ये फेल होने वाला है, सडन फेलियर नहीं होगा। आगे चलो इसी में दिखाते जाए। चलिए ये लोड पैनल टेस्ट किया गया 17 के अंदर में, ये पैनल तोड़ करके दिखाया। So this is an improvement for redstone precast system where they are using, जहाँ stone मिलता है उसको यूज करें। Then this is two-way precast panel system. अभी तक हम सब देख रहे हैं वन वे पैनल सिस्टम। इसमें जो पैनल कास्ट करते हैं इसमें चारों तरफ के अंदर में रीइंफोर्समेंट निकाल दी जाती है और वो जो बीच में थोड़ा छोटा स्मॉल बीम्स बनते हैं, जॉइस्ट बनते हैं छोटा, विच इज कास्ट इन सिटू। उस रीइंफोर्समेंट जो है उसके साथ में एंटेंगल हो जाती है और ये पैनल को इंटीग्रेट कर लेती है। 3 पैनल्स है। दिस इज प्रीकास्ट कर्व टाइल सिस्टम। कंक्रीट के पैनल को शेल के बजाय एक सिलिंड्रिकल शेप, नॉट ए सिलिंड्रिकल बट कर्व्ड शेप दे दिया विद लाइक ए सिलेंडर। उसका पार्ट है, समझो सिलेंडर का ये, या शेल वैल्यू। तो कर्वेचर है, कंप्रेशन के अंदर में सेफ है, रीइंफोर्समेंट की प्रॉब्लम नहीं है, मैश दे देते हैं इसके अंदर में जस्ट फॉर सेफ्टी, और ऊपर से कंक्रीट फिल कर देते हैं विथ प्रीकास्ट जो है। ये शेल, ये देखिए शेल को रखते हुए राइट को कास्ट करते हुए सिस्टम। ये मैकेनिकल, थोड़ा सा नीचे करो, ये मैकेनाइज सिस्टम ऑफ कास्टिंग द शेल्स। हाउ वी कैन डू मैकेनाइज कास्टिंग, मैनुअल कास्टिंग भी कर सकते हैं, मैकेनाइज कास्टिंग। दिस इज a यूकोपैन इंटीग्रल सिस्टम। ये सिस्टम डेवलप किया था जेलिंस्की फ्रॉम स्विट्जरलैंड, जिसमें U स्टैंड्स फॉर यूनिवर्सल, CO स्टैंड्स फॉर कंक्रीट एंड पैन स्टैंड्स फॉर पैनल। ये कलकत्ता में इंडिया में यूज हुआ। ये आपके स्टील प्लांट जो वहाँ है उड़ीसा में, उसमें यूज हुआ, चीज के इंडिया के अंदर में, नेपाल में यूज किया गया, जस्ट टॉकिंग एशिया, वेस्टर्न कंट्रीज में तो बहुत से। इससे पैनल सिस्टम, इसको भी थोड़ा सा दिखाते, ये पैनल है इसका। उन्होंने एक ऐसा पैनल डिजाइन किया था, सेम पैनल कैन बी यूज फॉर रूफ वॉल एवरीवेयर, शेप सेम का, ताकि मोल्ड की कॉस्ट बच जाए। ये देखिए फिगर 8 में देखिए, 3 तरह के पैनल्स हैं, सिंगल पैनल, पैनल विद विंडो एंड पैनल विद डोर। 5 मिनट बस। ये इसका क्या करें, मैं वही तो मैंने बताया था, बहुत है मेरे। चल चलिए पूरा, चलिए दिखा दीजिए। मजा नहीं आता, मैं तभी तो बोल रहा हूँ मुझे। चलते चलिए फिर अभी कौन सी टेक्नोलॉजी दिखाए, UTS, ये भी मेरी रिसर्च है। सब प्रीकास्ट सिस्टम, मुझे तो पता भी नहीं चलता टाइम का। मैं कितनी स्लाइड हो गई पता नहीं, अभी तो 230 पर। प्रीकास्ट रिकंस्ट्रक्शन बहुत बहुत टेक्नोलॉजी है, तो दिखा देना बच्चों को बाद में है। बताइए। I've been asked to stop the presentation here. Can't help it because there are so many technologies, can't show it in such just 1 hour. Thank you for listening.
So thank you so much, sir, for the vast presentation that you have given.
I know it would not have gone into the minds, but this is just give an idea that you have a broad spectrum of technologies. ऐसा होता है जैसे बास्केट है पूरी, अब उसमें से आप पिकअप करते रहिए अपने आप, बस ये
Yes, sir. With so much technologies and so much systems that you have briefed us about. So, yes, so we just thought prefabrication and precasting was just a small, like, a small thing. But after looking into your presentation and the various techniques and systems that are there, so I guess students will be more interested to explore these things, and your presentation will definitely help them or guide them with the same. So, sir, I just had one doubt. So, for most of the tier 2 and tier 3 cities or the contractors, which stage of prefabrication is realistic, sir, that can be adopted today?
You know, according to me, in tier 1 city and metro cities, because a lot of multi-story buildings are coming up, yes, you can use these precast systems in multi-story building only for slab elements, because frame structures is a frame structure. We in India don't have a system still for our, because of the earthquake, zones, I won't prefer and I won't advise. But slabs, of course, can be precast, and it's a big construction element. I- I'll I'll give you further. Yeah, can go. Let us go to this tier 2 cities, 3 cities, 4 cities, even rural areas. Small precast elements, small industrial setups can be done by. That is what I was discussing with your professors here. Let the students be motivated to become entrepreneur. I'll make them entrepreneur. I've already mentored two startups on this. Yes, but it takes time. I will have to discuss with the students their strength, their weaknesses, their interest, their passion. Only then these things come. It took me 55 years to come at this stage. And then I could, construct thousands of houses at one place. The largest housing, 14,200 houses, one project I have done, just single project. In one single project, I have used this 10,52,000 precast elements, these small. So, to come up to this stage, let the students not do it, but I know students can do better. Today's students have got more zeal than me. But yes, I can be a mentor. I don't mind. Let them come forward. I'll teach them. I'll guide them. See, but only those who are passionate and who are interested. That's too important. Thank you.
Thank you. Thank you so much, sir. And if anyone has any questions, so they can unmute themselves and
They're asking if somebody wants to ask any questions.
Well, I think for questions, I'll come one day again. I've talked to your professors here. I'll show these detailed presentations, teach them each and every part of the presentation. So these are just few slides. There are about 7,000 slides with me. So I'll select and see one day. I'll find out time and see how many students are interested in this. Let's see. It depends upon the interest of the students.
okay, sir. So thank you so much, sir,
No
for
mention.
your valuable insight. And we'll be looking forward to have you in the panel discussion, which is at 3:15 p.m. today. So other panelists also will be there, and then maybe we can discuss a lot about the precast technologies or prefabrication technologies in that panel discussion.
Yes, I will.
Thank you so much, sir.
You can start.
So, dear all, the next session will be starting at 12:15. We already have our next speaker, Mr. Ashish Kapoor, sir, Senior Scientist from Structural Engineering Division, the Central Building Research Institute, Roorkee. So we'll be starting off by 12:15, so that we will take a 5 minutes of break and then join exactly at 12:15. Thank you. Welcome back, everyone. So we are here for the the next talk that is on the innovations in 3D concrete printing, advancements, applications, and future prospects for smart and sustainable construction. So we have with us Mr. Ashish Kapoor, sir, Senior Scientist, Structural Engineering Division, Central Building Research Institute, Roorkee. So to give a brief introduction about the speaker, I now request our HOD, Dr. Ruchi Saraswat, to please give a brief introduction.
Hello. Good afternoon.
Yes, ma'am, you are
Good
audible.
afternoon, everyone. Sorry for this interruption. Welcome you all. It's my honor, it's my privilege to introduce our next speaker, Mr. Ashish Kapoor. He is a scientist D in Structural Engineering Group at CSIR, Central Building Research Institute, Roorkee. He has over a decade of experience in structural engineering with expertise in structural condition assessment, non-destructing evaluation, repair and rehabilitation, earthquake-resistant design, and advanced construction technology. He successfully led more than 600 projects involving the assessment and rehabilitation of civil infrastructure. His current research focuses on 3D printing, precast and modular construction, sustainable cementitious materials, structural health monitoring, and performance evaluation of critical infrastructure. He has been actively involved in several national projects related to the disaster resilience, airport infrastructure assessment, seismic risk mitigation, and full-scale structural testing. With Mr. Kapoor serves on technical committees contributing to the development of the national standard and guidelines, and has authored numerous research publications in reputed international journals. His work aims to bridge research and practice by promoting innovative, resilient, and sustainable construction technology. Welcome, sir. Without any interruption, I request Mr. Ashish Kapoor, sir, to deliver a lecture. Thank you.
Good afternoon, everyone. Thank you so much for inviting me in this special. What exactly is this? Is a online lecture series, and
Yes.
okay, so thank you so much for inviting me, and I hope with my experience, and I would like to share what we have. This is all about our India's research in the field of 3D concrete printing, because we all know that 3D concrete printing is one of the name which is used as a buzzword all over the world, and it has been uh, under the monitoring of all the technical persons who are aware of this 3D concrete printing technology. So today's my aim is to introduce the students about the 3D concrete printing, how this 3D concrete printing works, what is the challenges, how this material behaves, what are the materials, and all the basic things which we are and what R&D work we have done till now. So I think my screen is visible to all of you.
Yes, sir.
Yes.
So starting with this innovations in 3D concrete printing, what exactly why we are doing this 3D concrete printing? So before starting this exact 3D concrete printing, let's talk about the challenges in construction right now we are facing. So we all know that in the era of this automation and this AI ML generation, civil engineering is the only field where this type of advancement is not that much visible as compared to the other sectors like your telecommunication, your automobile, and other all the other areas. So what we are facing is we are again following the same old school methods, like we are following that we have facing the challenges of slow construction, complex process, shuttering, scaffolding is always there. Then quality control is again that is a low quality control because of that manual intervention. Then there is a lot of wastage of material, and because of this there is a impact on environment, and again the scarcity of manpower. Right now we are facing a little bit scarcity of manpower, but if you compare it with the western countries, down the line of around 20 to 30 years, we will also face the same problem of skilled as well as unskilled manpower. So, right, it is the time where we have to focus on all these challenges, and one of the potential solution is 3D concrete printing. Similarly, that we have discussed about the previous speaker discussed about the precast construction technologies. That is also one of the potential solution. So another one is your 3D concrete printing. So what is 3D concrete printing? It is a transformative construction technology which will reduce the wastage, enhance the sustainability, innovative design possibilities, and faster construction, because everything will be done as a automation based concrete printing. So what exactly is 3D concrete printing? We all know that 3D concrete printing is defined in two ways. One is your additive manufacturing, another one is your subtractive manufacturing. The subtractive manufacturing, we all know the basic idea behind that subtractive manufacturing was the laser cutting. So that was the subtractive manufacturing process. In additive manufacturing, the concrete is laid by layer. The process of joining materials to make objects from 3D model data, usually layer upon layer, potential to disrupt conventional construction practices. So 3D printing is the form of additive manufacturing in which components are fabricated in an additive fashion by adding successive layer of materials together. So it is a computer controlled placement of extruded cement based mortar to create a physical object layer by layer. The image you can see, this is a type of a seater which is constructed or fabricated using 3D printed. So what are the benefits of 3D concrete printing? One, from constructability point of view and sustainability point of view. From constructability point of view, rapid construction, high productivity, low cost, less labor, geometric design freedom, and short supply chain. From sustainability point of view is less carbon dioxide emission by using local material, eco-friendly structure, less requirement of formwork, less generation of waste, higher safety, and socially adaptable. So these are the benefits of 3D concrete printing. So if we talk about what are the materials are used in 3D concrete printing, it is cement, sand, and some admixtures are used, and then it is mixed in a pan mixture, and then it is pumped through a design pump, and it will be extruded through a designated or a defined size nozzle. So this is about and we got the final 3D printed material. So this is how the print will be done. So in 3D concrete printing, what exactly is difference? The difference is it has a behavior of high thixotropic material, which should have the ability of extrudability, pumpability, as well as with the buildability. Means that the extruded material should have sufficient static yield strength that it will not deform with its own weight or with the successive layers weight. So how this process goes on? The first process is your designing. That 3D model is developed by using SketchUp or AutoCAD 3D. Then that will be a dedicated software is used for the slicing, in which it will be converted into G code, or it will be converted into machine readable language. For that, we need .stl file. So whatever the designing we have done in SketchUp or in AutoCAD 3D, that our output file should be .stl. Then after slicing, it will be that printed will be done. And after printing, that post processing, like your curing, surface finishing, support removal, etc., will be done. So in the end, we'll got the final product. So this is the whole 3D concrete printing process. So in market, there are various types of 3D concrete printers are available. Like your robotic solution for 3D printing is gantry based printer, serial robot, parallel cable driven robot, mobile serial robot, and these type of printers are available. So one of we in CSIR CBRI, we have two 3D concrete printer. One is your lab scale 3D concrete printer, which having the print dimension of 1.5 meter into 1.5 meter. And another one we having 10 meters by 10 meters by 10 meters. This one is the large scale 3D concrete printer. So for 3D CP, there are two methods. One is your offsite printing process, which is similar to your precast construction elements. So in which the fabrication is done in a centralized industry, then transported to the site, then finishing will be done and assembly at the site. And finally, the product will be finished. And another one is that on-site printing, in which the printer will be assembled at site, and then after assembly, the printing will be done exactly at the site, and then finishing will be done. So these two methods are used in 3D concrete printing. The first one, where the printer is assembled or printer is installed at your lab, and the components are printed, and the components will be transported to your site and then assembled. Another option is that whole printer will be installed directly at your site, and that printing is done at exactly at your site. So this is the components of 3D scale lab printer which we having in CBRI. This is one is your front view. This one is your back view. In front view, you can see there are certain sensors, material hopper is there, hose pipe, gantry system, power supply. This is the printing bed where the printing will be done. And this is the print head and nozzle. And it is control system. From backside, you can see this is the control panel, then concrete mixture is there, and there is a pump from where it is connected with the hose pipe, and this complete system is for 3D concrete printer lab scale. And this one is the image of full scale lab printer. You can see it is almost similar to your lab scale, but the size is higher, bigger. So the size is 10 meter by 10 meter by 10 meter, which it can be print a building of G+1 structure easily. So coming to the properties, material properties, which we are focusing is, one is your fresh properties, another one is your mechanical properties. In fresh properties, we will see first is your flowability, second is your extrudability, third is your buildability, and based on this, open time is required. Then compressive strength, flexure strength, tensile bond strength, shrinkage and cracking. So rheology is an important bearing on printability of concrete. It is a science of flow and deformation of matter and describes the interrelation between force and deformation and time. The two fundamental rheological parameters are yield stress and viscosity. So the 3D concrete printing actually requires the pumpability, extrudability, and buildability, which means it requires a contradictory rheological behavior in which it requires a low dynamic yield stress, which ensure that the material will be easily pumpable and extrudable, as well as it requires a high static yield stress, which helps it to maintain the shape after deposition. So this is the kind of a contradictory rheological requirement for 3D concrete printing. So once this satisfy these three parameters, your concrete will be printable. So the entire idea or entire principle behind the 3D concrete printing is the thixotropic behavior of that particular material. So how it is done? If you see that in pumpability, the ease by which it can be pumped through one location to the exact designated place where we have to do the printing, and extrudability means that it will extrude the material from the exact dimensional nozzle which we are using. That nozzle can be of your circular size, it can be of rectangular, it can be of square, any type of nozzle can be used. And buildability means it can take up the load of successive layers. So for that, we need a high yield stress or high plastic viscosity. If it is not satisfied, then we can face this type of failure. The one is your plastic buckling and another one is your elastic buckling. So the properties which we are seeing is aggregate yield stress. If we aggregate size will affect the yield stress, and aggregate grading, aggregate angularity, aggregate shape, paste volume, water binder, fly ash, slag, silica fume. So these are the parameters which are going to affect the materials property. These arrows are showing whether it will decrease or it will increase the yield stress or plastic viscosity. So based on that, it will affect the how the material behaves. So coming to the pumpability is ease with which fresh mix transferred from pump to the extrusion nozzle, where we are using different types of pumps are available in market, like your ram extruder, positive pumps, and progressive cavity pumps. So these are the things which how the print that pump is pumpability affects your printing, and this is how this structuration of the mix occurs if pumping mix halted. Because if pumping is halted in between, there is a chances of blockage. So we have to be very careful during this type of pumping of 3D printable concrete. So here yield stress and plastic viscosity is the main driving properties for pumpability to ensure a proper pumpability. So for that we can depend on, or we can use the viscometer or rheometer or tribometer for measuring the static or to measure the yield stress or plastic viscosity. Coming to the extrudability, it is the ability to extrude a mix through a nozzle without significant cross-sectional deformation and minimum splitting tearing as known as extrudability. Here in image, you can see we have extruded one material with the dia circular nozzle, and we have a dia of around 30 mm. So we have to check whether it is deviating from that 30 mm or not. If the extruded material is of higher size or the lower size, or it is equivalent to that size, so that will convert into your shape retention factor. So these are the things which we visually inspect, and superplasticizer, microsilica, nanoclays, these will improve your extrudability, or this will enhance the extrudability of your 3D printable material. For that, we have this, I already told you about the shape retention, that width of the extruded filament divided by the width of the nozzle. Higher value of SRF implies higher yield stress. Higher value of SRF beyond certain limit causes blockage, because it means that your concrete's static yield stress is higher, and we are getting the size lower than the nozzle size. So these are the some of the nano additives enhance shape retention ability of concrete, increased printing speed, reduce width of the filament. So these are the parameters which we have to be very careful during printing. And buildability, as I told you, this is the simple thing which it should maintain its shape and support additional layer without collapsing. So depending on your size of the nozzle, different type of nozzles are used. Circular nozzle has a less contact area as compared to your rectangular or square nozzle, but the shape of circular nozzles looks very attractive. So buildability mainly depends on your printing method constraints, rheological properties of mix, and design geometry of that particular structure. So this is how we check for the number of stacked layers with respect to the number of filaments. So we should calculate the shear strength of particular concrete. So this is how that buildability, it depends on your time plays a very significant role in deformation of layers. Insufficient time gap results into void in the filaments, or higher porosity influence durability, mechanical performance of printed filament. More time gap improves shape stability, but significantly decreases the bond strength. In short, we have to maintain the print timing in such a manner that it will not reduce the bond strength, as well as it will gain a sufficient strength that it can hold the weight of successive layer. So this is how we can move. So coming to the open time. So after evaluating these fresh properties, open time means that a concrete which is printable at a particular time, means once you mix the water and all the ingredients, your material is flowable but not buildable. Once it extruded, it will collapse. So we have to wait for that material to gain a sufficient strength. Once it gains a sufficient strength, suppose after around 30 minutes, from 30 minutes, it is less buildable, but it is flowable. And after 30 minutes, you can see it is buildable and as well as extrudable. From 30 to around 60 minutes, it is buildable as well as extrudable. It means this is your printing time or open time, or it is called a printable window. After 60 minutes, your material gets hardened and it has a buildability, but it doesn't have flowability or extrudability. So within this 30 to 60 minute, this is your printable time. This is the time where you can print your material. Otherwise, before that, it will collapse, and after that, it is not able to flow, or it will not able to pump. So that is the open time, and we have to maintain this open time depending on your type of structure which are using. For that, we use accelerator or retarders to balance between the requirement of your structure. So this completely depends on your mix design, how mix design is has been done. And other various factors affecting the open time is your environmental condition, like your evaporation, rate of evaporation or hydration, and what is the relative humidity over there. For example, if I develop a material here in Noida, will not be workable or will not be printable in Chennai, because the relative humidity of Noida is different from Chennai. So then we have to modify your design mix. So accordingly, we have to modify your design mix based on your temperature, humidity, location, and as well as the size of your component. So how mix design in 3D concrete printing is? So it is, as I told you, it is a balance between pumpability and buildability. So that balance is required. And based on that, material compatibility is also checked, like what is the hose pipe length, what is the pump capacity, what is the size of the nozzle, how that can be done. Then and the grade of concrete will be decided based on your sand binder ratio, water binder ratio, aggregate size. Generally in 3D concrete printing, we are using the fine aggregates, means the size of the aggregate is 2 mm, less than 2 mm, and coarse aggregate is not used. So these are the ingredients used in 3D concrete printing. This is how you can see 3D concrete printing is done in our laboratory. We can print any shape which is not possible with your regular concreting. So this is how we can this is a amoeba shaped it is a shape of a amoeba which we are printing with our 3D concrete printer. The nozzle size is 20 mm, and the layer thickness is half of your nozzle size. So the layer thickness is around 10 mm, and the nozzle's dia is 20 mm. So test for hardened properties, we generally go with the density in which we check for the voids, if there is any void between the filaments, because there are the high chances of, because it is a layered structure, there is a high chances of a voids between the two layers, but that can be checked and that can be removed by a good printing material. Another thing is, this material is a printed structure. It has an anisotropic property, which means it doesn't give you the same test result or same strength result with respect to the direction of testing. So for that, we have to check for this anisotropic behavior of 3D concrete printing in compressive strength, flexure strength, as well as in tensile bond strength. So in reinforcement in 3D concrete printing, it is another, still it is a challenge in 3D concrete printing. Printing reinforcement or mesh reinforcement is used, or we can introduce a cable at the nozzle as printing over conventional bar, or steel bars can be inserted horizontally by giving opening at the backside of the extruder. With this existing printing method, difficult to connect reinforcement and vertical support. The horizontal reinforcement can be easily placed, but the vertical reinforcement still is a challenge. But we have modified our nozzle in such a way that the vertical reinforcement can be placed in between that nozzle. But again, the limitation is it cannot go beyond 1 meter. So 1 meter is the length of that special type of nozzle can be used, or we can go with the hybrid printing system, involve mechanized inclusion of steel filament into current 3DCP, or manually placement of reinforcement is also feasible. So you can see this is a type of a special nozzle where the nozzles is splitted into two halves, and the vertical reinforcement can be placed in between that one, the pre-installed vertical reinforcement. From these two nozzles, the concrete will be placed and the deposition will be done again in layer by layer in this manner. So this is the image you can see. This is the modified printing nozzle. And another thing is we can introduce high strength tensile wires, which is also known as murfers in this. So methodology point of view, what materials we are exactly using in binder? We are using cement and other cementitious material, then fine aggregate, super plasticizer. We are using that super plasticizer, high water reducing admixtures. Then we are using VMA, which is, this is the exact magic material which converts your normal mortar into 3D printable mortar. For VMA, we are using methyl cellulose based, and then again some retarders and some nanoclay can be used, but this is then an optional. Then material design and print process parameters, we check with the water binder ratio, sand binder ratio, optimum dose of super plasticizer, VMA, retarder, and nanoclay. Printer type, which type of printer we are using, then nozzle size and shape, then printer speed, because printing speed also affects your printing quality. Here we having the print speed of around, and the maximum print speed we have 100 mm per second, and for that we need to modify our mixture. What is the requirement? So if we require 50 to 60 mm, then we have to work on our mix design. If we need the print speed higher than that, then slight modifications are required. Then the printed material will be checked for your fresh properties as well as your hardened properties. So here in 3D, in CBRI, we have developed one agro-industrial waste-based 3D concrete printed material. And in that one, we have used cement, fly ash, bagasse ash, GGBFS, sand, and those admixture which I have already mentioned. Then this mix design is done. And depending on your sand binder ratio, bagasse ash, fly ash, GGBFS, various dosage has been checked, and based on that we have developed 3D printable concrete from M20 to M60. So right now we having the design mix of M20 to M60 with us. Then we check the rheological parameters, mechanical properties, durability, harden test, and these mineralogical test also. And also we have done the numerical simulations to check the behavior, and within few months we are going to check the full scale testing of 3D printing building which will be having the print size of 3 meters by 3 meters and 2.8 meter high. A complete full scale building will be tested for your lateral load, and we are planning for that one also. So this is how we have done the optimization of mixed design. This one is for cement plus bagash ash, where we have optimized the 40% replacement of bagash ash with cement. And here we have used 1.4 sand binder ratio and 1% superplasticizer, 0.5% VMA, and 0.4% retardant, and 0.2% PP fibers. This is to control over the your drying and shrinkage cracks, because we are having a high cementitious material. So this is how we have checked the flowability test. We have checked the flowable material, then shape retention, how extrudability, buildability, and then open time. So these are the samples which we have printed. Like you can see, these are the beams, these are the beds. From bed, we have extracted cores. Then we have tested these cores for compressive strength, tensile bond strength, and split prism test for interlayered bond sample also. So this is how we have done the testing part for hardened concrete. So this is how we have checked our open time for this type of printable material. The hole which we are showing, it is having the compressive strength of M30 grade. And this is our open time requirement. From 10 minutes to 70 minutes was the printable window. In between, if we are printing, that we get a proper or well printed extruded filament of optimized mix without any tearing, splitting, or any defect. So this is how we have done the evaluation of compressive strength. Here you can see the in perpendicular direction, in lateral direction, and in longitudinal direction. We have tested the compressive strength. Here you can see there is a decrease of 16.4% in lateral direction and 11.11% in longitudinal direction as compared to your perpendicular direction. So this means it is an anisotropic material. For that, we have to already cater during our design. So similarly, there is a flexure strength test also. And again, this flexure test longitudinal and lateral direction as compared to your casted sample, it gives a slight, or you can say there is a lower strength as compared to your casted samples. And again, we have tested for the tensile bond strength also, that different directional, it is an isotropic behavior. So it gives a different values with respect to perpendicular, longitudinal, and lateral direction. We have done this testing. And again, that split tensile strength also, this is as per the ASTM 3 C39. And you can see with respect to control, perpendicular, lateral, and longitudinal direction, the strength decreases by 6, 12, and 24%. So this is how you can see printed, how the printing specimen was done. This is the shape of a pie, which is printed in this direction. Then it will be inverted in such a way that it becomes a seater. So the people can sit over it, and it having a compressive strength of M30 grade. And it is also a completely watertight concreting. Here you can see that the water is filled in a circular vase, and it is done. So this is how you can see. This is where we have done the India's first 3D printed rural house in Roorkee, which was inaugurated by the Minister of Rural Housing. MORD's minister has inaugurated this full-scale 3D printed building in CSIR CBRI Roorkee. It is under demonstration. So we're having a full-scale 3D printer also. This is how the full-scale 3D printer works at site. So these are the some of the applications in the world, that in Florida, in Texas, Germany, Netherlands, New York, Virginia, that 3D printed buildings. Again, you can see these are the hybrid construction where the walls are printed with 3D printing, and roofs and slabs are your precast materials we are using. And here we can see this is the 56 square meter house is printed in IIT Chennai, and this is the house printed in CBRI Roorkee. So if I summarize that flow behavior during pumping in 3D concrete printing is strongly influenced by the material properties. Multi-material printing or hybrid construct techniques are often required to achieve structural and functional performance. The 3D printing process is governed by the rheology of fresh concrete, particularly yield stress and viscosity. Addition of fibers generally reduce workability due to increased viscosity and yield stress of the mix. So standardized guidelines, there is no standardized guidelines all over the world is there. There is no IS code, or there is no any other country has developed till now any materials for material specification, manufacturing process, testing method, structural design. And reinforcement placement can be achieved manually or by automation in one. So what exactly we need? We need standards for 3DCP right now. So guidelines and validation of printable material, and absence of skilled and prepared workers for operating 3D concrete printing is again a challenge, because this technology is not available readily available in the market. So the again we have lack of skilled manpower in 3D concrete printing. Then appropriate design techniques to conquer limitation on 3D concrete printing, which we have already discussed. Then current regulation and absence of complete set of norms, and high establishment cost is there, because as we all know that whenever there is a new technique or new uh, technology is there, the cost will be always higher. So once it will be largely available in the market, I'm sure that the cost will definitely comes down. It is similar to your technology we are using just in your mobile phone. Once the mobile phone comes in the market, the cost was very high. Once after that, the multiple players comes into the market, the cost automatically comes down. So entirely different design method is needed. We can't go with your conventional method. And BIS as well as other ASTM Council is also working to develop the design. I'm also one of the member of BIS in developing the code for 3D concrete printing. So there is no such panel or standardization test are available. From future scope, we have to look into the new materials for which is compatible with 3D concrete printing. Multiple nozzles or multiple materials can be used simultaneously to create the effective printing. We also work on the building information modeling and life cycle assessment of this type of structure. And we also we have to work on the how to print high-rise buildings, and we will work on the developing norms and guidelines. Then some mathematical or analytical models will be checked to prevent failures, and mechanical reinforcement and smart self-reinforcement geometries can be used. Then risk assessment, that will be your seismic and fire. We are already on the way to check the seismic performance of this 3D printable building with full-scale testing, and reduction of need of warehousing, transportation, and packaging. So it will be directly printed at your site, and it can be your printer will be reassembled at different location. So improvisation of supply chain efficiency to maintain customer responsiveness. And another thing which I want to just highlight is recently we have published one book on advances and challenges in 3D concrete printing, and that is under the Springer is the publisher under the production house of Springer. So this is available in the market, and you can go through this book, and you will get to know from scratch to future challenges what are the advancements and what are the challenges and how the 3D concrete printing works. So a complete book is there on 3D concrete printing. So thank you so much for patiently listening me. And if you have any doubt, any questions, you can ask. Thank you so much.
Thank you, sir, for your presentation on the 3D printing, the technology, and then the techniques, the testing that we do. So, participants, if any of you have any questions.
Sir, very good afternoon, sir. Thank you for the insightful session. Sir, I have few queries
Yeah.
related to 3D, the project which you showcased, the first 3D rural housing at Roorkee.
Yeah.
I just wanted to know what are the different challenges you encountered and how did you go with the reinforcement placement, sir? Because as you mentioned, it is manual and automation, but for rural 3D printing housing for project, how did you encounter the different challenges at this site and also related to the reinforcement? Because the reinforcement is
Yes,
something which
yes.
gives the tensile or it bearing, right?
Exactly.
So
Exactly.
without that, how do you means how did you proceed with that? So that's what my major concern is.
Okay. To your question, thank you so much for asking this a very good question. The first thing is we have designed this structure as a single story only. So it is a kind of a masonry structure in which we have incorporated the bands and all the earthquake resistant features. For that, we have not used your conventional reinforcement. We have used Murfer. Murfer means it is a kind of a high tensile wires. So
Yes, sir.
if you see in this video again, I can show you. Here you can see these are the materials. These are the printed blocks which we have used. It is interconnected, this kind of a blocks, how this is assembled at site. It is a precast construction. And this one is, here you can see, this is Murfer. So
Okay.
at sill level, at your uh, window level, and then at your top level, these high tensile reinforcement bars, no, high tensile reinforcement wires, which is known as Murfer. If you go on a Google it as a Murfer reinforcement, you will get the details of it having a tensile strength of around 2000 MPa or higher.
Okay, sir. Okay, fine,
And
got it.
another thing is you can see this, there is a column over there. So what we have done is we have integrated the reinforcement inside, and the self-compacting concrete is poured inside the column. So this column will act as a RCC column with which having a permanent shuttering of 3D printable concrete outside, and you can see the image, that shape of this column is like it is rotating.
Yeah, got it, got it, got it.
So this is how we incorporate reinforcement into the 3D printable concrete.
Sir, currently in India, I think it is up to G+1 story, right? I think they have not
Exactly.
yeah.
Yes.
Okay, still
So
the
because
codes are under process because still
yes,
codes are
under
not available. Yeah.
yes, absolutely right.
Uh,
And within 1 or 2 months, we are going to test full scale lateral testing of 3 meters by 3 meter building in our lab. So
okay, seismic.
then we'll get to know the seismic behavior of this 3D printable concrete also.
Sir, is it the like for seismic also like you will be using the shake table and all, or it will be some more advanced equipments to test the
No,
3D?
no. For in shake table, you will not get to know the exact deformation, how it will deform. So what we are planning to test with in a quasi-static condition in which lateral loading is done by using actuator. So we'll do the cyclic loading with we having actuator of 100 tons capacity, so that it will a cyclic loading will be done, and we'll get to know at what level it goes failure, what is the energy dissipation, what will be the maximum deflection with respect to your cyclic loading behavior.
Okay, sir. Sure, sure. Okay,
So
sir.
in our CBRI, we having a reaction wall of 12 meter in which you can go with the testing of G+3 building in one go.
And the gantry you are using is The machine is gantry, right?
Yeah,
Gantry
that
printer.
gantry-based 3D printable concrete.
Yeah, yeah. Okay.
Yes.
Okay, sir. Thank you so much for the information.
Thank you. Thank you. I think someone asked me to switch on the camera, but I think my camera is disabled from your end. You cannot start the video because it is disabled by the host.
Okay, I've done it, sir. Thank you, sir. Thank you so much. Like that was for the, so if you can just keep the presentation on, like any one slide.
Yeah, yeah, sure. Is it okay?
Yes, sir. Thank you so much, sir.
Yeah, thank you. Any other
Participants,
questions or
any other questions?
if you have any query, you can contact me or you can visit CBRI Roorkee for this type of advanced construction technologies. Anytime, you all are most welcome.
Sir, from on behalf of the Department of Civil Engineering, JSS University, I would like to thank you for like sharing your knowledge, your experience, the work that has been carried out in the CBRF. So thank you so much, sir. And we'll be having one more session, like that is the panel discussion at 3:15, and we would be happy if you can be one of the panelists in that session also.
I'll check because I have some other commitments in the second half. So if it is possible, I will join. Otherwise, just pardon me. Thank you.
Thank you. Thank you so much. Thank you so much. So participants we'll take a break for lunch and then we'll resume our session at 2:15 p.m. Thank you. Thank you so much.
Hi, good afternoon.
Very good afternoon, Mr. Birde.
Hi. Can you hear me? I'm going to turn
Yes,
my
we can very well hear you.
camera on. So, yeah.
So welcome back, all of you. We have our next eminent speaker, Mr. Amit Birde, with us today. It's my honor to introduce you all, Mr. Birde. Mr. Amit Birde joined India's leading construction company, Larsen and Toubro Limited, as part of the Precast Initiative of the Residential Buildings SBG in 2012, with over a decade of precast construction experience in the United States, with a leading precast concrete manufacturer. He is currently heading the Precast Initiative for Buildings and Factories Independent Company and is actively involved in developing and promoting precast technology adoption in the residential and commercial building sector. He also heads L&T's Precast Works Competency Center that was recently formed to standardize and optimize L&T's precast construction capabilities across 10 different independent companies. Mr. Amit is known for his expertise in a variety of residential, commercial, and industrial precast concrete buildings. Currently, he is actively involved in the construction of Sidco P-May housing project in Navi Mumbai, the largest order of the residential buildings group. He has graduated with honors from the Government College of Engineering, Pune, and later pursued higher studies at the prestigious Purdue University, USA, to complete MS in Civil Engineering. Recently, he has also completed his Executive MBA from the Indian School of Business, Hyderabad. He is a member of Indian Concrete Institutions. He is a licensed professional structural engineer in the US and Navi Mumbai, and is also a US GBC LEED certified professional. We are very much honored to have you, Mr. Birde. It's over to you.
Hi.
You please start the session, sir.
Sure. So I'm presenting. Let's see.
Sir, you are on mute. Sir.
Yeah, I think I was not able to unmute that. So, okay. So somehow it got automatically. Can you hear me now?
Yes, sir.
Yes, sir.
Okay. And you can see my screen, full screen presentation.
Yes, sir.
Okay. All right. So, yeah, thank you for the kind words. It's a pleasure to be here. I understand you have been going through a series of presentations since morning. You have another half a day as well. So I'm going to keep it short, but still fill that hour, right? So that's the idea. Focus is on, of course, precast technology. We will go over about 40-45 minutes in terms of technology, why L&T is looking at technologies to begin with, how we adopt technologies in all aspects, and then what we will be looking forward to in the age of AI, which is one of your themes for this conference also. So in that digital space, what we are offering, what we are doing, purely from a construction standpoint, right? I won't get into L&T's details. I think everybody is fairly familiar. We are not going to spend time. But what I would like to note is within L&T, we have more than 23 companies. And L&T Construction is a sizable part of that. And I come from L&T Construction. Within L&T Construction, there are again 8 independent companies that operate, right? And in that, buildings and factories, what you see on screen, and as the name suggests, it looks at buildings and factories. So we operate in a variety of projects across India, maybe Middle East some. But anything that is related to buildings, may it be airport, hostels, IT parks, factories, manufacturing, residential, the whole 9 yards. So we don't get into the infra side much. There is a separate company which will deal with the infrastructure. So a lot of attention is given to that sector because of the scale and size we operate. But this is still about 50% of the revenue of L&T construction. In that, residential becomes one of the big portfolios, and as the name suggests, L&T is large and tall. We do a lot of high-rise buildings, a lot of mass housing in that residential sector. And if you see, these are all the recent projects in Mumbai that are ongoing, that are finished in recent times, right? So buildings more than 200-meter tall, or sizes of more than, let's say, 3 to 5,000 units in one project, right? It does not necessarily be tall. This is AP housing, which is horizontal. Right? These are almost 1 lakh houses, even if the low-rise building. So these kind of projects we repeatedly look at, right? So with that background, the topic today was precast and why L&T got into precast construction for residential, right? So if I want to relate that why we took that decision about 15 years ago, we will have to look at the state of the art today, right? And we have been blessed with visionary leaders who anticipated that what we are seeing today about 15 years ago and got into this system. But where we stand today is construction is at what we ideally would call a paradigm shift, right? In terms of whatever socio-economic situations we are in terms of large project sizes, in terms of volumes, right? When 2,000 houses project used to be a big number, we are now looking at 15,000 houses, 50,000 houses in one go. That 2,000 houses project used to be a 5-year duration. Now 15,000 houses project duration expected is about 2.5, 3 years, right? So all that, if you look at that, whatever that we have to do, the construction industry comes to these two parameters that you see on the screen, right? And in the entire presentation, I probably have 3 or 4 slides that I would want you to take home with you, right? And I will let you know which slides those are. And this is probably one of these slides, especially who are graduating or looking at starting a career. The industry in last 30 years, especially the building industry, which never saw a need for mechanization, never saw a need for digitalization, is being, for a lack of better work, being forced into getting into that, right? For maybe we don't have the workforce that we want, we don't have the skilled workforce that we want. 5 years ago, it used to be that we don't have skilled workforce. Today, if you ask me, we don't have workforce to begin with, right? In a country with more than 1 billion population, we still are not finding people who would want to get into construction industry. And the reasons are great. I think this is the India story we are developing. There are a lot many opportunities available compared to the hard work that you are getting into it. So is it mechanization and digitalization for the sake of it? What we are looking at is, if in the center you will see the business excellence, and if you want to achieve that business excellence, our take is today we have to get into this mechanization and digitalization. But why is, if you want to complete that circle, that mechanization is going to improve my efficiency, right? Efficiency in terms of wastage control. In construction industry today, there is extreme level of wastages, uncontrolled wastages. We don't even know how much we are extra spending. We are not tracking how much extra we're spending. It just gets added to the price. Second, of course, is the productivity improvement. So get the same amount of work completed using less and less people. And that is what we looked at in terms of the workforce requirements. So if I am adopting mechanization for the efficiency, the digitalization is allowing me to track that efficiency, whether really we are able to improve things or not. And that digitalization and tracking mechanism is leading me to further innovation, what works, what doesn't work, which method works, which technology works. what are the design requirements, and which will complete the circle to further what new or modern technologies to adopt. And this is what you will see. What we usually focus is there is very rarely a big shift. Even if I say we are at that paradigm shift, construction industry is fairly slow to react. So what we have been doing is the continuous marginal improvement. Like you keep the thing, take it, and keep tweaking it. Right? If it takes 3 hours to produce 1 cubic meter of concrete, see how we can do that in 2.75 hours. Maybe next year try how we can do that 2 hours. Percentage improvement, but continuously keep tweaking at it. And this is exactly what you will see in what precast construction we are doing and what we have done over the last decade and probably where we'll go. But why we need mechanization and what's the scales? I think the project photo that you see is our Atal Setu, which connects Mumbai to Navi Mumbai. It's one of the longest sea bridges in India, marginally lesser than what we have in China, but it goes for about 21 kilometers. And this is one picture, right? This is not precast concrete. The segment is actually OSD, which is orthotropic steel deck. So the entire 150-meter long girder, which is 12-meter wide, is produced off-site, brought on a barge and installed. Right? And the picture at the first hand doesn't give you the scale, but if you want to look at this red box area and look at it, these are actually the people standing on it. And now if you look at that picture again, it will tell you that barge itself is a football field length. Right? It was built in India by L&T. Floats it, controls the vertical up and down within 2 to 3 millimeters. And what used to take such span of about 150-meter long and a 12-meter wide, 3 to 4 months to build, is being installed in about 2.5 hours on that bridge. And that's where the mechanization is helping. That's where that mechanization is bringing that productivity improvement. Right? So now if we bring that same mechanization in buildings industry, where we would look at. Right? And this is probably the second slide that I would want you to take home, especially when we look at buildings, is we have a range of buildings, right? So we start looking at it, okay, where I can adopt what. And usually the buildings are dealt in terms of height, more than the horizontal spread. Usually the design, everything, functionality, everything depends on the height. So we start looking at from a low-rise building and to high-rise. And the S curve is drawn with a specific need. If anybody who has taken the recent math, the rate of change of technology adoption, if you draw a derivative to this curve, it is going to reflect that rate of change. So wherever that curve is steeper, more bubbling in that sector, more need for construction methods in the sector. So with that perspective, if you see bottom, which is low-rise construction, when we say low-rise, usually about 5 to 6-story buildings, to the middle span, which is about 5 to about 30-story buildings. And then at the top, when it starts moving, if I have to put my pointer out here, it comes where you have more than 30 stories to super tall building. We are doing 60 stories. Right? So low rise, the curve is flatter. There is not much going on. We are fairly happy with what we are doing. It's easier to build low rise buildings. Of course, you would have heard we have done 3D concrete printing now. So we have already delivered about 50,000 square foot buildings where 2-story buildings, 3, 4. Right, and your backyard, this is for BRO in Chandigarh, where these buildings are now standing. As you go to the mid-rise section, aluminum formwork is what you will use mostly of the residential construction, but we are using precast, we are using moving to modular or volumetric construction in this space, but lot of change because 5 to 30 is where most of your projects are operating. Then if you go 30 floors and above, usually major cities, Mumbai, Delhi, Bangalore, some now. And there the tall buildings, because the number of buildings is limited, we have very advanced systems. If you see in this picture itself, a climbing formwork, which once the building starts and the core around it, we have system that works faster than precast as well. because it's one single building. There is a climbing. We can justify that and build those building faster. Where we are looking at is on those buildings when we start building the surrounding the core, maybe bring precast panels, pre-finished windows installs. Those are being looked at, but not a great big need. We are fairly happy with what we do. So, like I said, this is the sector where you are going to look at various technologies, and that kind of applicable to pan India, not a particular city or particular range. Now, how will we look at those technologies and how we will adopt is whether precast, whether steel, you look on each side, and these are the two things. If you are in the construction space, we are of the opinion that one single system is not going to make or break it. Right? We are going forward, we are going to see some sort of hybrid construction where multiple technologies, you take advantage of those and adopt it. But we are fairly sure that we are going to go offsite. And this is one of the key things where the industry is shifting now, is whether you do steel, whether you do precast, whether you do kind of hybrid. The message is you get out of the site. You go off site, you go in a controlled environment, you set up a factory, you build, bring it and assemble at site. That is what we are looking at. And that is the core philosophy where we started looking at residential buildings. Is these are the projects we have finished to date, and we'll go through the summary also now. But many residential which kind of fit in that window, right? That 5 to 30 story. We want to do offsite. We want to do hybrid combination. So precast now is precast new. You see Motera Stadium. I'm sure many matches you would have seen. I'm sure many of you have visited also there. It is 100% precast, yeah, including all these fancy Y columns, and that you'll see each column was about 230 ton, and we built that in precast. It's been there, sitting there for long time. Most of you would have heard high-speed railway. We are building the first one, Mumbai Ahmedabad. Another year or so it will be going, and this is a picture right from that. What you see in screen is a 40-meter long single cast girder. It weighs about 1,000 tons, right? Pretty fancy stuff. But if you asked that site, they are more proud about that straddle carrier that we have built in-house in India, which carries that girder. But the girder and precast is mainstream for them. They've been doing that for last 20-25 years. There is hardly any bridge that we see these days which is built using conventional methods. It is always either segmental or this is a full span, what we call it, system. So why we are saying precast new or precast as a modern technology or a new technology is in residential construction or building construction has not been predominantly used, right? Now, there are various reasons why this, that, but India actually is one of the unique countries where one residential industry has this kind of demand, right? Lot of cluster housing, mass housing is for our population, China and India. Second, if you see technology wise also usually design, we are one of the few countries where it rains heavily. One of the few countries where we have presence of seismic considerations, right? If you take US, not as much rains, seismic is there. If you take Singapore, which is, these are the countries which have adopted precast, where a lot of rains but no seismic. If you go to Middle East, almost no seismic, no rain also. So these countries have easily adopted. But in India, those parameters affect. And that's how we have seen that earlier we started with conventional. We went with tunnel formwork. Tunnel formwork is still one of the fastest systems to get to build residential buildings, but very niche buildings, very unique challenges. From there, we moved to aluminum formwork. And this is nothing but entire floor you put shuttering, where earlier we used to do beams, columns, maybe some walls and do the block work. Instead, we said we'll do pour the building, the entire floor in concrete. And 95% of our work that we do today, which is about 400 to 450 towers under construction across India, we do this with aluminum formwork. Most of the industry also since then, I think we were one of the first ones in 2002 to bring aluminum formwork. Now most of the construction industry is using that. and the same system, if you will see, is slightly more expensive. It has slightly more concrete compared to your conventional beam column system. But it was done and it has become one of the popular systems is because much faster. What used to take about 25 to 30 days to build one floor, and which is where generally that 28-day strength becomes a norm, because you have to start building the next floor and you have to be assured that the concrete has developed enough strength. In aluminum formwork, we are doing that same work in about 15 to 18 days. So 30 to 40% improvement. And why beneficial? Because there is only one activity of shuttering, and then you pour your walls and slab together to build that floor. From there came time in about 2010, which I said about 15 years ago, is this speed improvement itself was not enough. The 30% improvement, we were looking at further larger projects where we started looking at precast. Right? And that precast is nothing but exact same system, look, touch, feel wise, you will get the same system, but everything is assembled at the factory. So that offsite component, what I mentioned, is what we are looking at. Otherwise, once the building is constructed, even our own engineers will not be able to find the differences between this cast in place aluminum formwork and precast. But in terms of productivity, still 30-40% improvement compared to aluminum formwork. So again, if I have to broadly give you a feel, what used to take 28 days in aluminum formwork will take about 15 to 18 days. In precast, it will take somewhere around 8 to 9 days. And that's the overall benefit why we are looking at this system. So if I have to put that same thing, this is the third slide I would want to take you home, is if I have to compare those at a very engineered broad level, we started looking at our own data. Right, this is nothing. It's inside L&T. We took up a project about 3 years ago. One area which is done by aluminum formwork. The second in the same about a kilometer away from the aluminum formwork building in precast. Same building types. It's within the same projects. So same challenges, same weather, same number of people, same setups, whatever social and geographical parameters. And what we looked at is, if I have to make 1 cubic meter of concrete using aluminum formwork, right? When I say make, is actual structure. So you build 4 walls and 1 slab, where the total cubic meter is about 1 to build that system. I will put about 5.5 people to make it. Now, what 5.5 people? 1 person to pour concrete, about 3 people to build the shuttering around it, about 1.5 people to tie the reinforcement, right? So this is that overall 1 year data divided by total cubic meter and number of people required. For per cubic meter, I need this. If I switch to a basic precast system, which is very conventional, nothing fancy, a basic factory, instead of those 5.5 to make the same cubic meter, same 4 walls and slab, I will need only 3.5 people. If I make slightly advanced, let's say some circulation, robotics, concrete is poured automatically, that 3.5 further gets reduced to 2.5, right? So imagine that. This is why we are using technology, because we are finally, L&T is a contractor, right? We can't do technologies unless they start saving us something somewhere, giving us the benefit, the value engineering. So the benefit is this, which is of course gets translated to the clients also, is from 5.5 we are jumping to 2.5, right? Now what gets usually missed at it, and what I will keep coming back, is you have to put together or put yourself in the system and look at these splits. If this 5.5, all those 5.5 people, when they are building this concrete, they are at site. In precast, only these 0.75 people are at site. Out of that 2.5, everything else is sitting in the factory. And this is where the technology is important, because I'm not interested that 5.5 to 2.5, this is yes. But the real challenge today happening is at site, where it's extremely getting difficult to control the sites, control the water, power. There are seasonal, if not something, some people will come and demonstrate. There is absolute lack of quality control. You are building a 30-story tall building, sending these 5.5 people 30 stories above every day and get concrete poured, move your concrete, pump it up, move your shuttering up. Extremely challenging. Whereas all this is happening at factory on a ground level in the control environment. People come, park their bike or stay very nearby, do honest work of a 10-hour shift and move away. 70% reduction in the site activities. And this is where that offsite is important, is I am able to manage those risks much, much better, right? And this is what the construction industry has not seen to date, but that risk is governing everything. Whether I will be able to deliver what I promise has a lot more value than speed itself. So 5 years ago, we were looking at speed, speed, speed. But what we have figured out now is more than speed. If your client is much, much happier, if you tell that, okay, I'm going to deliver this in 10 days, and you actually deliver that in 10 days. That is the deliver what you promise. What is happening at conventional is, yes, that 15 days is very interesting, what used to take 30 days. But the 15 days, because everything is at sites, sometimes goes to even 25 days. Whereas this, I am able to control much, much better. And this is why we need technology, right? And this is why this slide is important, third slide to take home. So how we have evolved now, what projects, I think if you see about 2010, we started one as a pilot project, about 12 lakh square foot built up area. These are about 2000 houses. But one of the tallest buildings even to date, 70-meter tall building was done in Mumbai. From there, we have come, second project about 60 lakh square feet. Another we took about 17 lakh square feet. We are now looking at or actually operating another one which is 2000 crore plus, and we are as we speak today we are looking at another which is about 20 million square feet. So it has become, over the years, 15 years, it has become a mainstream technologies where we another 6 months we will have more than 150 lakh square foot of built up area constructed in this system. Now, what next? So we are, I remember we do always that continual marginal improvement, right? So last 2 years, we like, okay, we've been doing this, but what best we can do? And these are pretty much the epitomes that you will see in this space. Left-hand side, if you will see, we took a project 2 years ago, where this is an actual building in that running project, which was built in only 36 days, right? It's a 12-story building. Each floor has about 8 flats, so 96 flats. And those 96 flats were not only built in 36 days, but it was finished also in total 96 days and delivered to the client. So what used to take usually 6.5 to 7 months to do in conventional, which at site we were operating in probably about 4 months, was done 96 days, fully handed over building, right? So at least about 50% further improved. Same way, about 6 months ago, we took, okay, residential is there. We want to get into now beams, columns, commercial building. So one parking structure we built in just 45 days, right? So this is about 330 car park setup. Will take anywhere between 5 to 6 months if I use a conventional system, but was built in 45 days flat. Of course, foundation was done, but the superstructure, even in this building, the foundation, the first floor, whatever is conventional was done ahead of time, but the superstructure. But in both projects now, you will see each floor was built in 3 days. And what we are more proud is from the first floor onward itself, every floor was done exactly 3 days. And that's that promise, deliver what you promise, planning. It needs extreme planning to do that, okay, I have this many number of elements, daily I'm going to install these in one floor, 3 days. And that first floor itself was done in 3 days, and then every floor 3 days, exactly 36 days. Same way here, we actually, this was done 2 days before we planned for 45, it was done in 42 days. And this is where that technology advantage is there. Now, where all we can take the technology, of course, it starts at design. So up to 90-meter tall, we are doing precast, total precast buildings. A lot of R&D is done, tests done. We will do some of that in the coming slides. But more than 90 up to 150 meter, we have options where we'll do hybrid, where the core will be still because we have to further do the tests. We have to do seismic, how it works. Even around the world, there are only very few buildings which are more than 100-meter tall. So that we use an optional hybrid system. What we do engineering wise is again no rocket science. Same layout is taken, whatever that you are using. Some wall slabs are split as much as possible, two-dimensional, and those are broken. And then these elements are produced in the factory in that quality control, brought it to site, and then they are stitched together with a variety of connections. Without going into too many details of that, the whole thing I would want you to focus is emulative, right? So the design philosophy, what we have adopted here so far in India, is emulative. And as the name suggests, what emulative means is once the construction is done, once these two panels and slabs are connected together using wet concrete, we call it stitching. These buildings will behave similar to a conventional cast in place building. And usually the discussions on precast and seismic, they are more sensitive where the outside world is using welded connections, bolted connections, mechanical connections. We are not using those. We are not there yet. We are spending extra time. Those are even much more faster connections, but we are not using those. But we spend extra time to connect them together to get that performance out of it, right? And then what we are leading is, these are some of the photos of the building. This was the first building. This is what we did in Bangalore, about 35 buildings, fully residential. And some photos, if you'll see, again, from the functionality aspects, you will specifically notice that the look, touch, and feel of the system is exactly same as what your customer or end user is used to, right? The same kind of building elevations, sunshade, chajjas, balconies. Because I'm using a different technology, because speed is clients or speed is contractors, but the end user doesn't care. They have to live with that building for 50 years. So because you're using a technology, we cannot offer or do something drastically different. And that's what a lot of care in detailing, design, engineering is taken, where your buildings look, touch, and feel is taken care of. These are some of the other buildings we are doing in Mumbai now. Many buildings standing, completed, taller buildings under construction. This is that repeat project which we have also built to about 50% done now using this system, right? Not only from outside, but even from inside. The finished flat is where your end user is going to spend most of the time. They shall not have any different. And these are the finished photos. The flat once finished, even like I said earlier, our own engineers will not be able to find joints. For example, here there is a joint here. There is a joint at the corners where we do stitching. But the way the engineering and detailing is done, you will not find any difference in terms. Now, how we do it? We set up temporary factories at site, right? And when I mean temporary, this is exactly what a temporary factory looks for us, right? So it's by no means anything less than a state-of-the-art factory. It's just that we don't have a central factory yet, because transporting these heavy elements with large trucks in cities like Mumbai and all becomes very tricky. We don't have that kind of infrastructure. So what we do is we take up a parcel of land right next to the project. If this is the project, we set up a factory right there. You spend about 6 to 8 months setting up that factory, and then the elements are delivered and the construction is done. Now here you will see it's right next. Sometimes these are 3-4 kilometers away, but still a manageable distance, where you don't want your truck stuck in the traffic for 3-4 hours when you are building 300 elements a day. So that's how the factories are built. Further mechanization, right? We said, I noted that precast and then semi-automatic and fully automatic. So one of the factories now that we are operating this for last 4 months, it's a fully automatic battery mold system, right? So these are vertical. If you see these gaps, this is where they spread out on a rail. So these are 20 panels each, 10 here, 10 here. At a push of a button, they will open up. You work on the 5 panels, whatever walls that you have to build, put the cage, do the conduiting, everything. Once all are done, they close, and there is a hydraulic system where all these cells are kept together. So there is no concrete slurry loss. Quality is much better. You get vertical casting. You get both side mold finish. With horizontal casting, you don't get that. And then we have set up this concrete shuttle. You see this is the track, and that track goes all the way to the batching plant. And then this concrete shuttle brings the concrete to this mold. This is the distributor. You will see the funnel. So that shuttle, the funnel goes there. Shuttle will drop the concrete, and then this distributor system will pour concrete into this cells. Right. Now, how does this help everybody? Is one horizontal casting take a lot of space. Horizontal casting has one surface which is manually finished. It's not very flat. This concrete, there is no transit mixer anymore. So right when it's mixed, under 6 to 7 minutes, that concrete comes and gets poured into this panel. And one of the largest quality control concern is your transit mixer. You would never know how long it is mixing, how much water is added, what happened on the site or what happened on the road, how much it was waiting, whether the consistency is there or not. All those issues are gone here. There is no manual intervention in this system from batching plant to mold. Everything is automatically produced and cast. These have their own vibrators. So we are not even doing the needles anymore. They're sides, they're at the top, they're at the middle. Once the concrete is poured, the entire system gets vibrated. You get clean looking panel, both sides finished, which is directly ready to paint. Right. Now, what all kind of jobs? Of course, residential, I already showed pictures, but we are taking it up now everywhere. So this is in for a Reliance in Jamnagar, which is an electrical building. It's a massive building if you see a person standing here. But all these portal frames are done in precast. Walls are in precast. The entire building is built without any on-site activity, right? And much faster. Same way we are doing this parking structure I showed, but office buildings where beams and columns and hollow core long span buildings. These buildings have been standing. This was that MLCP where we use this hollow core slabs, much faster system, right? How much faster is we installed, I think this number is showing 5 hours, but later we have installed even around 55 to 60 slabs in that 10 hours time. If I have to compare that productivity, which is what we focus on, and these are pre-stressed slabs, they are produced in the factory and installed at the site. Usually, if anybody in the structural background, this is a slab and then we pour concrete on top of it so that they behave together, right? So this slab, even if I say that acts as a shuttering, usually my shuttering productivity norms are about 3 to 4 square meter shuttering per person in one shift. If I compare this as shuttering, instead of that 3 to 4 square meter, we are doing about 100 to 125 square meter per person per shift. That's the multifold productivity improvement. That's kind of speed is what we are looking at in these systems. This is something different. I just wanted to put it up again is toilet pods. So this is a toilet pod in a residential building, a concrete pod. And this picture is taken from within the same pod. So all this is already done at factory in this toilet pod, finished all activities, and then install at site to build around it. All you do is probably just change the outside door because that usually sees the site activities. You cannot put the finished door. But why we did that is again same offsite, right? To get a gang of 5 people on a 21st floor to get the work done, the piping, the grouting, the tiling under that same quality and making sure all the checks are done, balances are done, is a task. I'm not saying can't be done. We are doing that. But it's much, much easier if you do in a ground level factory setup where the processes are set up, and that's how we are pushing. This has its own challenges. You need a large space, you need a lot more inventory. But if those challenges are avoided, we are doing now these toilet pods everywhere. So if you see in this project itself, we set up a small factory at that project. It was done at a pilot level. They were produced, they were kept and finished everything on ground. And then we had one space where the building tower crane itself lifted these directly from the factory and installed. It was a pilot project. We could do that, but much faster productivity, much better quality. Same way, a lot of architectural precast. If you ever come to Mumbai, this is IKEA Navi Mumbai store, hollow core slab, one of the longest till date with 750 kg per square meter load. Right, this we did in 2017 time frame, and 16-meter span with 750 kg per square meter warehouse load. If you see, the best advantage was this is floor to floor is 8 meter, so no shoring, nothing. The slab were directly placed, and within 50% improvement in construction time. And this is where that product was ideal. Steel frames, hollow core slabs placed and did fast. Now you see how the industry has evolved. At 2017, we were fascinated that a 16-meter long slab is taking 750 kg. Last week, we have done load test for about 11-meter span, but with 2,500 kg per square meter for a data center. It's an entire new segment that we are doing in precast. But this is how the industry, this is how the size scales when we discuss, where usually building load is about 250 kg per square meter. From 250, we are going 10 times on data center to 2,500 kg per square meter. And that's where engineering is getting, construction is getting interesting year by year. This is another one. We did a substation building in a oil refinery project in Vizag, right? It's a 2,500 crore project. Within that, this is a 35 crore building. But this is the heart of the entire project. If this gets delayed, everything gets delayed. So they wanted to get it fast. So we proposed in precast and got it done. Like, these are some of the system, and this is evolving now. This was about 5 years ago, but from residential, we are now moving to all sorts of construction, and that's why I wanted to just put those pictures. Facade. Facade was another interesting item. If you see, this was an old job, but where the technology works, we have to find out. We cannot force the technology on anything. And this was one classic example. It's a tall building in Calcutta, where if you see, the architect wanted that wave pattern. They are not in one line. They wanted these fins in wave, right? Now, if I start doing this conventional formwork at site, every floor will have to shift the formwork. It will be just impossible to do that, and then it's very difficult to manage that, align it. They will shift formwork. By the time they pour, they will realize that it was wrongly done, and then it's all gone. So what we did is we did the building in conventional, but only these architectural elements we did precast offsite. They were all same. So production was exactly same. And then they were connected to the facade later with that pattern. It was much, much easier to do it that way. Same here. This was done in Hyderabad, where the building had a very unique look and they wanted to do everything in block work. We said we'll convert that to precast. And the entire facade was done in precast and only painted at site. So this entire block work plastering, which is what the most time consuming item, was done in precast. We did another step here in Mumbai project at a pilot level, steel building. We said, why block work? I will use welded connection, right? This is, like I said, these are dry connections, much, much, much faster. But it's a new industry, so pilot level we wanted to do that. So what we did is the panels had cast in welded embeds, and because the structural frame is steel, we welded those panels to the steel embed. The benefit, this is about 2.5 meter and 4 meter tall. If you do block work plaster, it will take at least 3.5 days without painting. When we started attaching this is about 25 minutes for the same area, attached to the building, crane gone, and that's the 10-15 times productivity improvement. Similar lot of factory buildings, wherever that technology works, right? This is another classic example, right? This is in Bangalore for a villa project. If you see, this is classic Bangalore English villa type, where they had these pyramid shaped roofs. These pyramid shaped roofs are sitting on an 8-meter double story height room. So if I have to do this in conventional concrete, I have to do the staging, which is 10-meter long, which is a huge or big number if you have to do that. One floor, usually 3-meter tall. Then I have to install the shuttering and that slope and do concreting, which we started doing that. And it was taking anywhere between 25 to 30 days to build this one roof. Then we said, no, only the roof we will switch it. So only the roof was done on ground, which we built the molds, permanent mold, no shoring, nothing. And only cast these 6x5-meter caps. And then the caps were installed on these villas, right? 6 to 7 hours per cap versus 25 days. And that's what we are looking at elements like this. This is another example of your Navi Mumbai airport, which is just opened up international airport in Mumbai. 15-kilometer long compound wall. Now, compound wall is nothing new. We have been doing that for years. I'm sure you would have seen that where you have these planks that are put together. And this is what it was planned and designed, saying 15 kilometer, do the planks. There were 20,000 planks, right? To install these 20,000 planks itself was becoming a challenge. So what we did, okay, we said, why planks? I'm going to do the entire panel in precast together. Now these planks are 80 millimeter thick. If I do one panel precast that long, which is 3 meter by 2.5 meter, and usual horizontal casting, I will need at least thickness of 125 to 150 millimeters, so I can handle and do everything. And that was not there, clients, because client wouldn't pay extra. So I said, you figure it out. So what we did is we built vertical molds, and we cast that entire panel vertical. We lifted it vertical, stored it vertical, transported it vertical, installed it vertical. In its entire lifetime, it never saw any horizontal. So within that same 80 millimeter thickness, we were able to do this one full panel with the logo and everything. The benefit, 20,000 elements became 5,000. That 5,000 elements were still installed using the same P&M, same equipment, same little crane that I would have used for a plank. So without adding any extra resources in terms of heavy equipment, heavy machinery, we reduced the quantum to 25% only. And wall was done much, much faster. Right. So that's the flavor of technology. I think I am somewhere at that 35-40 minute mark. The balance 10-15 minutes I'm going to spend on the digital aspect, what we are doing. I think questions, if any, we'll take it at the end of it. But I just wanted to give you a heads up that only 10 more minutes of this torture and it will get over. So what in digital space, right? So this is an actual picture about 5 years ago. And this is the volume that we are building. Right, this project has about 7,500 houses. These 7,500 houses are being built using about 1,15,000 elements. The digital, what I am discussing, tracking, progress monitoring and all, at this scale, when we are tracking 1,15,000 element, your Excel, your day-to-day planning notebook is just not feasible. So that digitalization is not a luxury. It has become a mandatory requirement where I have to model everything and then track it. Right? We are still thinking there are people, but since 2014 onwards, we have adopted BIM. All our residential projects since then for last 12 years, from about 60-70% 12 years ago to 98% plus now, only very niche something or which is very fast paced. We don't do that, but everything is on the BIM. Right? How that BIM is helping me is the central model. Once it's there, like I said, 1,25,000 elements or 15,000 elements to track. That one model is able to interface with multiple agencies, some one way, some two ways. And the whole crux of it is productivity. So the back and forth, turn around, take prints, model, everything is being done that, and it has become a norm, but it is helping greatly. And then we have our own app in-house that is developed, where if you see this one snapshot, this is my precast wall panel with the reinforcement and everything, whatever that goes. Even a 6 millimeter link is modeled. Once that model which has this reinforcement and everything, I am for the production or shop drawings, we are not doing separate drawing anymore for last 5 years. At the click of button, 85% of that drawing is generated. Tomorrow, if somebody wants to change this window size, production drawing was ready. We used to do from scratch, AutoCAD, everything, print it again. We are not printing production drawings also anymore. You change the window here, it adjusts the reinforcement around it, and immediately, instantly, that shop drawing is ready. For our precast mold shuttering, those mold drawings are also being imported from the BIM model. So there are no more manual checks to measure dimension, make sure that the shuttering or the mold is of the same size. Everything is controlled and that manual intervention is taken out. Once it goes to site, I mentioned we have an our tracking app. Now this app, that one wall panel I showed, it will track the entire history of that wall panel, when it was cast, at what strength it was demolded, who did the inspection, who signed it off. There is the checklist, where it is stored, when it was picked up from the factory and delivered. Entire life history is tracked, recorded, available at the fingertips, panel by panel. Right. Real-time snapshots of that status, how many panels are there, how many are cast, how many are on the truck, how many are at the site, is given and updated real time. That is one of the biggest things of this digitalization is uh, before these tools, site, everything gets tracked on Excel. At the end of the day, somebody is making that report saying, today I cast these many, today I stored these many in the yard, and 25 of them were on the truck. That updated report, somebody checks it next day morning, reviews it, saying, this is good to go, publishes it to their cluster office. Cluster office will review, and they said, okay, good to go. End of the day, we'll push it to the head office. By the time head office gets, 2 or 3 days are gone. Even if it's a problem, we don't know it. Here, now that engineer scans, 7 o'clock in the night, element is done. 7 same time it gets updated in the system. If I have to log in at 7:10, I am going to see how many panels are installed, whether they are per the plan or not, immediately. So it's all real time happening. Same tower progress, we have now digital twin models also, where in the model itself it will show how many panels are there, where they planned, what are planned tomorrow, and taken up. This is another very nifty tool that we use. Is there are sensors are placed in the concrete panels, and they will measure the strength real time. So if you'll see, this is an app here, and it will show that 6 hours now, and the 12 MPa strength is there. How it helps is again efficiency. And what we saw in our factories is we usually are following the cube test, right? And in this app also, we are still doing the cube test, but our requirement is about 15 MPa in 18 hours before I can take the panel out of the mold and start the next day's work. So when we were doing the cube breaks, we found in a year-long data that instead of 15 MPa, all cubes were breaking somewhere around 18 to 19 MPa. For 4 MPa, that's a big shift. It's a 2 or 3 hours of delay. Every day on a 24-hour cycle, that 2 hours is a big number. So we started asking why, who is waiting until 19? The interesting reason was the QC decides when to break the cube. They have limited stock of cube. So on their gut, if the person who is in charge, if he breaks saying, now it has come and breaks, and for God's if the cube breaks at 14.5 instead of 15, they don't have additional size of cubes and they cannot decide now whether this is 15 or not, it will get rejected. So to avoid that situation, they were waiting and they're making sure that when the cube breaks, it has to be more than 15. And this decision making was leading that all cubes are breaking in that 18 to 19 because they're fine there. Everybody wants to add the cushion. So they were doing that. Then we started using this tool where the software is telling that, okay, it is tentatively your panel now has reached 15 MPa. Once that indication is there, they go and still break the cubes. But now the cubes are breaking that 15 to 16 MPa, and the indication, the digital tools are helping to improve that efficiency. And such efficiencies you will see across company. We have now that digitalization has become a way of life. We have hundreds of equipment. We have 11,000 construction equipment connected to online. We are at that industry 4.0 moving next forward. And these are some of the examples I will show, and then we will close it. These are not related to precast directly, but where we are using this tool. So if you see this example, this was a video made for a tender presentation of how the project will be operated. This is for our Varanasi cricket stadium. It will be inaugurated in next couple of months. It's a total precast stadium. But even before we go to the site, these tools, the scans and all are helping, where this video is exactly showing to client, for us also, saying how I will manage the project, how I will bring the truck, where it will turn, where will people walk from their colonies to site, what will be the people management. In L&T, usually one of the biggest thumb rules is, if you are involved in the project, all you do is, first thing you do is visit the site. Unless you visit the site, nobody will trust you that what you plan or not. But those days are now going on, because these tools, you can make these videos fairly quickly to the scale and get things done. This is for a Delhi railway station project. It looks like a picture, but it's a point cloud. There are thousands of points scanned in about 40 minutes, which will give you the exact picture of that whole railway station in terms of, it can be broken down. If you give the command saying count the number of trees, it will count the number of trees to electricity poles. And what survey used to take days, sometimes 2 weeks, is now getting done in about 6 hours work. A lot of other tools in terms of scanning, again, like I said, without going into too many details, but what used to be dream fancy land when we were in college, which 5 years ago used to be, so somebody in China is only using that. These things are being used at our sites now, where you are using the twins, you are using for visualization, you are using for verification, where what will come as builds are correct or not. Everything is being watched, everything is being adopted, saying how this will go. This is our central secretariat job, where it will show you where the ventilation, where some conflicts are there, how the surveys are done. Things like that are being done. Wastage control, I said, was one of the big things. So we have been looking at that. So we have system now. The diesel was used to be one of the biggest pilferage item. Nobody knows how much diesel, who is consuming what. So now we have systems where the pump talks to the truck. It identifies the truck. Once the truck comes, it will automatically pull up how much this truck has done diesel this month, how much is the plant. If it has quota, then only that diesel gets dispensed in that truck. Otherwise, it will flag it somebody. Earlier, it used to be saying we had 100 liter for a truck for a particular period. Month down, you will say it has already consumed 200 liter. Then whoever, whatever reason this happened, that happened, but it used to happen. Now it is all controlled. Same for our batching plant. Every batching plant is connected. What is the productivity? How much cubic meter is used? How much was supposed to be done per hour? Everything is getting tracked. Data is collected, where we are now looking at predictive analytics. So this is one of our safety screens, where all the projects, based on the observations that the projects are getting in the initial stages, they get compared to a 10-year database and get flagged that, oh, some of these incidences means some systems are not set up at that site. It will get flagged saying something is going to go horribly wrong, go and visit. And these indications are getting to the head office level, so that they can plan and visit using that database. So with that, I will conclude. I think going back to my old life, precast, where we will go, right? This is where we want to go. These are futuristic jobs for India, but we already used to operate. But if you'll see these buildings, these are total precast buildings. Even the brickwork and the paint is done at factory. So whatever I have shown you so far is just concreting. We are still finishing it at site. We are still painting those. We are still putting a lot of efforts to finish this. But these buildings, if you see, the bricks are cast in the precast panel at the factory. All the site work they have done is just treat the joints with the sealant. Otherwise, all these buildings, modularity, if you see precast needs modularity, this is a total precast building with so many variations and architectural features. There is a parking structure behind. Total can be done. And this is where we are now. I think next 10 years, probably India will see is pre-finished buildings where everything is done at factory. Like this panel, this is a Marriott hotel building. This is gray cement. This is brown cement. No paint. These windows are installed in the factories and panels shipped. They have thermal insulation inside, which works much better in terms of heat and energy. Same office building. These are not colored buildings. This is white cement, gray cement, and buildings like that in schools, in architectural treatment. So this is where I think this is where we'll go. I'm going to conclude with this video. This is that Mission 96 video that we mentioned. And I think I'm right on time, another 2 minutes. So it will give you a flavor of what that Mission 96 was, how that building was planned, done, and what can really be done. I think I shared with the audio, so hopefully you're able to hear the audio, right? In the initial clip. I'll run it anyway, you look at it, and then we'll conclude. All right. So with that, thank you very much. Appreciate your patient hearing. I think, yeah, if we have any questions or whichever way we want to take.
Yes, that was quite an informative and insightful talk, Mr. Burde. We are delighted to get lot of field-related information from your end. The floor is open for discussions and queries now. I request if any of the faculty members or the students or the industry persons have any questions to Mr. Burde. Okay, if no one is available, I have one just small query, Mr. Bird, as you have completed all the aspects of the precast construction as well as the importance of digitalization. One small query from my end is from the perception of the end user, are there any noticeable differences in the performance of precast residential buildings with respect to the structural safety, durability, thermal comfort, sound insulation, and maintenance when compared to the conventionally constructed buildings?
So yeah, actually, a variety of questions in there. I can probably spend another 2 hours explaining each. But quickly is as far as the functionality is concerned, because it's precast technology, you are not going to get anything different. So if you are now using an aluminum formwork building, which is what 95% of the people are seeing these days, you are getting the same exact system, same concrete thicknesses, same detailing, same walls, absolutely no difference. The one big difference you will gain advantage is the concrete is minimum M50 grade and above. So it's highly durable, because at factory level for my cycle times and all, we need minimum that 15 MPa we discussed about. So automatically concrete strength system is highly durable. The joints is a concern for everyone, and it is a concern. I'm not going to say, because to on paper that system works beautifully. To get that quality control assurance is not everybody's skill set. So as long as there are people who are who know what they're doing, that system we have now. I showed the pictures building standing, where earlier, the initial pilot project buildings that we operated, we used to get about 10 to 12% areas where you will get leakages through the joints. As of today, the way we have evolved the technology and all, that number is about 2%. And it is actually lesser than conventional construction in my mind, because in precast, we only have to worry about the joints, right? That quality control, make sure that things are done well, make sure there are level of defenses. But the first building that I showed, the 70-meter tall building, which is 2,000 apartments. Each apartment has one toilet and one bath, so about 4,000 those pods. And usually in our construction, the toilet is one of the biggest areas where water seeps. Concrete is not in impervious material, but high quality, that M50 helps, where not a single complaint of all those 4,000 pots where leakage was there. Of course, there is waterproofing treatment, everything. But because of that factory produce advantage, not a single toilet has leaked. We have had other areas, the 10% of the joints. Same thing if you will see when we look at the seepages in the flats. 99.9% we don't have leakages in the slab alone. It's always at the joints, where to a level we are actually flooding the whole flat with 1 inch water for 4 hours. Not just the kitchen, not just the toilet, because it's a new system. Because Indian household is using a lot of water within the house also. We do a test where we simulate the rains on these joints from external, and from inside we just flood the entire flat and then test it. So entire flat, imagine, gets tested for 1 inch of water filled everywhere. And then we look from the flat below what is seeping. And 99.99% slabs don't have the seepage, because again, that high grade concrete, factory controlled concrete. The work that is done at site, which are the joints, we do see now 2-3%, which we control. In terms of thermal, sound, all other parameters you noted, we have now a variety of approvals through all from IIT Madras to IIT Delhi to Bombay and major leading institute, which performance is equivalent.
Thank you, Mr. Burde. Now we have come to the end of this technical session. Mr. Burde, your presentation has been immensely enriching and has offered us a comprehensive understanding of the evolution of precast technology in India over the last decade. The practical experiences you shared from Larsen and Toubro, particularly in the areas of large-scale housing projects and digitalization, have given our participants a valuable industry insights that go far beyond what textbooks can offer. On behalf of the Department of Civil Engineering at Jesus University in Noida, we sincerely thank you for taking time to share your expertise with us. Ladies and gentlemen, it's now we move forward for the next session, that is the panel discussion. We have eminent industry persons, Mr. Pramod Adlaka, Managing Director, Adlaka Associates Private Limited. We have Mr. Amit Burde, who is the Head Precast Initiatives, Larsen and Toubro, Mumbai, Maharashtra. We have Mr. Ashish Pipal, who's a scientist in CSIR CBRI. Welcome to all the eminent panel members. Now I request my colleague, Mr. Bharat, to please moderate the session and take over the panel discussion, please. Mr. Bharat.
Okay, good afternoon, everyone. So after an enriching series of technical sessions that we have gone throughout the day, so we now arrive at one of the most engaging segments of today's summit, that is the panel discussion. So it's my pleasure to welcome our distinguished panelists, who collectively represent the industry, research, and consulting and academia. So their diverse experience promises to provide us with a comprehensive perspective on the opportunities and the challenges of precast construction in India. So to go ahead, like the first topic that we would discuss is that what is the biggest bottleneck to scaling the precast or prefab in Indian housing? So is it the cost, or is it the skilled labor, or the awareness? So I like if Amit Bhate sir can share his opinion on this.
Yeah, I actually couldn't hear your question well.
Okay, sir, I'll repeat the question, sir. What is the biggest bottleneck to scaling the precast or prefab in Indian housing? Is it the
Yeah.
cost, skilled labor, or the awareness?
Yeah, actually, cost is always there, right? Indian market, if you see, one of the biggest thing is it's an extremely cost sensitive market. As a social community, we look at that. So value engineering always plays a big role. In our experience also everywhere, if you say the quality, the speed, the safety is one side, and it's valued only if it matches my existing ongoing costs. If it's 1 rupee per square foot more, the interest goes multifold down. So the cost is for every technology, not just for precast. This is how the industry operates. If you see outside the world, they will pay 3 times the premium if there is value for time, and that is coming now slowly. But we are not there yet. So at the same cost, whatever that you do becomes a constraint. Now beyond that, then cost constraint, the bottleneck that we see is your infrastructure. I mentioned that we don't have that infrastructure where we can easily transport large elements. We don't have that kind of road network. It is again evolving. Last year we built one of these parking structures in Mumbai where the slabs came from Ahmedabad. So it's not like, but this was not possible 10 years ago. So that is also changing. But it is one of the unique things. We are not doing it day in, day out. So to work around it, I am setting up these factories at the project site. Right? Now you saw the picture of the factory. That doesn't come overnight. We spend good amount of 6 to 8 months to set up that factory, and the project duration is about 2 years after you set up the factory. After the 2 years, I am going to scrap that factory, take everything and end it. And this is one of the biggest bottleneck today for us in precast. Is for a 2 year project, I am spending 8 months efforts, and that 8 months factory, if it's a central factory, it will go for next 15 years operate with that I cannot afford to do it here. Right now, that has a cost. If one factory of 100 rupees I am setting up and using for 15 years versus the same factory of 100 rupees that I am using for 2 years only, that cost is getting built into the project. Right? We are not finally, bottom line is money. We are contractors. We are not going to put our own money. So that is actually one of the biggest bottlenecks. Second is the heavy equipment and P&M. So we have heavy cranes. Like I showed you the crane that can lift 1,000 tons, the straddle carrier. But when it comes to residential construction, we need heavy tower cranes, which will go high. We cannot build straddle carrier which will go 100-meter tall. So we need tower crane. But tower cranes are limited by the capacity availability. There are outside world tower cranes which can lift 25 ton at 40 meter. We have usually 6-7 tons, so we are limited by that size. If I can lift 20 ton, I can go longer elements. If I go longer elements, my speed is half, because if I have to install 100 elements, I can install only 50 elements, longer elements, same time. So productivity is double. So those are the two big things that we are seeing in the current industry here, in residential particularly, that is holding us back.
Okay, thank you, sir. Thank you for the input. Adlaka sir, if you can, as Amit Bhate sir told us, it is mainly with the cost and also with the infrastructure, and then the tools and equipments or the machineries. So, any input that we can have from yourselves regarding the same.
That's one of the reasons I have been promoting intermediate technologies which are affordable, cost effective, and require minimum capex. Capex means minimum capital investment. Every Tom, Dick contractor can use these technologies. Every Tom, Dick contractor can use the technology even in the rural areas, semi-rural areas, town 3, 4, tier 3, 4 cities. This. So my experience is in small panel prefabrication. If you allow me, I want to show just 7 slides which I have prepared, which is a sort of a lessons which I have learned, and I want to convey it to the viewers. If you want to allow me that, or you can allow me at the end of this panel discussion, depending upon it.
Yes, sir. At the end of the session,
You
we'll
complete
definitely.
the views of others, and then just allow me. I want to show 7 slides. Last, that's the lessons which I have learned out of 55 years of my experience into these technologies.
Sure, sir. Sure, sir.
Please.
Mr. Ashish People, sir. So.
Yeah, as first of all, Good afternoon, Adlakha sir. It's been a pleasure seeing you after a long time. And thank you, for inviting me here. And as Mr. Vade rightly said, cost definitely is going to be a big, a challenge. But we also need to understand that, it's not always just about the direct costing. It's also about the indirect costing or indirect benefits that we get when we get into the prefabricated aspects. One indirect benefit or indirect cost that plays a very major role in completion of any project is the timeline. And with the prefabrication or the precasting in picture, we can beat that timeline in a quick way. So obviously that gets somewhat adjusted at that particular pace. So not just the indirect cost, we also have to look into the indirect cost aspect here, because that ultimately reduces your labor, reduces your timeline, and all those kind of things. So yes, that plays that definitely is going to play a major role. And but what I feel personally is that with the prefabrication things, that for the multi-story buildings and all, the performance of these buildings or the connections very specifically that they have, particularly in the event of a seismicity event or the seismic event, that ultimately is the reliability that people are getting, that how these connections are behaving or how these particular system is behaving in the event of an earthquake, that ultimately still that is evolving. We continuously are testing here many of these systems, and few systems are working, few are not working, those kind of things still is happening. This is an evolving methodology, evolving technology, but surely that has a future and it is evolving. Few of the technologies are doing wonders, few are still developing. So I'm not saying that any technology is bad, but yes, few require some modifications or adjustment to make them better, and few are working. So we still are working to bring more faith, more reliability into the prefabrication, and at the same time we also need to work on the optimization of these technologies, so that the people can use them in a better way without thinking about the direct cost much. So those two, I guess, are the bigger challenges to tackle into, and then we can, utilize these technologies very efficiently, because ultimately that's the future. So that anyhow is going to be there.
Okay, so as per the like the panelists' opinion, it was mainly concentrated on with the cost, whether it is the direct or indirect. And maybe if I can give, like, I have something to say, it would be that like awareness also plays a very major role. Right? Even in the like, if you are considering the low-rise buildings, or even with the like mass housing projects, if we are taking up, until and unless the higher ups who are available, they are aware about these technologies. So maybe like until we make them aware of it, and then the skilled labors also increase in this particular sector. So like that can add as a like a collaborative thing in increasing the efficiency of the precast technology or the prefab constructions. So thank you, sir. So the next question that we have for the panelists is, can what policy or regulatory changes like would accelerate the adoption of this precast technology faster? Amit Bhate, sir.
Yeah. So actually, those actually, when you say at the policy level, earlier the taxation used to be a challenge, but with the GST that has been a thing of a past. When I say that was a challenge, meaning you saw the toilet pots, what we did, and that idea we had also discussed 10 years ago. That I will finish everything. That has been the demand all along, saying if you can finish it in factory, it will help me a lot. But when we tried that 10 years ago, the pilot pod finished at a factory had a different taxation system, because it was considered as a finished product. It had VAT, it had duties and all. And that kind of held the adoption back. Now with this GST and all, that is fairly streamlined, and that's not a challenge anymore. At the policy level, yeah, of course, you cannot do one particular thing you build with this technology. But what we have come to an understanding now is the projects depend a lot on the technology that you select, the delivery, the layout, and that starts on the drawing board. What we are advocating now, because the scales and sizes of the projects are very different, we cannot design a project, especially housing, that was meant to be built using a beam column system, or that was meant to be using aluminum formwork system. Do the whole design, spend 6 months, get the approvals done, do the drawings, and then give it to build, saying now you build with precast or built with steel. That has a lot of challenges. The true efficiency of the product technology is never adopted. So what we feel is we have to go back where the way we are building projects has to be slightly modified. Is you select your technology first, whether it's steel, whether it's large panel, whether it's small panel, and design your projects for that technology. And that will give a lot more beneficial or the true, because aluminum formwork has its own benefits, tunnel formwork has its own benefits, precast has its own benefits. But if precast is kind of forced into a building that is designed for tunnel formwork, it will not work at that optimum efficiency. So that at policy level, something, and it's a lot of things are already under motion itself. But that's where you design your buildings for the technology, not design the technology for your buildings.
Like I said. Ashish sir, if we can hear from you first.
Yeah, see, as far as I understand, first of all, we need a rigorous test data and a robust system. So these two indeed are required, to bring a better faith in the technologies. And along with that, people earlier were, the industries were facing a very tough challenge in ultimately convincing the people that how these technologies will work, and how it will look, how it will function and all. So for that, I guess already government has in 2021, government started the Lighthouse project, which it was launched by Honorable PM in GSTC India. So under which in the 6 cities of our country, prefabricated multi-story construction occurred. That project already completed, and based on the same now, the various departments of the MOA, Ministry of Housing and Urban Affairs, is actually helping these industries to further disseminate the technologies. And these lighthouse projects are ultimately working as a live laboratory for the people to witness that yes, these technologies can function well, and how the connections are working, whether water tightness is there or not, how the high rise construction can happen, and all those kind of things. So government actually is already has started working in this, but yes, more or better dissemination still is required. And still for the industry counterparts, yes, these technologies are slowly getting the part of the SOR as well. So they surely can take care of these aspects. Apart from these 6, I've been a part of the recently constructed NIT Goa project as well. So that ultimately is again a completely prefabricated building, prefabricated structure. All the structures are completely prefabricated. So the government is creating live showcases for the people to see and feel how these technologies work on ground. So definitely the regulatory changes are happening, and right now what required is a further dissemination of these technologies on the ground. So that is already underway.
Like I said. So we can't hear you. Yes, sir.
Last.
Yes, sir.
Just a minute.
Can you give us a request for sharing? We want to share a slide.
Okay, then we just have one more question, and then like
Okay,
after that, I'll
just have one thing.
Thank you, sir. So the next question that we have is, how mature is BIM or digital twin adoption on real Indian job sites versus on paper? I'll repeat, like how mature is BIM or digital twin adoption on real Indian job sites versus on paper?
Yeah. So if I think if I may start on paper, like I said, we are 100% now, and that has become the norm. So and design offices and all, I think without BIM now we are not starting. The photos that I showed, it is being enforced from the client, which is the one of the projects is for Sidco, where the tender itself, and that was a 2018 tender, which enforce saying at the end of the project we should give an LOD 350 level plus preferably 500 level models handed over to the client so that they can get the maintenance and everything. And that is in place. We are actually, as we handing over these buildings, we are giving these models, including almost LOD 500 level, where except maybe the specific brands are not picked up for the valves and all, but even to the valve level, the models are there where performance characteristics are there. On ground, there is actually that to collect that kind of data is very tricky. With this now AI, it will generate much easier, but still a sizable portion is covered. So, and when I say on ground means actually using these tools to improve. The one challenge that we have seen is the transition, because BIM and all is fine. We will do 100% BIM model, we will give and all, but actually using that BIM for class detection at site, or using these tablets I show in the video to make sure that issues are captured before they are found. And this is where these tools are there. Otherwise, once one pipe starts hitting other, there is rarely you will go across. But these tools are going to help where even before those two pipes are going to come there, they get caught and they get moved, and so that we don't lose time. That adoption is coming. I don't think we are there yet, but it will come. Now, how we will help is we have understood that there is a lot of resistance, and it's not a classic old change management and handling resistance. The resistance is coming because we are at a transition phase where, because of adoption of these digital tools, we are actually adding to the work more. So if the engineer on ground, she still has to do, or he still has to do the checklist on paper, submit it to client, and then go to an app and again do the checklist for the sake of adding digital. Because I am enforcing saying I want the checklist done in app. Client is still saying, no, my PMC needs to physical sign. I need a physical paper. And this is holding a lot of things where we are now in that process where the app updates, checklist gets immediately printed, and some same checklist is submitted to the client. If we come to that phase, this adoption will very quickly go to 100%, because then only truly you will start seeing that the work is actually getting reduced. Right now, it's not even same, it is more, because at quality level, somebody's PMC is saying, no, I want my physical stamp checklist only. Your app, I don't care. Client is also saying, no, for our records, we need physical paper. So that transition, I think we are right in the middle of that. More and more, once that faith comes, and transition, because that trust is not there. Somewhere they feel, no, you sign digital, somewhere it gets modified. I don't know which checklist I will see. So when we build our systems where they're tamper proof, where we start trusting each other, these adoptions will be much, much, much quicker.
Ashish sir?
Yeah, as Mr. Amit rightly said, BIM definitely right now, the digital twin or the BIM, that definitely is getting places its rightful place on the paper or on the design files. But it's still, as he rightly said, it is a right now it's a phase where people are shifting from on paper to being digital. So every time when something this kind of shift happens, there comes a resistance from people because they are not comfortable with something. So that is the thing. And as far as till now, the construction industry of India is really dynamic. We start doing something, but as per site conditions we tries to modify those things. And these two things continuously, we have to keep it in sync. Otherwise, the people gets into havoc, that how, ultimately we have to modify the BIM. And these are the issues that is happening on site, but I have to keep it in sync with the BIM. So those kind of things. And again, there are papers that paperwork or the paper trail that they have to follow. So these are things which are right now creating a challenge, that yes, this thing is on paper, but we have to bring it on the ground. So people have started using it. They are definitely doing it for every of their major project. But ultimately, it's basically the people who runs the projects. So slowly, the industry is making the people, very comfortable with the BIM software, because there are a couple of people who are not conversant with this right now. So they are trying their best to make the people conversant with this software. And then, the shift slowly will happen. Right now it's underway, but slowly it definitely will happen.
Thank you so much, sir. Like participants, if any of you have any one question on which you want the panelists to have a discussion on. Anyone from the panelists? Sorry, anyone from the participants?
Please allow us for screen sharing.
Short slides. Seven.
Yes, ma'am.
One 53 total है. Last में चले गए.
Is it visible?
Yes. Yeah, we can see it. Again, full screen, please.
Last slide, sir, you were telling, right?
सबसे last slide, 7 slides है last के. कैसे बोले चले? उल्टा चलेगा. शुरू का है तो 250 स्लाइड. ये जो आ रहा है लिखा हुआ.
सर
हाँ, ये इससे
This one?
पहले क्या? हाँ, इससे पहले क्या है? और चलो इससे पहले. इससे
Hard
पहले
fact.
बस हार्ड फैक्ट्स.
Okay.
Sorry for getting delayed. I
Is it
just
audible?
Is it audible?
Yes. Yeah, we
Yes,
can
sir.
hear you.
Yes, sir.
Can I read it fast?
Yes, sir.
Okay. This is what I have learned during my experience of using alternate technologies. And most of them is prefab precast systems. Okay. This one slide first is hard facts, that is reluctance. Globally, low income affordable housing sector is very conservative. Any new technology with complete departure from traditional is bound to encounter number of external obstacles. Any change even if it is for betterment, is resisted by users. And users means habitants. Passionate for alternate technologies spend a major part of their energy in overtaking such resistance. Any entrepreneur, despite having social inclination, get discouraged when question of acceptability by users play predominant role. Unlike mobile phone, a house cannot quickly be rationalized because emotions and traditions dominate the choices. Unlike manufacturing and delivery of a consumer product, construction is a system which require complex delivery mechanism. Next. Then what is the technology ecosystem? Alternate technology market is born on pessimism, developed on optimism, grown on skepticism, and matured on euphoria, but would die on doltishness, बेवकूफी. Who are the villains for defeat of a technology? मैंने जो काम किया है, बहुत से technologies use की, but some of them got it defeated. Why? उसके reasons है ये by experience. Some intentionally got it defeated. So in some case, it was the contractors who made it to get it defeated. Why? Bad quality, bad intentions, cutting corners, disregarding standards codes, greed, ignoring quality checks, laziness, lack of confidence, not following good practices, unsafe structural provisions. Next. The development of appropriate technology for quality, affordable, sustainable buildings has to pass through various stages of improvement. Production process, execution process, quality control, cost reduction, durability, safety, ease in implementation, and then finally acceptance by community. Continuous R&D is the key factor for sustainability of any technology. Next. However, successful promotion and adoption of innovative technologies require enough time to prove durability and advantages compared to existing ones. Sometimes it takes decades before they are widely accepted. Although several examples of projects with new materials and technologies exist in few cities only, however, they are yet to be recognized as norms. Next. We come to the affordability because this is the part which is important for any new technology or for any technology, new or old. No alternate technology is successful unless affordable. Affordable to the contractor, affordable to the client, affordable to the user. It is important to understand the difference between low cost versus cost effective construction. It is possible to produce low cost buildings but with compromised quality. Conversely, cost-effective buildings are produced with economy, yet maintaining high standard of quality. That is what should be our aim. Next. Yet there is a bright side. And this is all pessimism that I have shown, but there is a bright side. What? There are 6 key lessons for achieving success in alternate, innovative, prefab, precast technologies. Lesson 1. Overcoming resistance. We are all players in the game of technology. It is not the skill only, it is the game spirit, will, commitment, and courage that wins the game. Changeover from conventional is not a zero-sum game. It has to be a shared endeavor. Together, we have to overcome the resistance and win the trust of the people and the society to whom we intend to serve, and for which there are many success stories too. जैसे LNT वालों ने अभी दिखाया सक्सेस स्टोरीज का. Lesson 2. Persistence and patience. Continuous persistence does pass the obstacles and open the gate for possibilities. If you truly believe in something, go for it. The worst that can happen is failure, and even that comes with lessons to try harder and with further as a smart person. Do not surrender to fate. After a single failure, failure precedes success. The successful people known are those who have known defeat, known suffering, known struggle, known losses, and have found their way through persistence and patience out of the depths. Lesson 3. Quality deliverance. Dispel the wrong notion. Affordability does not mean low quality. A building is beautiful and useful only if it is practical and within affordable limits. Irrespective of financial status, even the poor also aspire today for dignified living. Many of the social EWS and LIG housing schemes, despite offering subsidies by the government, have failed to take off due to bad design and bad quality of construction. ये हमारी इंडियंस की एक हैबिट है, जिस हैबिट को हमें चेंज करना है. नो चलता है. क्या होता है आज की डेट में, जो भी कुछ काम करो सब चलता है. ये हैबिट जब तक चेंज नहीं होगा, ये क्वालिटी नहीं आएगी हमारे यहाँ ड्यूरिंग कंस्ट्रक्शन. Lesson 4. For achieving the objective using alternate technologies, the lesson 4 is quality does not come only with machines and investments. We have to overcome the attitudes and mindsets of all players. Yet, there are challenges. The survival of any technology rests on delivering the quality product, it is the house or any building. The biggest takeaway is the mindset of our own taking bold steps. This is for entrepreneurship, for those children today who wants to become an entrepreneur or want to start the startup. What an entrepreneur would need to start a venture. First thing is knowing your product. Product is what? Technology, better than anyone else. खुद को ही आपको experience नहीं होगा, खुद को ही knowledge नहीं होगी, you cannot deliver anything. Understanding unique demand of the country's market. Know your customer's pocket and their aspirations, and a burning desire to succeed with no ifs and buts. To our professional friends, architects, engineers, entrepreneurs, and students, innovation, this is another problem. Everybody says innovation means invention. No, innovation does not mean invention. Do differently what others do. Incidentally, you will still be watching your own reflection in mirror. This is a slogan. Turn the mirror into window with values like patience, dedication, belief in your hard work, and the importance of doing things the right way. That looking for shortcuts, you will find impossible becoming possible. Next. The greatest of all lessons is, the questions may be so many, but the answer is one. Passion with positivity. But there is a caveat. मकान ऐसे मत बनाओ कि लोग फरियाद करें. मकान ऐसे बनाओ कि लोग फिर याद करें. Thank you.
Thank you, sir.
Yeah. I think Adlakaji, you just read 15 years of my life. In Precast. So, thank you very much. Appreciate all your comments.
Yes, we now have come to the end of our panel discussion. Thank you very much, the distinguished panel members and the esteemed moderator, for such an engaging and thought-provoking discussion. Today's panel has given us valuable insights into the opportunities, challenges, and future direction of precast construction in India. I would like to express our heartfelt gratitude to Mr. Amit Burde, Head Precast Initiatives Larsen & Toubro, for sharing his extensive experience in implementing precast technologies in large-scale residential and infrastructure projects. Our sincere thanks to Mr. Pramod Adlaka ji, Managing Director, Adlaka Associates Private Limited, for highlighting the immense potential of prefab and precast technologies in delivering affordable, efficient, and sustainable housing. We are equally grateful to Mr. Ashish Pipal, Scientist E, CSIR CBRI Roorkee, for sharing his research expertise and practical experiences on sustainable and affordable housing through precast technologies. On behalf of the Department of Civil Engineering, JSS University, Noida, I extend our sincere appreciation to all our panelists for generously sharing your knowledge, experiences, and vision. Your participation has undoubtedly made the panel discussion, one of the highlights of Precast India 2026, the online summit. Thank you once again, sir. From here, we further move to another technical session by Mr. Ashish Pipal. Mr. Ashish ji, welcome again.
Thank
Mr.
you.
Ashish Pipal is going to give us insights on case study, utilization of precast technologies for affordable and sustainable construction in rural housing. May I now request my colleague, Dr. Vaishnavi Bansal, to give a brief introduction of Mr. Pipal to all of us.
Good afternoon, everyone. Am I audible? Good afternoon.
Maybe your voice is too low.
Good afternoon, everyone.
Yes, you are audible.
Myself, Dr. Vaishnavi Bansal. I'm from Civil Engineering Department, JSS University, Noida. I feel a great privilege in inviting Mr. Ashish Pipal as a distinguished speaker in today's summit. I'll give a brief introduction about him. Mr. Ashish Pipal is principal scientist at CSIR, Central Research Institute, Roorkee, with over 16 years of experience in geotechnical engineering and research. His expertise spans landslide early warning systems, climate resilient and disaster resilient construction, traditional buildings, and affordable housing projects. He has authored 7 books, including Kavach, Rudraksh, and Good Construction Practices, and made significant contributions to Pradhan Mantri Awas Yojana Grameen through the Rural Housing Compendium Pahal, which has influenced housing development in 13 Indian states. Mr. Pipal is currently developing a national version of PEHEL to cover all states and UTs, and is actively engaged in projects of national importance that focus in research, quality construction, capacity building, and technology demonstration to advance the housing and educational sectors. Sir, we are delighted to invite you as a distinguished speaker for our summit. Your valuable insights and expertise would greatly enrich the session and benefit all the participants. We welcome you, sir.
Yeah, thank you. Can I share my screen now?
Yeah, sure. It's visible.
Please. Thank you.
So you can share this.
So, is my screen visible?
Yes.
Yes, sir.
Yeah. So, good evening, all, and thank you for inviting me here and letting me share my thoughts on this topic of precast technologies, how they can be utilized for the sustainable and affordable construction of in the rural housing sector particularly. Now, as recently we discussed even in the panel discussion that the a challenge in the precast system or the promotion of the precast system is one of the biggest challenge is cost. And rural housing sector, in particularly in our country, it is very tricky to play because majority of the beneficiaries, if you look into the PMAYG scheme, majority of the beneficiaries of PMAYG, they don't even have land, they don't even have any kind of shelter available with them. Many of them resides in the huts which have this thatch roof and all those kind of systems, which, so again, expecting these people to spend a lavish amount on the precast construction or any kind of construction which ultimately requires a huge amount, that cannot happen. That is something which just cannot that is not practically possible. And so ultimately the main trick is how ultimately we can provide them with a house which ultimately is cost effective, affordable, sustainable, and at the same time it can be constructed within a minimum amount of time. So ultimately in PMAYG, with the help of Narega, they get timeline of approximately 90 days to construct their house, and few of the states in that provide a benefit or the additional amount if they complete it in an early time. So let's say in 45 days, if they are constructing their house, they ultimately get some bonus to construct the house in a reduced timeline. So that's how this PMAYG part plays. So we have to be very cautious when we talk about the rural housing sector of our country. It is very, very sensitive, very economically sensitive, as well as the safety also plays a very major role in these kind of housing scenarios. So just to start with, I would like to provide a brief aspect of how the rural scenario in our country persists. So if you look into the data, it's basically approximately our population is somewhere around 147 CR in 2026 approximately. There are plus minus some figures are there. Apart from this, we have population centers in rural which is something like 6 lakhs, and urban is just 7,000. So the population center, if you look into, 6 lakh is to 7,000. That's the huge gap that we are having. And along with that, majority of the population, like somewhere around 69% of the population of our country resides in the rural areas, and in urban it's just 31%. So we have to take care of not just these 31%, but also of the 69% that ultimately is living in our country. And as Mahatma Gandhi also had said, that the heart of India actually lies in the villages. So we have to think of these people, the rural people of a country, and how they can get safe and sustainable houses which look aesthetic, which look good, and that the houses which they can call as ghar, not just as makan. So that, with that philosophy, we have to look into these aspects. And along with that, definitely they have they provide a GDP percent of 40% in the contribution of GDP of the rural India is approximately 40%. So yes, we have to look into all these aspects, and at the same time, how we can support them in the upliftment of the betterment of their lifestyle. So there has been a paradigm shift. Recently it is happening, it has happened. Majority of our hill villages are now has been declared as ghost villages because no one resides there. And this is why this is happening, because ultimately majority of the facilities that was supposed to be there, still the government is working day and night to generate facilities. Now the road connectivity is really good, the people are getting the schools are getting open, the opportunities are getting created. So yes, the things are getting slowly adjusted to the pace, but yes, there's a huge way to go right now. The various reasons that we can talk about of the migration is, again, the work employment, businesses, education, marriages, move because of birth, because of the household, and all those kind of aspects. So ultimately, these are a very big reason for the migrations, and ultimately these are impacting the urban scenario of our country, which again is building the overpopulated cities that we call we simply call our cities as overpopulated or overcrowded, but ultimately it's we who is the crowd. So we have to think about that aspect as well. We ultimately want to live in those cities because opportunities are there according to us, and that's how these populations are gaining into the urban scenario. And then there is environmental degradation, because ultimately if we are we are encroaching the city limits, that ultimately environment has to pay a price for that, and that ultimately is onto us. And then there's a decline in food production. No one is there to grow the food. Unemployment, ultimately people who has got shifted from rural to urban, they are unemployed, and they are trying to earn their bread and butter to how they can survive in this. And that's how, and ultimately is the decline in education and healthcare, or the living condition of these people. So ultimately we have to think that how we can provide a better living condition to all these people in the rural area itself, so that they don't need to get out to the urban scenario. And then cities can stay less populated, they will get a better living conditions, the food production will increase, the environmental degradation will reduce, and ultimately our planet will sustain. So to create a sustainable environment, particularly in our rural India or in our country, we have to think about the improvement of quality of life in rural India. And one of the biggest part that plays in this quality improvement is ultimately the housing sector, because there are three basic needs of any individual. It's basically that the one that we call as roti, kapda, and makan. And so makan plays a very major role in the quality of life for any individual. So the contribution that prefabricated buildings that can create for particularly for the rural sector is in terms of education, health, housing, agriculture, farming, and employment generation also. So how we just when we talk about the prefabrication, typically we talk about how the buildings can be created, or particularly the high rise or whatsoever we talk about. We simply talk about the either the offices or the apartments or houses. We don't really talk about that. Yes, educational institutes like schools and sanitation infrastructure can also be created with the prefabricated system, and people are working on that. As I recently said that the NIT Goa campus, that has been that is a completely prefabricated structure. So people are working in this direction as well. Then we can have health centers, wastewater and sanitation. So during the COVID time, in CPRI, we constructed more than 12 healthcare centers with approximate total bed capacity of more than 500 beds for the COVID hospitals. So healthcare centers can be created, particularly in the time of disasters or the pandemic kind of situation, when the time is the key. At that time, these kind of prefabricated structures can do wonders and can really help in saving of the lives of the people of a country. So that is one thing that ultimately the prefabricated infrastructure can help people. And then again, ultimately it's the housing. So people can get pakka house with wastewater utilization and sanitation facilities, which are the basic needs that are required by any individual to survive and live with dignity. So that is something which is again there. And then for the agriculture sector also, we can think about the green storage or the cold storage or even the processing centers, which ultimately can bring prosperity to any village or the rural India. So that again can be think of. And farming, yes, it can help in the improved cattle sheds or the milk preservation centers. So that's how the prefabricated structures for those kind of aspects can also be created. And then ultimately we can create the employment generation by production of building materials and components. So we can create a localized economic self-sustainable zone, which ultimately can adhere to the needs of the local people or the rural people, and then they can easily survive on their own. They don't need to go out to the people asking, okay, they in the urban scenario, that is one thing which I have to get from a city or something. They easily can survive on their own in the rural area itself. So that's how we can help with the prefabricated systems as well. And ultimately, to address all these issues, we require scientifically designed buildings, scientifically designs training centers, and the infrastructure, which ultimately under government of India's mission people are doing. And but that required a short time and with limited resources and with an innovative approach. And there, actually, when we talk about a short time or with limited resources, that is where the prefabricated buildings or the precast buildings comes into picture, because they really can save time, they really can save resources if utilized properly. And then ultimately it can help in safeguarding the rural India in a very better way. So just to give you an idea that how the resources and techniques at present is being utilized in the various households. So if you I've created state-wise. So if you look into this is just for the roofs, that how the people are utilizing the material for the just for the roof construction. If you look into this, you'll find that majority of the people are either utilizing GI sheets, or they are utilizing simply RCC. In my recent encounter with when I was working with the Uttar Pradesh government, I had a word with the people of Gorakhpur. When I visited there, I was working for the construction of few of the demonstration houses there. And in Gorakhpur, people have a practice, since hundreds of years, they are constructing roofs of reinforced brick slab. But ultimately, when I talk to them about this, that you can construct the same roofs at your upcoming houses as well. Why you left construction of these houses? They simply denied, saying, "Na sir, आज की तारीख में ना RCC चलता है, and we just don't want to look backward by utilizing these RB slabs." So I asked them, but is there any problem with these slabs? So they said, sir, नहीं, problem कुछ नहीं है, हमारा मकान भी पिछले तकरीबन 60-70 साल हो गए हैं, but उसमें कोई ऐसी परेशानी नहीं है ये, but still we don't want to use it. Then I told them that ultimately the RB slab is much more thermally comfortable. Then they were like, we'll put a fan, there's no worry about that, but we want an RCC roof as only. So as recently Adlakha sir said, it is really difficult to ask people to change. People they will create hurdles. They won't accept the change very easily. They want their house to be exactly built as the house of a neighbor, that उसने ऐसा बनाया था, मुझे भी ऐसा ही चाहिए. Otherwise he'll think मेरे पास पैसे नहीं है, मैं गरीब हूँ, मेरा social status चला जाएगा, and all those kind of there are n number of reasons which they'll give just to showcase that I want this kind of construction. So, shifting of technology is really a tricky part. But yes, we have to look into that aspect, because ultimately it's not just that, this is the only solution, or RCC is the only solution. If you look into the traditional construction practices, they were more based on the local material requirements. Let's say in hills, we have a technology which is a traditional construction technique called as katkuni, or in Uttarakhand that is called koti banal. So that ultimately is something which utilizes just the stone and the wood, which is easily available in the hilly terrain. So they don't need to get somewhere else to bring some material and construct their own house. They were simply utilizing the material which was right there available with them, and they were constructing their house. And just to surprise you all, people who doesn't know much about Katkuni or Koti Banal, the oldest known, with the help of proven carbon dating technology, the oldest known structure that we have of Katkuni is more than 1,000-year old at present. And that's not a ground story or G+1 story building. That's a G plus 6-story building. So it's a 7-story building totally that is existing, of more than 1,000-year old, constructed just of wood and stone, that too without the use of any mortar or adhesive material. So that is the beauty of traditional construction. And right now we are talking that we cannot shift anywhere from concrete or the GI sheets and all. So we have to think of the alternative material, alternative technologies, and we can utilize the same in the prefabrication, and then ultimately we can do wonders for the from the sustainability as well as from the thermal comfort aspect. So the challenges for any building scenario right now, or particularly in the prefabricated scenario for the rural housing sector, is in terms of safety, functionality, sustainability, aesthetics, and economy. So people, when we talk about prefabricated buildings, people need to be sure that whenever I'm adopting a new technology, is it going to be safe? They have seen RCC as the RCC frame construction as something which is safe for them, or which is durable for them. So they want their house to be durable till at least they are there or their kids are there. So they want their house to be just like that. Can we provide them safety and durability, with the alternating technology or with the prefabricated technologies that we are proposing? If that is happening, we surely can, these technologies can penetrate. Functionality, whatever every rural every rural area of our country has a different mindset. You cannot think that a house which is being constructed in Uttar Pradesh will be having the same acceptability in the southern part of a country. That is not going to happen. Ultimately, the social aspect of every village, every community is different. So we have to look into that aspect, that we just cannot generate row housing in the rural scenario. We have to think in the functionality or the social acceptance aspect as well, and then accordingly we can do the space planning and utilization. And if that is happening, people surely will adopt, because if the safety and functionality comes in hand to hand, people surely are going to adopt these technologies. Then comes into picture the sustainability. So right now the government has a focus on how the building infrastructure can be more sustainable, how the carbon footprint can be reduced, how the global warming can be dealt with. And as we all know that cement, steel, these are really huge carbon footprint generating materials. So research definitely is going on. We are very much, we have solved the issues to a great extent by the research and development in the building material sector. But yet, if with the help of prefabricated optimization of the prefabricated buildings, can we do the help do the take care of the sustainability aspect as well? If we can do that, ultimately there'll be a great help. And then comes the aesthetics, and at last the economy. Ultimately, it's basically going to be the use of local materials as well as the use of optimized use of resources, and that's how we can help in safeguarding the economy or making the technology cost effective. And that once that is happening, once all these 5 parameters are in place, these technologies will definitely hit the ground and will definitely hit the rural sector of our country. So what we can do in these cases is something like the issue that we are having at present is in terms of, first of all, the raw materials. So we can think of the utilization of local materials, which can be in terms of stones, or the bamboo or wood or mud. Right now we can think of these materials, and surely these materials are being utilized to a great extent to reduce the carbon footprint, and can help in the sustainability as well as the climate resiliency and time. So prefabricated components can surely reduce time, and we can definitely utilize them for doing so. And then economy is ultimately the sections need to be optimized. We in plank and joist system, we use the T-beam action. Because of this, it reduces the thickness of the plank, and then ultimately it's the material reduces to half. So that is how we reduces both the carbon footprint as well as the cost of the system. And then safety, ultimately the use of seismic resilient features in any building, and or you can use a well tested technology which can ultimately safeguard the structure and can give us a sense of protection to the resident of these buildings. So to begin with, let me introduce you all to one of the product or one of the technologies, stone block, which is heavily being used in majority of the buildings where the brick is not easily available. Let's say and that is not just the case of any hilly terrain. It is also in majority of the plain area as well. Major of the plain areas, the cost of bricks is really high. In hills, in let's say in Roorkee, a brick costs somewhere in the range of 6 to 7 rupees, whereas in hills of the Uttarakhand itself, the cost of one brick goes to as high as 12 to 15 rupees. And ultimately that is where the economy comes into picture. If we are utilizing these bricks in the bricks which are being carried from the plain areas to hills, if we are utilizing these, ultimately the cost is going to be huge, and the building is not going to stay economical. So that's where the utilization of locally available materials or the stone comes into picture. In hills or in places where stone is easily available, people with the help of very thin or very economical frames, they can cast their own stone blocks, which ultimately are having strength to as good as the strength of any stone that they'll be utilizing. And this one block costs somewhere around 25 to 30 rupees and covers the area of 5 bricks. So ultimately, if I talk about the hilly terrain there, where the cost of one brick is, let's say, 15 rupees, then ultimately that for the 5 brick it's going to be 75 rupees, and the one block is costing on the higher side, it's costing somewhere around 30 rupees. So it's the half of the cost that I'll be saving, and the material which I'll be getting right next to my door. So this is one very good product, or one very good material, which ultimately can help people in reducing their dependency on the bricks, and can help construction a bit faster, because ultimately, with just one block they'll be covering the area of 5 bricks. So they don't need to place 5 bricks one by one. They simply can place one block, and ultimately the wall area of 5 bricks is covered. So this can hugely reduce the working time to construct a wall, and that's how the time that gets reduced is in the range of somewhere around 20 to 25%, and that ultimately is huge. If I talk about the construction of several houses, or the mass housing project kind of situation, this 20% plays a huge role, and the people can ultimately can construct their houses utilizing this. So there are several buildings that has got constructed utilizing the stone block. In particularly in hills, thousands or lakhs of houses have already got constructed, and people are still utilizing this technology. So the people can think of using this, and it has been in use since decades. So it's a time tested technology. CBRI itself has tested it in our labs. So it's a time tested as well as scientifically tested technology. So there's absolutely no issue in utilizing it for any kind of mass housing or normal house construction. Then the other one is RC plank and joist. Now, this is one thing that I was talking about. Adlakha sir has widely used this RC plank and joist. So, but in the for the urban scenario, yes, it has got some limitation. But in the rural sector, this particular system plays a very vital role, and it is very much popular in the rural housing sector. More than 10 lakh of houses have got constructed utilizing this just in the state of Odisha. So this is one thing where very thin section in the this is a partially prefabricated system where the size is 300 by 1500 wherein just the reinforcement is just 3 6 bars in the longitudinal direction, and stirrups in the form of 200 center to center in the horizon in the other direction. And then this has a thickness of just 60 where if I'm going to construct RCC roof, it is going to have a thickness of minimum 100 whereas this thin section is having a concrete thickness of just 60 and again, as I just now said, it is having a reinforcement of just 6 So ultimately, there's a huge reduction in the terms of reinforcement. There's a huge reduction in terms of material, and these ultimately can reduce the material requirement to as high as 30 to 35%, which ultimately brings down the direct cost in the same proportion. And along with that, it helps whenever the wall is getting constructed, a person can cast the RC plank at right next to their house, and once the wall is complete, he immediately can place their RC plank and joist at the wall level, and then they can the roof can easily get constructed without utilization of any kind of shuttering. So ultimately, the cost of shuttering is also reduced here, and that's how when we talk about the cost as well as the time, both comes here into picture, and ultimately the optimized section helps people in reduction of time as well as reduction of cost. So it has been designed in such a, if you have a look at the section of this particular plank, it is designed in such a way that it remains completely, because of the T-beam action, it remains completely in compression. So the dependability on reinforcement is reduced to a great extent, and then because of the T-beam action, the joints does not get open. they comes close, and that's how the water tightness also remains in place, and ultimately the system works just fine even in the places where the high intensity rainfall happens. So that's how this ultimately plank and joist helps in the rural sector in the construction of a roof. So the next thing is a prefabricated brick panel system. So a brick panel system is particularly suitable for places where bricks are easily available, but they want the reinforced brick slab in the form of panels, and ultimately they want to save time and save cost. They don't want to put their cost onto applying shuttering and all. So at those kind of places, these prefabricated brick panel system can be easily adopted, and these brick panel system can also be utilized in the form of a wall. So for the walling also it can be used, and for the roofing purpose also it can be utilized, and it ultimately helps in the reduction of the time as well as cost to in the range of approximately 20 to 25%. So but the limitation is that whenever you are going to design your house for with both these technologies, that when you're designing your room sizes, you have to design it as per the requirement or the criteria of sizes of these panel systems, whether it's RC plank or brick panel. You have to design the room size in multiplication of these panels only, because ultimately otherwise they won't get fit in the room size, and then that will be something which ultimately will create a problem. So during the initial planning time itself, you have to think of that if I want to utilize this technology, we have to plan the house accordingly, and then everything rest is just fine. And ultimately this brick panel system can help in lowering the temperature of the roof, and can make it a bit more thermally comfortable, as well as it is ultimately it takes care of the loading condition as per the Indian standard criteria. So that ultimately helps in constructing at a faster pace and at a lower cost. Then the next thing is the channel unit. If we want to place it wall to wall, then ultimately a channel unit can also play a vital role in construction of a house. So the people in rural areas can utilize a channel unit, which ultimately is we have divided the roof into multiple layers. So it's basically a waffle unit which has been divided into segments, and ultimately that is getting placed. So the thickness gets reduced. Ultimately it is a very very thin section at the top. It is just in the range of 30 to 45 thickness, and then over it you can apply the thickness of a deck concrete topping, which ultimately can fill the gaps and can make the roof robust. And this particular system helps in because it creates void at the top, so it ultimately helps in creation of a thermally comfortable environment as well, and can ultimately reduce down the cost and saving in the material aspect as well. Then there's Alpan. Alpan is something which is very similar to any the sloping roof that we construct, particularly in the areas where yeah, the rainfall is really huge. So high intensity rainfall areas where sloping roof is required, the Alpan can be created, and these are thin sections which can be placed one over the other, and ultimately it creates a sloping pattern. The same Alpan can be utilized for the prefabricated staircase construction as well, and similarly it can also be utilized for the prefabricated the chaja portion above any the window or the door slab. So that is how the Alpan can be utilized in any of the housing project. And ultimately you can construct your wall utilizing stone blocks. You can construct your roof using brick panel or RC plank and joist. You can construct your projections and your staircases utilizing Alpan, and ultimately these small prefabricated sections we can help in in easy construction of a rural house, and then the partially prefabricated segments can construct a fully developed rural house. So this is how the alpine, if you look at these photographs, this is how the alpine get placed, and ultimately it creates a sloping roof for any house that is required. And then at the same time, the wastewater disposal system also can be constructed using the prefabricated technology. So a prefabricated wastewater disposal system in any rural house, there are two kind of wastewater that get generated. One is from the kitchen, the other one is from the bathroom. So so either they have the oil that need to be filtered out, or the soap, or the greasy material. So in for both these kind of materials, this kind of the wastewater disposal system can easily be prefabricated. It is a prefabricated system, and simply you can dig a hole of the requisite site, and then it can be lowered down and can be connected with the drainage, and ultimately it will start functioning as the wastewater disposal system. So the issue of sanitation in any kind of rural area, that also can be tackled down very easily if this kind of wastewater disposal system is being utilized in the rural house, so on the rural area. So the benefit that ultimately we gets from these kind of prefabricated systems is ultimately the direct costing is in terms of let's say approximately 25 to 30% direct costing that we get. There's a breakup also I've given, that how the RC plank, how much cost saving and time saving they provide, and how much is the energy saving that they provide. So and a brick panel roof is in the range of 25 to 30%, whereas the time saving is in the range of 70 to 75%. So they ultimately can help in the reduction of direct cost, material saving, time reduction, and ultimately if I'll say that there's an energy saving of 20 to 60%, there is a saving in the carbon footprint also. So it is in the range of 20 to 30%. The carbon footprint also gets saved, and ultimately once these products easily can be casted at a rural level or a local level also, where the person can generate his own business utilizing these kind of prefabricated systems. So ultimately it will boost the local economy, and ultimately there will be employment generation, and there will be a self sustainability in the rural areas. And ultimately with these proven technologies, as I already said, lakhs of construction already has been accomplished. And as you've seen in the RC plank roof, approximately 50% of the material cost directly was happening. So 50% reduction in material directly adds to the need to the requirement of the reduction of energy to 50% there itself. But again, there will be like the screed concrete that you're putting and all. So ultimately the energy here, it is being shown that it is 20%. That is because of the reason that at the top sometimes people apply the waterproofing coating, the base coating, and then they apply the flooring as well. So that's how the energy saving gets reduced. But ultimately if you're not going to do that, then ultimately it's in the range of 30 to 50% of the energy saving. So the way forward in this kind of technology can be in terms of ultimately we are in CBRI, we have demonstrated the world's first, or India's first 3D concrete printed rural house as well. I guess Mr. Ashish Kapoor might have shown this in the morning session. So we have constructed a rural housing, a rural house which is 3D concrete printed, and ultimately we are utilizing the energy ratings also for the construction of rural houses. And we are, with the help of Ministry of Rural Development, working in the field of AI and VR also, how the artificial intelligence and virtual reality can be integrated in the Avasoft app that runs for the PMAYG scheme, how that can be integrated, and how the rural housing sector can be made more robust, more tech friendly, and how the people can, before the construction of house, can easily understand how their house will look like and how it will function, and they can choose how, what kind of typology is required for their house. So all those kind of things we are integrating with the help of Ministry of Rural Development, and soon these things will be out in the field for the benefit of the people. So I guess that is from my end, and I'm open to questions. So thank you so much.
Thank you so much, Mr. Ashish Pipal. Your case studies demonstrated that technology can play a transformative role in rural housing by delivering faster, economical, and sustainable construction solutions. The practical experiences and innovative approaches you shared have provided a valuable lessons for all of us, especially our students and young engineers. We sincerely appreciate your time, contribution. Thank you so much for sharing your experience, sir.
Thank you.
As we have come to the concluding part of our online summit on Precast India, may I now request my colleague, Dr. Amit Tripathi, to please share a vote of thanks.
Thank you, Jyoti ma'am. So, respected dignitaries, distinguished speakers, honored guests, faculty members, dear students, ladies and gentlemen. As we conclude today's inspiring summit, it is my pleasant duty to propose the vote of thanks. On the behalf of the Department of Civil Engineering, JSS University, Noida, I extend our heartfelt gratitude to all who have contributed to the success of the Precast Summit 2026. First and foremost, I express my sincere thanks to our distinguished speakers, Mr. Satyam Agarwal, Senior Engineer, Mr. Pramod Adlaka, Managing Director, Adlaka Associates Private Limited, Mr. Ashish Kapoor, Senior Scientist, CSIR, CBRI, Mr. Amit Barde, Head Precast Initiative, L&T, Mr. Ashish Pipal, Scientist E, CSIR, CBRE, for sharing their expertise, practical experiences, and valuable insights that greatly enrich today's summit. I also extend our sincere appreciation to all the esteemed panelists for an engaging and thought-provoking discussion that highlighted the future of precast construction in India. My heartfelt gratitude goes to our summit chair, Dr. Jagdish RS, for his constant encouragement, guidance, and inspiring leadership. I express my sincere appreciation to our convener, Dr. Ruchi Saraswat, Head of the Department Civil Engineering, whose vision and support made this summit possible. I also thank the university leadership, including our Honorable Chancellor, Vice Chancellor, Registrar, Deans, HODs, faculty members, and administrative staff for their unwavering encouragement and support. A special word of appreciation goes to our organizing committee, student volunteers, technical team, media team, and staff, support staff who work tirelessly behind the scenes to ensure the smooth conduct of every session. Finally, I thank all the participants, faculty members, industry professionals, researchers, and students for your enthusiastic participation, thoughtful interactions, and commitment to learning. Your presence made this summit truly meaningful. We hope the knowledge exchanged today will inspire further innovation, stronger academia, industry collaboration, and continued efforts towards building smarter and more sustainable infrastructure. Thank you once again. Have a good day to all.
Thank you, Ashish Pipal, sir.
Thank you, Dr.
Thank you.
Tripathi.
Thank you.
One last thing, but not the least, I request all the participants, including the students and academicians, to please give a formal feedback. The feedback link has been shared in the chat box. Thank you, one and all.